Hello， 大家好，我是波特，祝大家圣诞节快乐！天气这么冷，就是宅在家下棋就对了。而且今天晚上呢，主播如果还有体力的话，就可能会开台，可能。继上次介绍了 13.24B5 打上分神之后呢，今天要来介绍的是双星处刑双 C， 有多难念的，但真的很强。这部是特地邀请我们 DLC 团队的 Terry 所带来的，大家可以去追踪一下他的退取实况，那也可以顺便追踪一下我的，因为我最近都会很勤来的开台。这套啊是属于一个比较冷门的特殊玩法，因为只有在选到双星恐惧的时候才会来玩，所以呢比较难撞正一点哦，就是你完全不可能去铁头玩的，完全不可能哦，一定是刚需双星恐惧的这个增幅装饰。那我们有非常多的会员啊，还有 VIP 就是用了这套阵容冲了非常多分，蛮多人都已经上了翡翠钻石甚至大师，所以如果你有想要收到这类的战旗资讯，欢迎加入我们的 YouTube 会员。今晚还会再分享一套隐藏阵容给大家。当然最快上分的方法还是找人1对1教学了。如果你是大师以下的玩家，我能保证你教学绝对是能有所收获的。至少我们已经带领了超过10位的学员爬上大师了，并且这个月我们教学也接了超过200场，真的是非常感谢大家的支持。好，首先来介绍一下双星恐惧这个增幅装置，就是呢你刚好部署2个相同的英雄的时候，你就可以触发这个增幅装置的效果，所以你要记得上2个相同的英雄，这2个英雄呢就会都增加250的生命以及攻速还有暴击率。它有分为金色跟彩色的，数值是不太一样。当英雄升到3星的时候呢，你还会再获得它的2星该英雄，有点类似以前的双胞胎，但是以前的双胞胎呢，它是比较偏向全属性加持的那种感觉，就是坦克也能用。而现在这个双星恐惧啊，它是给爆率还有攻速的，就会比较适合后排的输出。而且这个属性的加成呢，非常契合处刑者这类有吃爆率的英雄，能够很好让你技能的爆率拉满，非常变态。目前呢最推荐的双星玩法就是阿姆姆直接上2个，还有潘森，以及搭配上图奇还有维克斯，基本上会是2守护、2摇滚、2处刑、2朋克。这套双星处刑双 C 是非常好克制当前版本一些强势的斗士阵容，像是雅宁啊、贾克萨杰以及阿卡丽等等的，因为顺伤实在是太高了，所以就很容易让他们的前排就地融化。我想应该蛮多人对维克斯跟图奇都不太熟，所以这边要来简单介绍一下，就是他们的一个技能。好，主要呢就是维克斯它带有晕眩的效果，并且是晕眩 1.5秒。最重要的是呢，它是对1格内的敌军造成伤害，所以它是一个范围技能的角色。再来呢就是图奇，它也是一个范围技能的角色，不过它是吃误伤的。在玩这类范围技能的一个角色的时候呢，我们可以靠单顶前排，或者是说将角色放置在中间的位置，来让技能最大化它的范围伤害。出装的部分我可是可以去出精进、死帽、破防者、红 buff、法爆以及巨杀。比较推荐的3件套呢，就是精进加上死帽以及破防者。而且在玩这类属性英雄的时候呢，最好就是要保证自己有暴击装备，所以这也是为什么蛮推荐去出破防者的一个主要原因。而图奇的话呢，你则是可以去出红 buff 啊、俄语以及无尽。阿姆姆则是可以去拿噬性神盔啊、石像鬼、星火、坚定之心、好战等等的一些坦型装备。比较推荐的一个出装顺序呢，就是最好要先有一个启动装备，因为维克斯的技能呢是75魔，这种魔长的角色呢都会很吃启动装。接着呢就会比较推荐星火跟破防者这样子的一个装备。这种蛮注重降防的，因为它的爆率还有伤害都已经拉得非常高了，所以如果你有一个降防的话，就能最大化你整体的一个伤害效益。毕竟你也有2只的一个维克斯嘛，所以如果你是主养维克斯的话，就蛮推荐你出完精进之后呢，就先去出一个降防装备。这部装置必备的呢就是双星恐惧，而且它比较通用的就是助攻碑文啊、理想主义以及治愈灵球，可以拿3战力的增幅装置，或者是说时候你只需要花1块钱，所以经济的增幅装置只有在一些特定的时候才会去拿，就是如果你拿了，然后你可以更快或者是说及时的就来到3星，或者说你可能真的是缺很多张牌才会去拿。主秀比较推荐的就是图奇、维克斯以及阿姆姆。玩真正的先决条件的第一个就是拿到双星恐惧，第二个就是最好是2之1就直接选，否则呢你有可能就是有时候没有去留牌嘛，很难突然转过来玩这套阵容。接着来讲到阵容过渡部分，这套呢是一个2-3费的赌狗阵容，前期保血量或者说连败都是可以的。如果你是打连败的话呢，前期可以不升等，最大化你的经济，优先去拿精进啊，还有星火， 还有破防者这一些组件。假如你是保血过度的话呢，则是可以在2之1的时候去升上4等。4等的话，你可以先去组出的就是2庞克、2守护的羁绊。如果有看到金克斯还有凯能的主秀呢，都可以拿来去过渡。因为我们这套阵容不是要赌金克斯，所以基本上前期是不会去刷牌的。所以你看到那些庞克1块钱的福利呢，要记得忍住，先不要刷牌，等到2之5的时候去升上5等。5等的话就是可以去补上山娜，凑出2宿舍的羁绊。3之后再去升上6等。6等的话就是可以再去补上相同的角色，记得优先去补后排的角色，因为你能够享受到更好的攻速还有爆率加成。如果说今天血量真的是低到60以下，那这个时候呢，你在6等就可以去更换你的主秀了。你在6等低排的时候呢，要有的一个观念就是我们就是要来低2费的主秀，而不是3费的，除非你是选到好戏上场。好戏上场这个区域就是你会拿到高1级的主秀，所以除了好戏上场之外，我们在6等呢通常都会比较偏向2费的一个赌狗。这个时候我们要去抓的就是图奇这只角色，但是玩图奇的话，它的
打造宝宝统合学习力，瑞士研发全新 S20。
上限会是比较低的，毕竟它就是个2费卡嘛。但是有的时候你在打连败，本来血量就很低很低，这时候你的容错是比较少的，你就会比较被迫去玩这种更低费卡的角色。而当你今天真的确定就是要来玩赌图奇，或是确定更换主秀的时候呢，你都可以每回合使用这个庞克1块钱的福利机制来去刷新商店1次，就是尽早的去拿你的相关体系牌起来。而且我发现有些人不太懂庞克机制，庞克这个东西，如果你是玩金克色的话，你前面就是得低牌，而不是去存钱，然后等着3之1的时候才去一次低干。因为呢，庞克它给的加成是非常多的，它会直接给3%的生命还有攻击力。你每次花这1块钱的，都是来帮你的图奇还有攀升提高它的一个上限和伤害。接着4之1的时候可以去升上7等。如果说你今天是要养维克斯的话，那这边是得去大刷牌的，因为这里呢会是你的一个转正时机点。在7等的话呢，你也比较好去刷到维克斯还有阿木姆这2张牌，然后去组出一个2情绪摇滚的羁绊。在7等大刷牌呢，主要就是要去追3费的一个赌狗英雄。所以如果你是在这边才更换主秀的话，就一定得去选阿木姆或者说维克斯的主秀，这样呢你的上限是会比较高的，而且你都已经忍到了7等，就不要去将就那种2费的主秀了。比较需要注意的是呢，我们要在4之1的时候去补出阵容的质量，至少要把4只英雄刷到2星，才能够比较好锁血，接着你才可以去回存经济。等到回血之后呢，你就可以每回合存40到50的一个经济量，慢慢的去追出阿姆姆还有维克斯来到3星。最慢要记得就是5之1前的一定要刷出1只角色来到3星。除了潘森之外呢，我们的其余英雄都是要去追到3星的。他们都3星之后呢，我们才会去考虑升上8等。所以这套阵容呢，其实它的思路跟萨米亚有点像。萨米亚呢，也都是那种3费卡很多的阵容。那这个时候我们就得去卡在7等刷牌。就是这一些观念呢，我都有放在从零到精英的那部影片。所以如果你对这种观念类型很不熟悉的话，真心推荐一定要看。新手玩家可以善用播放清单去找到新手适合的影片，就是你不只要学阵容，也要学观念，两者结合在一起，它才会是更好上分的。好，升上8等之后呢，我们就是要根据主秀的一个羁绊，选择去上4守护，或者说4摇滚，还是说4处行者。接着再来提醒一下摆位的一些细节，就是我们后排的输出呢，记得就是站在第4排中间的一个位置，因为呢，我们的维克斯还有图奇，它都是范围的技能，可以把他们2个呢想成是珊娜或者说亚菲利欧这种范围类型技能角色，你就会很好理解了。因为如果他们站边边的话，他们有可能技能只有命中就是1个人或者说2个人，而你站中间的话呢，是可以命中至少3个人或者说1群人。阿姆姆呢，则是要记得单顶在第1排，让敌方的前排都能往我们的阿姆姆靠近去包围他，这样你就可以让图奇还有维克斯的技能打到更多的敌人。接着依靠图奇还有维克斯处刑的一个伤害联动，就可以达到快速清场的效果。再遇上贾克斯拉、雅宁还有杰阿卡丽这种斗士角色，也就是跟他站同侧直接秒杀他，而且维克斯呢，他还有控场效果，就算杰啊他有夜色好了，他都能够把夜色瞬间打掉，秒杀这一种斗士角色。 这一场的话呢，在3-2的时候，其实 Terry 就有抽牌了。为什么？因为他这一场的区域是好戏上场，所以大家不要误以为说他是在3-2要抽突棋，他其实打连胜保险这样子的一个方式，他是想要去抽到3费的主秀的。所以可以看到的事情是，他身上7等之后，他就在找维克斯这一张牌的主秀。那他抽到的是情绪摇滚，并且拿下了英雄礼包。英雄礼包你拿的话，就是要赶快的在4阶段尽早来到3星。其实刚刚在打这种阿卡丽啊，然后你会发现，这个维克斯他只有2件装，而且前排没有星火的状况下，其实是会打的比较吃力的。那我们这边可以看到对面的话，它其实已经是基本成型的这种8-4阵容，就是很多种超粉拼多多的体系。都会在可能4-2，然后比较赛一点的，可能4-1就抽一抽，然后就成型了。所以我们今天就是要越早3星去制裁他们。这里的话呢，也可以看到对面就是现在非常流行的星刚一者。星刚一者，很多人可能会觉得说，很容易下去，但其实这套阵容你没有办法去完全的否定它，是因为它的强度真的很高。只要你够熟悉的话，其实你越会营运阵容，它的上限就能够开得越高，就是你吞越久，它的上限就越高。那这边的话呢，就是先把一些不会用到的牌先放在备战区，然后看能不能抽个利息。像他这边就是全卖，然后吃利息。接着你就是要把你的阿姆姆也抽3星。在玩这套阵容，其实我也会建议大家最好去确认一下外面有没有同行。我所谓的同行是说，萨蜜拉其实也算是一个同行，因为萨蜜拉呢也会抢到阿姆姆跟维克斯这2张牌，维克斯可能会抢的少一点，但很多人的萨蜜拉其实会用阿姆姆当一个主要的坦克，所以还是要去根据就是该场的一个状况去稍微观察一下其他的玩家，尽量不要去撞阵哦。这里的话，因为阿姆姆他拿的装备就都是这种降防装，已经拿了一个均等法衣了，所以这里就是先给维克斯做一个死帽，不然阿姆姆其实是会太软。如果说今天可能有好战的话，那就可以再搭配一个星火，其实也是蛮不错的选择。星火这件装备在这套阵容的效益是非常高的，因为突骑它是一只混伤角，它的第一段伤害是物理伤害，第2段呢就是魔攻伤害，所以星火这个装备它可以让很多人都吃到它的一个效益，算是一个效益最大化的装备。然后你可以看到对面的唢呐他还在打这个，他还在补这个触手，还在补 OK 太开心了吧，这边直接爽赚了4连胜。这个就是这套阵容的一个强大之处，所以你会看到它的瞬间爆发真的相当的惊人，而且它还有控场效果。像对面的话，你看它已经是完全大成，应该算已经是稍微成型体的这种2星约瑞科能打赢吗？2发直接把它秒了，2星约瑞科。
Enjoy your meal.
All you need is now. Let yourself go, let the feeling show. Don't worry about anything right now. Only us here, if you don't love, yeah. Ooh, don't let anything make us lost. All you need is now. Give yourself away, see things with your eyes. All you need is now. Say what you decide, talk with simplify. All you need is now. Hold your hands up high, share the love inside. Now.
就这，哇，通常这种状态是就是2星约瑞科，然后又2星阿卡丽，接着这种沙五色的整体升到9等，其实成型度已经拉得非常高，可以在5阶段5费2星，其实已经算蛮赛的，哈哈。结果没想到是直接把他们秒杀了。有没有看到就是斗士的角色真的很怕维克斯？这种处刑者，其实大家也可以把它想成是萨米拉啦。萨米拉也很好打哑拧的，如果有常玩萨米拉的人，应该懂我在说什么，就是完全是可以直接把它给秒杀的状态。那对面的话，他差一折就3星了，这边能送他下去吗？剩4滴，那感觉有可能有伏笔哦。但有一个人有2星的主秀镜，好的。这个算是比较麻烦的，因为其实进后期，尤其是他有蓝 buff 这样子的启动装，我觉得伤害也很高。进啊，这只角色你就给他一个启动装，蓝 buff 精进这样子的启动装啊。如果没有的话，其实魔运也很强。然后再来就是再给他一个爆发装、伤害装，然后第3件你可以再打一个科强，其实是蛮不错的选择。这里的话呢，最好其实再做一件前排装，结果没有0，没有前排装哦。这边他的老鼠就是龟锁分裂，然后再加上正义，就是算给他多一个启动装备啦。那对面的话就是这种，就是大家很常会是84阵容，然后去升上9等，滑上来的，可以看到8连胜瞬间到手。其实阿姆姆3星的蛮慢的，大家应该看得出来吧？就是他在6阶段的时候才来到3星。那他拿英雄礼包，其实也是因为他的维克斯进的比较少。那这种状况下，你为了就是狗一名是一名，就赶快拿了吧，就别撑了。2、4、6、8、9，他感觉真的是9等数了一下他的人数，感觉是9等。好猛啊！他这个95阵容随便打，不过也是有可能是因为是景象，但我觉得能够打赢这个95大阵已经算奇迹了，因为通常这种主秀的镜啊，我觉得也偏难打，尤其是他唢呐也2星，他唢呐是有启动装的2星。OK， 这边有稍微闪摆一下，然后对位这一只基亚娜，瞬间先2发，先融化这个基亚娜，不要让他打装备。接着就来处理一下这个劫，这个劫偷得很好，不过也是很合理的，因为他有好运手套，对手有好运手套，所以他偷得很好，正常。那这里的话，前排装备有拿到吗？没有拿到，那就有点小尴尬咯。这感觉算是一个小失误。OK， 直接把它重做完美重做，太强了，神奇的操作可是对手也是一个神奇操作，直接在9等主秀5费的主秀到手了，好强！这就是精英的实力。这就是我们精英的实力吗？9等是一定要刷到5费主秀的，但是很可惜还是打不赢双星主星双 C， 实在爆发太高了，1秒就让他的前排就地融化。蛮多人在玩这套阵容的时候都会蛮偏向去突起，但是其实维克斯他上限是更高，因为毕竟他是一个3费卡，而且大家应该有发现一件事情，就是他只要2发，他就有办法秒杀那种5费2星的角色，不管是约瑞克2星，然后或者是吉安娜2星、杰2星、阿卡丽2星，全部都是直接融化的。中期的话，你不知道对到哪一个对手，那你就直接放中间。但是如果说这种后期的一个决胜圈你就最好去对位别人的姐啊，或者说基安娜、阿卡丽这一些都是前排的 C 位，在第一时间就直接控场他一手，并且可以多使用没有装备的突起和维克斯去防一下冲浪的控场，或者是说阿卡丽死哥啊这样子的一个体系。那今天片到这里喽，感谢大家的收看，谢谢，拜拜。
大家好，这里是穷奢极欲，一个离不开钱的频道。我们过去聊过日本的独居问题，不只是老年族群，就连许多年轻人也都过着极简主义的生活，有些人甚至发展成简居族。日本心理医生斋藤环从80年代中期开始看诊，在他的职业生涯中，斋藤注意到年轻的男性病患出现的频率越来越高，这些病患多半来自中产家庭，平均从15岁就开始抗拒出门，他们不去上学，不去工作，人际关系因此斩断， 类似的隐居行为多半持续好几个月，甚至长达数年，而他最终将这个现象命名为简居族问题。然而不只有日本有类似的问题，邻近的南韩简居族数量也快速增加，现已成为该国重大的社会问题，严重到南韩当局今年推出新政策，每月发放每人65万韩元的补助，希望帮助境内广大简居族走出家门，不管重回校园还是职场。而这也不免让人好奇，当前南韩的简居问题究竟有多么严重？南韩政府2023年4月宣布，将为9到24岁的青年简居族提供每月最多65万韩元的生活津贴，协助他们重返社会。当然，当局也祭出排富条款，避免高收入家庭分散掉政府的美意。南韩对简居族的官方定义，很大程度参考了日本，也就是待在家中超过半年，不上学、不工作、也不社交的个体。根据官方公布的统计数字，在南韩19到39岁的国民中，总计有35万名简居族，占总数的3%左右。进一步看向细节，南韩简居族中约有多达40%的人口，从青少年时期就开始过着这种与社会脱节的孤僻生活。由于常年背离常态的社交圈，导致他们最终很难再融入社会。看在南韩政府眼中，简居族的成因非常复杂，有经济困难、学校霸凌、心理疾病、家庭问题与健康状况等，而当局最终认为寄出基本的生活津贴将可以有效解决问题。除了给钱以外，类似的扶贫政策也被包含进青少年福利支持法，合乎条件的申请者可以获得一系列不同名目的津贴，像是参与演唱会或看电影这类文化体验，有人也可以用来治疗残疾、进行矫正疤痕等医美手术，或直接申请就业支援服务。南韩官方预估，全国约有30多万名简居族，但实际数字恐怕不止如此。根据心理学家与前简居族的说法，南韩这片土地上可能有50到100万青年简居族。由于境内简居族的问题一年比一年严重，南韩也跟这个名词的发源地日本密切交流。最著名的案例之一出自 K2 国际南韩分部之手，他们曾在首尔市中心附近的住宅区安排一栋3层公寓楼房，总计入住10到20名年轻男女，入住者都曾是简居族。在该组织的安排之下，他们恢复了团体生活，期间受到来自各方的鼓励，许多人都恢复正常上学，其他人也在安排下规律工作。这套做法是南韩从日本学来的方式。南韩官派协同的专家认为，日韩两国的社会结构相似，而日本在处理简居族的问题上拥有丰富的实务经验，也因此南韩应当借鉴日本做法，以此降低失败的风险。除了学习长处以外，南韩也参考日本失败的地方，以此用作反面教材来学习。不少专家更认为，日韩都面临人口老化与少子化的问题，而简居族的严重性也不断拉高。日本 K2 国际负责人目前正积极在南韩各地推动讲座，同时也接受简居族家长的咨询。他认为南韩与日本的状况惊人的相似，由于南韩社会竞争异常激烈，从小就深耕的门第思想更影响南韩年轻社群，因此许多找不到工作的年轻人，或是在学生阶段发展受挫者，很容易就龟缩家里，在想象的安全范围内生活，不敢踏出家门一步。虽然日韩民间曾有大规模的合作，但在2020年疫情以后，许多交流就此中断。像 K2 国际在南韩的分部，就在2021年底熄灯，回归日本本土活动。话说回南韩的简居问题，虽然政府规划了大笔预算，想用钱鼓励他们走出家门，但看在简居族眼里，当局似乎搞错重点。该国一名简居族成员朴泰宏就在今年5月接受 BBC 采访，他说有没有钱并不是年轻人简居的问题，政府每月就给这点钱，也很难把该族群拉出家门。朴泰宏表示，并非每个简居族都有经济上的困难，像他自己就在简居期间获得父母雄厚的经济支援。现年34岁的朴泰宏，从2018年开始接受外界协助，目前已成功建立起社交生活。在他口中，自己简居的原因源自家庭。朴泰宏表示，父母从他小时候就频繁吵架，适合的原生家庭连带影响到他的学校生活。从很早开始，他就觉得上学非常困难，最终朴泰宏不仅不出家门，还退缩回自己房间，过起了常年简居的生活。现年30岁的柳成奎也有类似的经验，他从19岁开始简居，之后虽然被迫当了2年兵，但一退伍回到家，却又继续过起简居生活。柳成奎的理由也跟家庭有关， 父亲常年督促他上大学，甚至连学科都自己决定好，而柳成奎根本不被允许讨论自己的未来。经过辛苦的高中生涯，柳成奎考上大学后1个月就申请退学，自此他被羞愧感击败。退回家中简居时，他甚至连走出房门上厕所都不敢，因为他不想撞见家人，不想看到爸妈的脸色。经过长年的简居，柳成奎终于接触到 K2 国际，也终于脱离简居的生活。当前的他正经营一间名为 Not Scary 的公司，为其他简居的年轻人提供支持。看到这里，我们大致可以理解为何南韩会有这么多简居族。该国一间专门研究简居的咨商中心，他们经手无数案例，最终发现绝大多数的简居青年都有一个共同点，他们自认无法适应南韩这种竞争异常激烈的社会，最终就一步一步退守，直到龟缩在自己的房间里。这个咨商中心的首席心理学家朴大令直言，南韩高度竞争的社会氛围以及疲软的就业市场带给人们庞大的压力，而冰冷的社会风气压抑人与人之间的合作关系，也阻碍了人们追求兴趣嗜好的可能。不管是校园还是职场，人们生活的无力感都直线上升，同时更伴随了失望与焦虑。朴大令表示，许多南韩年轻人常把自己比喻为在笼子里奔跑的仓鼠，为了争取优秀的伴侣、满意的工作与漂亮的车房，他们被迫不停奔跑，一刻也不敢停歇。因为不少人深刻地意识到，自己一旦停下来，很可能就再也跑不动了。而不少简居族就是已经停了好几年的人，他们又怎能跑得动呢？更糟糕之处在于，南韩社会对成功的定义非常严苛，那些不属于主流价值观的人，很容易就受到排挤，或直接被边缘化。有些人成绩不好，受到欺负。有人家里贫穷遭到霸凌，有人性格内向而被冷落。如果没有人适时伸出援手，或原生家庭没有及时协助，就可能恶化发展成简居族。总结来说，南韩简居族的问题非常严重，虽然主脉络类似日本，但该国独有的氛围更加剧了状况。当局虽然想砸钱救人，但效果恐怕不容乐观。至于未来会如何发展，就让我们继续观察。好了，这集的穷奢就到这里。穷奢精选今天带来17选12的优质美食套餐，其中包括热销的塔香3杯鸡、火腿奶油熏鸡、葱爆嫩牛柳、翡翠野菇鲑鱼等菜色。12包菜色，穷奢优惠价1650元。另外，4选8的优质汤品套餐也在热卖中。除了高人气的极品牛肉汤，还有杜仲生鸡煲、麻油鸡汤与黑蒜鸡汤煲。8包汤品，穷奢优惠价1650元，再加送4包劲道的刀削面。以上套餐全程低温宅配，优惠期间免运费。有兴趣的朋友，请到下方链接购买，下单后数天即可送达。如果喜欢我们的频道，记得订阅、赞好和分享。我们下一集再见，拜拜。
还在做
针对衰老因子 AT0，一夜紧致，2周烹弹。
Alexander Wang, Christian Dior, Cartier, Chanel, Gucci, Prada. Alexander Wang, Christian Dior, Cartier, Chanel, Gucci, Prada.
Coast to coast, I drop bombs on you motherfuckers.
Alexander Wang, Louis Vuitton, Christian Dior, Balenciaga.
We're going to be differentiating Lambert's W function. So in a previous video, I had integrated this function. So this function has some interesting properties. We'll talk about that. And in this video, we're going to be differentiating it. So Lambert's W function can be defined in many different ways, one of which is the inverse function for x times e to the power x. So if you have f of x equals x e to the x, then its inverse, of course, this is a multi-valued function. By the way, you'll see the graph in a little bit, can be defined as, well, from, Lambert's W function. Okay, in other words, Lambert's W function takes x e to the x as input and returns x as an output. So whenever you see something like x times e to the x or t times e to the t is our thing, by the way, it can be whatever, anything, then when you apply Lambert's W to this, the output is going to be t. Of course, depending on the branch of the Lambert's W function, you get different values. We're talking about real values here, but we're going to differentiate it in the general way. And I'll be presenting two methods, but before before we start that, I want to show you what the graph of it looks like. So here's the graph of Lambert's W function. By the way, you can graph this in Desmos just by graphing x equals y e to the y. Because normally, if you graphed y equals x e to the x, that would be f, and you're now graphing f inverse. Make sense? And of course, there's a breaking point, which is very important, which is at x equals -1 over e. And obviously, by differentiating, you can get that point. But notice that at that point, our function is kind of split into two pieces. So what happens is, if you draw a vertical line at x equals -1 over e, you're going to notice that it's actually tangent to this graph. So any x value between -1 over e and 0 is going to intersect this graph twice, which will give you more than one value. All right. Anyways, just briefly, I wanted to talk about Lambert's W function and its graph, and now we're going to go ahead and differentiate it. Now, I think this problem is pretty interesting because we're actually going to differentiate Lambert's W function without knowing exactly what it is equal to. Because, you know, for functions like sine x, we know if we have sine x and we can differentiate it, its derivative is going to be cosine x, right? We know explicitly what this function is. But in the case of Lambert's W function, we don't. But we at least have a definition which we can use. So let's start with the first method. Now, remember, Lambert's W function was defined as the inverse function. So this is going to be a helpful way to think about it. But also there's other identities. For example, this is one of them. Lambert's W of x times e to the power w of x is also going to equal x. Now, think about why this would work, and please write down your thoughts in the comment section down below. Hopefully someone can help if this is not clear to you. Anyway, so I'm going to start with this identity and differentiate both sides using the product rule. So how do you use the product rule if you have like a u times v, as suppose u and v are functions of x, and to differentiate it, you're going to do u prime times v plus v prime times u. So you're going to differentiate one of these, multiply by the other, and then differentiate the second one and multiply by the first one. Make sense? So without knowing what it is, I'm just going to write this as the derivative of w, which is what we're trying to find, by the way, multiply by the second function, which is e to the power w, plus the derivative of the second one. Now, we got to be careful. If you're differentiating e to the power something, we're going to use the chain rule. So the same thing, multiply by the derivative of the inside, which is defined as the derivative of the exponent, and of course that will be w prime again, right? So the derivative of Lambert's W function pops up when you're trying to differentiate a product, obviously. And from here, we're going to try to extract what it is, and it's going to be fun. Okay, so this is the product rule equals, what's the derivative of x? That's a good question. It should be 1 if it's with respect to x, of course. So you're talking about the x over dx, and algebraic, or however you want to look at it, this is going to be 1. Okay, so now what do we do with this? Easy. Just factor out the Lambert's W function prime or w prime, and then you're going to be getting, wait a minute, I think we messed up here. Hold on a sec. Okay, let's check.
紧急插播最新头条，这份机密文件指出。
我们一家人做什么都在一起，
但只要有一个人不。
So we were trying to differentiate it. We just differentiate this one, and then I'm supposed to multiply it by the first function, which is now Lambert's W, and that's equal to 1. Now, here we go. Now, notice that in this case, we have a common factor, Lambert's W, or W prime times e to the W. I don't want to take out both. I just want to take out W prime for obvious reasons, because that's what I want to find, right? So here, this is going to give me e to the power wx plus e to the power wx times wx. Make sense? So I took out the derivative of Lambert's W, and now I'm going to solve for it. So let's go ahead and divide both sides by the expression inside the parentheses, and that gives us 1 over e to the wx plus e to the wx times wx. Make sense? So far we got the answer, but we're not going to settle with this. We're going to simplify this further. And to simplify it, we're going to use the identity that we started with, which is kind of interesting, right? that identity gives us x, so this part actually equals x. Okay? So our expression even got simpler. W prime is equal to 1 over e to the w plus x. It's fairly simple, isn't it? So that will be the answer. Let's go ahead and take a look at the second method, because I think it's going to be more interesting, but you'll get to decide. So with the second method, I'm going to start with the original identity, which is w x e to the x equals x. This time I'm not using the identity I used before. And then we're going to differentiate both sides, but this time it's going to be implicit differentiation. What does that mean? Well, it's kind of like, or should I say, composition function, because this is a function of x and we're composing with another function. Anyways, no matter how you look at it, let's differentiate both sides. That's going to be by the chain rule, w prime x e to the x times the derivative of the inside, which is the derivative of x e to the x, which is by product rule, the derivative of x times e to the x plus the derivative of e to the x times x. You get the idea, hopefully. And of course, this is equal to 1 again. So now, I know this kind of looks like the first method, but notice we started with a different identity this time, right? And we're going to do something else. We're going to call this expression t, because I want to get the derivative of the function, and inside I don't really want anything composed with another function. I want w prime something, a single variable. That's why I want to switch to t here. Be careful. So we're setting x e to the x equal to t. And this has some implications, right? If you w both sides, w x e to the x is going to be wt. From here, x is going to equal wt. Because by definition, w, or Lambert's w of x e to the x, is equal to x. By definition, that's, hopefully you already know that, right? Great. So now we got the following. First of all, we have this expression right here. We're going to go ahead and isolate it. First, let me write w prime x e to the x equals 1 over. Now I'm going to go ahead and factor out an e to the x here. That's going to give me 1 plus x. So here's what I need to do. We call this t, so this is going to be a t here. And e to the x, what is e to the x? What is x? X is going to be w of t. Make sense? So I'm going to replace x with w of t, and of course the same here. So w prime of t is going to be 1 over e to the wt multiplied by 1 plus w of t. Now, does this look like the first answer? Let's take a look. Well, it kind of does, but with a different variable, but it doesn't matter. You can definitely replace, wait a minute. It's not the same thing, of course, because we still have to convert it. So what we're going to do is we're going to go ahead and distribute, because in this case, distributing allows us to simplify it. So we're going to get e to the wt times wt, which is going to turn into t by definition. Remember the first identity we used. So w prime of t is going to be 1 over e to the wt plus t. But of course, you want to stick to x, right? So let's go ahead and write this in terms of x. So replace all the t's with x. That's perfectly fine. And then this is going to be e to the wx plus x. So that's the derivative of Lambert's W function. And of course, it contains itself. And go ahead and check out the video that I made about integrating Lambert's W. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time.
Like one. Brilliant.org can help.
Hello everyone. In this video, we're going to be solving a homemade polynomial system. I call this problem homemade. It's no big deal, but I kind of came up with the idea, and I'll tell you the trick, so hopefully anyone can come up with something like this. And I encourage you to do that, because writing problems actually is a fun activity. It also teaches you a lot of good skills. Anyways, that's a different story. Let's get to the problem. We have x plus y minus z is equal to 13, and x squared plus y squared plus z squared is equal to xy plus xz plus yz. So this is kind of like a weird system, because we have three variables and only two equations. So that kind of tells me, are we solving a Diophantine system? Are we looking for integer or rational solutions? Not necessarily. We're going to be solving for real values. So how is that possible? Well, there are some special cases for which this is possible. And in some cases, obviously, you're going to have infinitely many solutions. So normally, when you have 3 variables in 2 equations, and if you're looking for real solutions, it's normally infinitely many solutions. Anyway, I talked too much. Let's get to work. So I'll be presenting a couple different methods. First of all, I kind of want to try something without knowing these identities. So I'm going to pretend I'm not familiar with these identities, okay? And then second method will be kind of like the goal. So I'm looking at the first equation, the top one, the blue one, and I'm kind of thinking that's a linear relationship and the second one is quadratic. So I could probably square the first one to get something that will help me with the second one. So let's go ahead and do it. Why not, right? So you don't always have a good reason to do it. Just square the expression, and a plus b plus c squared, remember that formula, x squared plus y squared plus z squared. And then I'm going to be getting something like plus 2xy, and then minus 2xz, because z has a minus sign, minus 2yz, and that'll equal 169, which is 13 squared. Okay, great. So I do know x squared plus y squared plus z squared. Do I? Well, kind of. I do know that at least it's equal to this, so I can go ahead and replace this with xy plus xz plus yz, and then add the 2xy, and then minus 2xz, and then minus 2yz, and that equals 169. Awesome. Let's go ahead and simplify this. Xy plus 2xy is 3xy, and then xz minus 2xz is minus xz, and then same thing with yz, and that's equal to 169. Do you think that's helpful? Doesn't look very promising, but that's what we have. So what else can I do? So this didn't really give me anything helpful. Maybe I should isolate the z, or x plus y. So we have x plus y minus z. So let's go ahead and isolate the x plus y. And then hopefully I can just square both sides and get something helpful. If I square this, I get x squared plus y squared plus 2xy, and from here I get z squared plus 26z plus 169. Something similar, but this time we have a z squared, so on and so forth. Now what else do I have, right? Well, I kind of know that x squared plus y squared plus z squared is equal to xy plus xz plus yz, right? So from here, I'd like to do the following. I'm going to bring this z squared over here with a minus sign, because when I add them, they're going to cancel out somewhat. Or I can subtract them and x squared, y squared cancel out. So maybe I can just do that. Let me try. Subtract z squared. So I'm going to go ahead and erase this. Subtract z squared. And then add negative 2xy, or subtract 2xy. And I should be getting the following. When you add these two equations, or subtract, which one do you want to do? Actually, I want to subtract this way. So x squared, y squared cancels out, and then I get 2z squared. Remember, we're subtracting that way. xy, and that's going to give me 3xy, and then plus xz minus 26z plus yz minus 169. Again, this is not really helping much. I'm getting something more complicated than the original ones, so I kind of give up, right? Don't give up, because we're going to do the second method. So first method is not very fruitful, not very helpful. Let's go ahead and take a look at the second method. At least I tried, right? Okay, so here's how this goes. We have x squared plus y squared plus z squared equals xy plus xz plus yz, and x plus y minus z equals 13. Let me tell you something. The first equation, I guess that was the first one, right? Did I give you the first one first? Okay, that one is the first one. Now the first equation, let's call this first and this second, could be different. So I could have given you x cubed plus y cubed plus z cubed, even something more complicated, and you could still solve the system. You know why? Because the trick is in the second one. Okay, we're going to look at the second one really closely. So notice that I have the sum of squares and I have the products, the sum of products. So here's what I can do. I can put everything on the same side. I could also use something very helpful. Remember the cubic identity?
不想花时间，好麻烦。宝丽镜口腔护具清洁定。
We talked about it recently, right? This is factorable, and x plus y plus z is one of the factors. And the other factor, do you remember that? It is x squared plus y squared plus z squared minus xy minus xz minus yz. So in this case, it's equal to 0. So if that's equal to 0, then this is equal to 0, and x cubed plus y cubed plus z cubed equals that. But do you think the cubic is going to help us here? Not really. So we're going to do the following. We're going to factor the second expression or equation. How? First of all, we're going to put everything on the same side, like before. But not only that, we're going to make it factorable. And in this case, the idea is called completing the squares. Squares? There's more than one. Okay, here's what we're going to do. We're going to double this whole thing. And of course, it's going to be 0 still. So this gives us 2x squared plus 2y squared plus 2z squared minus 2xy minus 2xz minus 2yz. By the way, we could have done this without doubling, but doubling makes it easier. Trust me on that, okay? Now, here's what we're going to do. We're going to extract, because of the presence of negative 2xy and the squares, I'm going to take out an x squared with the negative 2xy and just add another y squared. So I used one of these, right? One of each. And then I'm going to do the same thing with x and z, and then with y and z. And notice that it just works out. Isn't that amazing? This is a really nice, beautiful identity, which allows us to actually split up into the sum of 3 squares. And remember, x, y, z are real numbers. Did I say that? Hopefully I did. Now we get the following. X minus y quantity squared plus x minus z quantity squared plus y minus z quantity squared equals 0. Now, when you have a squared plus b squared plus c squared equals 0, and if a, b, c are real, this implies 3 things. A is equal to 0, b is equal to 0, and c is equal to 0. So it's really nice that from a single equation, we can get 3 different results. So that's very rare, right? Now, here's what it means. All of these are 0, which means x, y, z are all equal. Yay, awesome. And looking at the second equation now, things become a lot easier. If these are all equal, why not set them all equal to x? So this is x and this is x, which means x plus x minus x equals 13. Ta-da! This gives me x equals 13, but also y equals 13, but also z equals 13. Now you can test out. You can add their squares. You can multiply them like pairwise, add them up. You'll always get the same answer. Well, xy and x squared are basically the same thing because they are all equal. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
缓解感冒初期症状，有效止咳，促进鼻道畅通，无药味。福猫热饮。
日本兰诺新上市衣物抗菌芳香豆，洗后长效抗菌抗臭，与天亮衣也有日晒般清新，日本热销第一。
Hello everyone. In this video, we're going to be solving an interesting equation. We have x to the power square root of 2 equals 1 minus ln x. I'll be presenting 2 methods, and I'm also going to show you a graph at the end. So we're going to be using something pretty interesting. First method. Obviously, for a problem like this, you can do guess and check, right? Can't you? I mean, that doesn't guarantee you found all the solutions, but at least that gives us a solution. Now, first of all, notice that x to the power square root of 2 is an increasing function, right? All right. And then 1 minus ln x is increasing, but 1 minus ln x is going to be a decreasing function because it's kind of like the opposite of ln x. Plus 1 wouldn't make any difference. If you differentiate it, you'll get the idea, okay? Obviously, it's only defined for positive x values. If it's in the real world, that's why it is going to be negative when differentiated. So we have an increasing function equals a decreasing function. What is that supposed to mean? One function is going to go up, one function is going to go down, and they're going to intersect at a single point. Obviously, the graphs are not going to be like that. They're going to be different. And I'll show you the graphs at the end. But first of all, before we start solving the problem, let's go ahead and test some values. For example, can x be 0? But remember, we just said x needs to be greater than 0. So that kind of restricts the domain. Obviously, if the domain of 1 minus ln x is positive values, the same thing is going to be true for x to the power root 2, because they can only intersect where they're defined, right? So x must be positive. Under those conditions, you can kind of test out some values, especially if you have ln x, you should always set it equal to 0. So ln 1 is 0, pretty much any log 1 is 0. So we get, if we replace x with 1, we get 1 minus 0, and that gives us 1, right? And on the left-hand side, we also get 1 if you replace x with 1. In other words, if you replace x with 1, you get 1 to the power root 2 equals 1 minus ln 1. That's true because this is 0. And 1 to the power root 2 is 1, right? Well, at least in the real world. What happens in the complex world? That's a very different story. But x equals 1 works. Okay, great. So guess and check, we get a solution. Is that cool? Now, obviously, the first method is short this time, which is very rare. Normally, it's more painful. But I want to give you something real quick. We're going to take a look at the graph at the end, okay? Let's go ahead and talk about the second method, which is a little longer, but more interesting. So the question is, can we use Lambert's W function? I know you guys like that function, and let's go ahead and give it a try. So Lambert's W function is pretty useful. So let's say you had a problem like this. This would be super simplistic, but x e to the x equals 2e squared. Now you could use Lambert's W function. Obviously, without using it, you know x equals 2. But there are different branches, so we kind of need to talk about how many solutions there are, so on and so forth. So with a problem like this, you could use it. You could even use it for something like x e to the x equals 2, right? You could Lambert both sides, and then this would give you Lambert or w x e to the x equals w2, and then from here you would just get x equals w2. Now what happens if you had instead something like this, x ln x equals 2? You could still use Lambert's W function, because you could turn this into this format, x e to the x, or in more general terms, t e to the t. T is my thing, whatever that thing is, it's just going to be repeated. So here's what we can do. We can write the x as e to the power ln x, and then this will be ln x times e to the power ln x equals 2, and now this is going to be your thingy. Look at that, the thingy times e to the power thingy is going to be 2. If you Lambert both sides, you're going to get ln x from here, and of course in this case you have to use exponentiation, but ln x equals...
Enjoy your meal.
Lambert W of 2, and then you're going to do x equals e to the ln x again, which is going to be e to the power Lambert W2. Make sense? So there's some examples how you can use Lambert's W function for simple cases. But we have something more interesting. And by the way, this is a product. You could also use it for a sum. Like what would happen if you had x plus ln x equals 2? Could you use it again? Absolutely. But you just gotta manipulate this a little bit, okay? Take some manipulations. And here's how we're gonna do it. This is a sum. You don't want that. You want to turn it into a product. How do you turn a sum into a product? Think about it. And also think about Cauchy's functional equations, right? And if you said exponentials, yes, you got it. So I'm gonna do e to the power both sides. And that's gonna give me something amazing. And this is really cool, because from a sum, we're getting a product. And that product is actually very helpful in terms of Lambert's W. So we can write this as e to the x times e to the ln x equals e squared. And of course, e to the ln x is just x by definition. This gives us x e to the x equals e squared. And there you go. The rest is straightforward. You just W both sides, and you're going to get the answer. Does that make sense? Pretty easy, right? Great. So this worked with x plus ln x. Would it work with a different scenario? Let's go ahead and check it out. And this is actually the second method. So we have x to the power root 2 equals 1 minus ln x, a very irrational exponent, right? Great. So now here's what we're going to do. First of all, in order to be able to use Lambert's W function, I want to get a number on one side and everything else, variables, x's, whatever, on the other side. So let's go ahead and add ln x to both sides. And then we're going to use the same strategy. do e to the power both sides. Is that going to help us? Let's find out. We're going to get e to the power x to the power root 2 plus ln x equals e to the power 1, which is e. And then we're going to separate these. E to the power x to the power root 2 times e to the power ln x equals e. E to the power ln x, as before, is equal to x. Now we get x. E to the power x to the power root 2 equals e. Uh-oh. We did not get x e to the x. We got something much more complicated. We got x to the power root 2. Can you imagine? This is kind of like a super exponential. But don't worry, we can take care of this. For example, if you had e to the power root 2x in the exponent, you would just multiply both sides by root 2. That would do the trick. In this case, we have to think in more complicated terms. We're just going to raise both sides to the power root 2, because that would give you x to the power root 2. But it would bring in some extra factors, but no, don't worry about it. We'll take care of them in a little bit. So this would give you x to the power root 2 times e to the power. Now, here's the nice part. When you raise a power to another power or to another exponent, you're supposed to multiply the exponents. So this becomes root 2 times x to the power root 2. Make sense? Awesome. We're super close, because what we need is to get the same thing for x, right? This is our exponent. That's our thingy, or t. Now, all I have to do is, by the way, this is equal to e to the power root 2. Let's not forget that. Now, multiply both sides by root 2, and you're done. Isn't that awesome? Root 2 times root 2. And now we got our thingy. This is our thingy, or t. Or, of course, if you apply Lambert's W function on both sides, you're going to get from here, if you apply Lambert's W, this is going to give you root 2x to the root 2. And the right-hand side, notice that this is my t. And if you apply Lambert on it, it's going to give you root 2. Which means x to the power root 2 equals 1, which means x equals 1. All right? Let's go ahead and take a look at the graph, and we'll finish up with that. Alrighty. So here's the graph of y equals x to the power root 2 and 1 minus ln x. As you can see, one of them is decreasing, the other one is increasing. They're only defined for positive x values, and they intersect at 1, 1, which means, again, x equals 1 is the only real solution. Are there any complex solutions? I have no idea. You're going to let me know. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
Is breaking softly and the night is glowing true. I feel a million eyes, but I can just see you. No rain, no
我是 Leo 曼谷的。한라산이죠.
Solving an interesting polynomial system. We have x squared plus y squared equals 61, and x cubed minus y cubed equals 91. I believe there is a Diophantine equation that just contains the second equation, because if x and y are integers, we could just solve for two variables with one equation. So you might as well, use that information if you already have it, or you can just guess and check, but that's not the goal. You want to solve this algebraically. And at the end, I'm going to show you something interesting. Okay, so let's go ahead and start by factoring this difference of two cubes. Remember, x cubed minus y cubed can be factored as x minus y times x squared plus xy plus y squared. And you can actually come up with this formula by cubing x minus y and then putting the terms that contain x minus y on the same side, and then factoring will give you the result. Okay, that's how it's kind of derived. So what do I know about this? I do know that this is equal to 91. Great. Do I know what x minus y is? No. Do I know the second factor? No. But let's go ahead and work with the first equation. That's why we kind of need to dig a little deeper. The first equation is the sum of two squares. How could I transform that into something helpful? Well, looking at the second equation, the cubic one, I think I'm going to need two things. X minus 1 is going to be helpful. And then another thing that is helpful will be the product, xy. It's not very clear right now, but you'll see in a little bit how that's useful. So let's go ahead and do the following. X squared plus y squared can be written as x minus y squared, because that gives you x squared plus y squared minus 2xy plus 2xy. Makes sense? And this is equal to 61. Awesome. So we got something in terms of x minus y and xy. In the other equation, which is the cubic one, we got x minus y, xy, and x squared plus y squared. So I kind of need to get rid of this. But wait a minute, I already know what it is. I can just plug it in, right? Wait, is x squared plus y squared 61? Yes, it is. So let's go ahead and substitute 61 here, because I already know it, right? So that gives us something different. Let's go ahead and rewrite our equations. X minus y multiplied by 61 plus xy equals 91. And the second equation says x minus y squared plus 2xy equals 61. Great, so these two equations are going to help us solve for x and y. And how do we go about solving it? We achieved our goal, actually, because we ended up with two variables. Notice that by using some identities, by using a little bit of algebra, we were able to turn this into a system of equations with two variables. What are those variables? Those variables are x minus y and xy. If we can find those, we can find x and y, hopefully, right? So let's go ahead and call this something. How about calling the x difference d and calling the product p? That makes sense, doesn't it? So now let's rewrite our equations under those conditions. D times 61 plus p equals 91. And then d squared plus 2p, or not, okay, that didn't work, sorry about that, equals 61. I should have chosen b for that one, not p. Anyways, just you kind of flip it and you'll get a b, right? Anyway, so this is my system. What am I going to do with this, right? Well, I could probably do the following. Distribute the first one. That's going to give me 61d plus dp. Let's not use pd. You could also use pd, no big deal. Equals 91. And now what can I do with the second equation? So I got the first one. From the second equation, I can actually isolate p, right? I don't want to isolate d because I don't want to deal with square roots. That would be a little ugly, right? So let's go ahead and isolate p here. That's going to be 61 minus d squared divided by 2. And this is awesome because I can plug it in here. I only have one occurrence of p, and that will be easy. Now let's go ahead and replace p with 61 minus d squared all over 2.
知名网红在口袋发现1000元。
So let's go ahead and substitute 61d plus d times 61 minus d squared over 2 equals 91. So this is the equation we need to solve. Let's go ahead and solve it. First of all, you can go ahead and multiply both sides by 2. That's going to give you 122d plus d times 61, which you can write as 61d, minus d cubed, we already got rid of the 2 there, equals 182. Awesome. Now when you add the 122d and 61d, you're going to get 183d. Let's go ahead and put everything on the right-hand side where d cubed is positive. That's going to give us d cubed minus, notice that that's going to become positive, 183d plus 182 equals 0. No way, you know this, right? Look at the sum of the coefficients. It's 0. 1 minus 183 plus 182 is equal to 0. Awesome. You know what that means? It means d equals 1 is a solution. Let's go ahead and use it to find p. P is given by 61 minus d squared divided by 2. So 61 minus 1 is 60 divided by 2 is 30. So we now know the difference of these two numbers and their product. Can we find the numbers? Absolutely. Let's go ahead and back substitute. What does d mean? D means x minus y, and p means x times y. How do you solve this? You could probably guess and check, and there's going to be two pairs, but let's go ahead and do it algebraically again. I know you already guessed it, but I can go ahead and replace y with x minus 1. I could also do x equals y plus 1, but I like the x better than the y. I don't know why, but it just looks better. Replace now y with x minus 1. X times x minus 1 equals 30. Again, at this point, you could guess and check because you're talking about the product of two consecutive numbers. Whose product is 30, so on and so forth. But anyways, let's still do it algebraically. Brute force. Okay. So from here now we can factor it. I think we can use factoring. We deserve it, right? X minus 6 times x plus 5 equals 0. And then from here we get two solutions. X equals 6 and x equals negative 5. Awesome. We got two solutions. How do you find the y values? Remember, y is 1 less than x. So if x is equal to 6, y is going to be 5. If x is negative 5, y is going to be negative 6. Notice that the product of these numbers is 30, and y is always 1 less. Of course, they're not symmetrical. X isn't always greater than y. In this case, y is greater. Okay, that makes sense? Great. So, what do you do with this information, right? Those are the solutions. Let's go ahead and take a look at some. Oh, by the way, we only found one solution from here. So let's explore a little bit further. I know we're going to stop probably when we check the next thing, but d equals 1 is not the only solution because this is cubic. So let's go ahead and do the following. I'm going to go ahead and leave the solutions alone. So I'm going to erase this part only. Let's go ahead and do our work here. And here, let's go ahead and take a look at the other solutions. So we got d cubed minus 183d, right? So what are the other solutions? How do you find them? You can basically do the following. You can kind of subtract a d from here and then follow by 182d plus 182, and then kind of factor by grouping. D times d squared minus 1, which is d plus 1, times d minus 1, minus 182 times d minus 1, and now d minus 1 is a common factor, of course, because we know d equals 1 is a solution, and then this will be followed by d squared plus d minus 182, and yay, there are real solutions. How do I know that right away without checking? Because if a and c in a quadratic equation are opposite signs, then the discriminant is always greater than 0. But if you find the other solutions, you're going to find something like this: negative b plus minus the square root of b squared, which is 1.
生理期来了，让你痛到很。
Plus, because negative 4ac, that's going to be 728. Uh-oh, this is interesting because you know what? 729 is 27 squared. Awesome. So this can be written as negative 1 plus minus 27 divided by 2. And if you go with the plus sign, you're going to get d equals 13. And if you go with the minus sign, you're going to get negative 14. Along with p, of course, p is not going to be 30 in this case. You kind of have to consult the formula. P equals 61 minus d squared. P equals 61 minus d squared over 30. Was that 30? No, it wasn't 30. It was 2. Yeah. 30 was after division. We got 30. Now, if you plug in 13, you're going to get 169. And if you subtract it, 169 minus 61 is going to be 108. But it's going to be negative 54. So P is going to be negative 54 from here. With the D equals negative 14, the product is going to be 61 minus 196, and 196 minus 61 is going to be 135, but it's going to be negative 135, and that's going to be divided by 2, of course. That's going to be a fraction. Not good, not good. Okay, anyways, you get the idea. We got other pairs. Let's look at the first one, because the first one kind of looks manageable. Do you think we can find two numbers whose product is -54 and whose difference is 13? You can test some integers, like, for example, I can think of 27 and 2, but their difference is not going to get close. I could probably use 9 and 6 or 18 and 3. Probably we're not going to find anything nice, but let's go ahead and write it as a quadratic equation. X minus y is 13. Let's replace x with y plus 13, and then the product is just going to be x times y, or y times y plus 13. That's equal to -54, and from here y squared plus 13y plus 54 equals 0. And from here, if you try to find the y value, you're going to get -b plus minus the square root of b squared minus 4ac. We're going to get some complex solutions from here, and probably the second one is also going to give you complex solutions. Anyways, you can go ahead and explore those on your own, because I'm going to show you the next big thing. And ta-da, that is the graph. Like, what is the big deal about this graph, right? Take a look at it. One of them is a circle. What about the other one? Does that look like an elliptic curve? I think so. Anyways, this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
3倍高效去除牙菌。
Hello everyone. In this video, we're going to be solving a nice, I want to say exponential, but this is kind of non-standard because we have the exponential function on one side and the polynomial on the other side. So it's kind of half exponential maybe. So we have 8 to the power x minus 1 equals x to the power 7, and we're going to be solving for x values. So we're going to be looking at some interesting stuff here. We'll be looking at graphs, some results from alpha, so on and so forth. But let's go ahead and manipulate this equation a little bit so we can use a very special function to solve this problem. I'm going to write the 8 to the power x minus 1 as 8 to the power x divided by 8, which is 8 to the first power, equals x to the 7th. And then let's go ahead and cross multiply. That gives us 8 to the power x equals 8x to the 7th. Great. So we have this exponential function on one side and the polynomial, the 7th degree septic polynomial on the other side. So in order for our very special functions to work, we do need something that looks like t e to the t. And probably I'm going to have something like x instead of the t, or something similar to x. Okay, some multiple of x. So we do have x to the 7th power. That's not good. We do need x to the first power. So let's start by taking the 7th root of both sides. And 7 is kind of fine because when you take the square root, sometimes you have to be careful about hitting negative values because that's not defined. The square root of a negative number is not a real number. I hope I said it right. Anyways, so from here we get the following: 8 to the power x over 7, because I can divide the exponent here. And let's go ahead and separate these. The 7th root of 8 multiplied by x. There we go. We got the x, so that's probably going to be our t here with some modification. But we have 8 to the power x over 7. I do need e to the power something. So I'm going to use the famous identity, e to the power ln t equals t. So I can basically write 8 to the power x over 7 as e to the power ln 8 to the power x over 7. But of course, this x over 7 can be moved to the front, and now this becomes e to the power x over 7 times ln 8. That's going to replace the left-hand side, and the right-hand side is just going to stay the same for now. So let's go ahead and write it as e to the power x over 7.
生理期不一样的干爽是好自在一体卫生棉，不一样的黑洞吸收力，采用一体材质，一吸到底，反锁大流量，吸后依然轻薄，不一样的超吸干爽一体卫生棉全新上市。
Hello， 大家好，我是日本妹妹なちゃん。今日は台北に来ています。ジャムや食べ。はい、じゃあ。 なんかちっちゃいさ、これジャムや
一份
でいいよね。どうしよう、何欲しい？
百叶豆腐。
きわちゃん百叶豆腐めっちゃ好きよね。
豆腐人間。やっぱやめた、丼豆腐がいい。
あとなんか欲しい？あ、これ美味しいの。やろう。
か。オッケー。
あと
ダルメ。
あと面線。
じゃあお願いします。
今なっちゃんが注文してくれてます。今日のドリンクはこれ安定のスーバーテンこちらからお入れいたします。
はい。ありがとうございます。じゃあ次ます。
ありがとう。ありがとうございます。2023年お疲れ様。乾杯。美味しい。美味しいね。美味しい。はい、じゃあ私たちが頼んだのは、面線と、あとは新干、
これ？
リンリンチェンとダルメ。
あと豆腐か。
あと豆腐とこの
ヤーローワン。
いただきます。いただき
ます。スープって美味しいの？
美味しい。
美味しい。飲んでみよう。
ジャムやってさ、生姜鴨スープじゃん。だからさ、冬にめっちゃいいんだって、温まるから。
確かに、今日めっちゃ暑いけど。体に良さそうな。
体に良さそう。これにさ、面線入れたらめっちゃ美味しい。
あ、そうなんだ。さすが入れてみよう。
ジャムやだーれ。
ジャムやだーれ、本当に。
きよちゃんさ、台湾に来た時からさ、台湾の料理大丈夫だった？
基本的に大丈夫だった。
あ、本当？私最初台湾の料理ダメだったのね。で、ジャムやは OK だった。
台湾料理、例えば
まあ、臭豆腐もそうだし、なんか感じじゃない？今日の動画はここ。拜拜，
又有多西
好，我是林轩。今天第一站呢，来到了桃园的新屋绿色走廊。这里可以租脚踏车，平日一个人只要100元，而且不限时间。这里拥有北台湾最具规模的自行车道，步道平缓，绿荫满布，旁边时不时还有一些小步道可以探险。骑在滨海道路旁，有海风吹拂，还可以享受海景，非常放松。接着来到了14楼手作甜点，这是一间超可爱半户外空间的货柜咖啡厅。除了有正餐可以享用，也有各式各样的手作甜点。店家还搭配节庆有圣诞红的装饰点缀，老板甚至帮我们点上了香氛蜡烛，在大自然围绕的氛围下度过轻松惬意的午后。最后我们来到了草踏沙丘地质公园，这里有绵延8.1公里沿海沙漠特殊地形，也是台湾海岸中保持最宽广完整的沙丘，加上并排的风车，景色非常壮观。许多电影电视剧也都曾经在这里取景，天气好的时候非常适合来这里散散步看夕阳哦。以上行程推荐给想来一趟舒心放松旅行的你，也欢迎收藏跟分享出去。我是林轩，想关注更多旅游生活可以关注我的 YouTube 还有 IG 哦。
This video, we're going to be working with an infinite fraction. We have 2 plus 1 over 2 plus 1 over 2 plus ... Hopefully you get the idea. This is kind of like an infinite pattern. And we're going to try to evaluate this expression. Obviously, what I mean by expression is a numerical value. All right? So let's see how we can do this. First of all, I'm not going to go into any type of convergence, limit, so on and so forth. I'm just going to assume that this value exists. So this, when written as a sequence, converges, which we'll do in a little bit. So I'm going to go ahead and set the whole thing equal to x. Usually start by, if you have an infinite expression, could be a radical, could be a fraction like this, you set pretty much the whole thing equal to x, and then you try to find x again. Because these expressions contain themselves infinitely many times. And take a look. The denominator of this fraction is actually the same thing with the original. So if this whole thing is x, then this will also be x. You see that? And this will also be x, right? Obviously. And there's more x's inside, but you don't really need to go that deep. This is good enough. So let's see if we can write this as an equation, all right? And solve for x. So from here we get 2 plus 1 over x, right? The whole thing was called x equals x.
哇，好香哦！
龟甲万味子满调味酱包。
最强修护小黑瓶， 机身年轻嫩透光，兰蔻。
Looks fairly simple, right? And then multiply everything by x, 2x plus 1 equals x squared. And then we want to put everything on the same side. X squared minus 2x minus 1 equals 0. And now let's go ahead and solve this as a quadratic. You can do completing the square or just use the quadratic formula. Let me show you how completing the square works because that's kind of fun. First, you're going to add 1 to both sides, so isolate the constant number, and then add 1 to both sides. Why are we adding 1? You might be questioning. I need to look at coefficient of x and then cut that number in half, and if I square that number, that gives me the number that I should add. Okay? That's always going to work with, in case of b, instead of the 2, you can figure out what you need to add. So now I'm going to add 1 to both sides, and that's going to give me a perfect square on the left-hand side, which is perfect. And now from here, I get two solutions because there are two numbers whose square equals 2. Those numbers are plus minus root 2, right? And then after adding 1 to both sides, you're going to get 1 plus minus root 2. What does that mean, though, plus minus? I know I wrote the plus minus differently, so don't be surprised. Now, this means that there are two solutions, and one of them is 1 plus root 2, and the other one is 1 minus root 2. Wait a minute. A numerical expression cannot have two different values, can it? No way. It's impossible, right? So there's a problem here. We have to eliminate one of these, or does that mean this expression does not have a value? Obviously, this is not clickbait. We're going to find the numerical value. But how do we eliminate one of them? If you look at the original expression carefully, you can realize that this expression is positive, isn't it? And now looking at the results, 1 minus root 2 is less than 0, so we have to eliminate it. Too bad. Okay. Now we end up with 1 plus root 2, which is hopefully supposed to be the value of this expression, right? I hope so. Now, how do we kind of verify this? First of all, we need to define our sequence. So we need to this needs to be well defined. So here's what we can do. We can say, hey, a sub 1 is equal to 2, and then a sub n plus 1 is equal to 2 plus 1 over a sub n. So I'm kind of defining it recursively, right? And what I do is I start with 2 and then put that 2 in the denominator of a fraction, a unit fraction, and then I just add to it. And keep doing it, and you're going to get the following. If you look at some of the terms, this should give you an idea. So a sub 1 is equal to 2. Yes, a sub 2 is going to be 2 plus 1 over a sub 1, which is 2 plus 1 half, and that's going to be 5 halves. Great. A sub 3 is going to be 2 plus 1 over a sub 2, but that's just 5 halves. That becomes 2/5. When you add them, they're going to be 12 over 5. And a sub 4 is just going to be 2 plus 1 over a sub 3 by definition. Again, I'm just using the definition because here n is actually supposed to be greater or equal to 1, right? And that's an integer. And now we have 2 plus 1 over 12 over 5, which is 5 over 12. And when you add the 2, you're going to get 29 over 12. Great. So this is 2.5, this is 2.4, and who knows what this is, right? 2 point something. And we start with 2. So the values seem to be near maybe 2.5-ish. We're going to find out what that's going to look like in a little bit. Or did we? We actually did, right? So that's the value we've been looking for. 1 plus root 2. Root 2 is about 1.4. So when you add 1, it's going to be about 2.4. So this seems about right. But the problem is, how do we guarantee that this value does not jump outside? So here's the thing. This expression is actually, so we can go ahead and kind of divide 12 into 2 to 29 and see what that looks like. It's going to go 2 times 24, and then you get the idea. And this is going to be 4, and then that's going to give us a 48, remainder 2, and that's going to be 1. Now notice that we started off with we start with 2, 2.5, 2.4, 2.41, and you can just continue. But you're going to realize something, that those values are going to accumulate near 2.4 something. All right? And that value is actually given by 1 plus root 2. So there is actually a way, and this, in other words, this sequence is bounded from above. And you can safely say that this expression is always going to be less than 3, or you could even use 4, right? And I kind of use induction to prove the idea. But I want to show you something else. So here's how we can work backwards. That's going to be fun. Let me show you something. This is really cool. So I'm going to start this time with square root of 2 plus 1. And you know that it's a finite value, right? So, I mean, it is a numerical value. Great. So I'm going to write it as follows. I would like to get a 2 from this. I want to separate the 2. So I'm going to write it as 2 plus root 2, but I just added an extra 2, so I have to subtract it. Make sense? Now here's the cool part. Root 2 minus 1 and root 2 plus 1 are actually conjugates. So their product is 1. Root 2 plus 1 times root 2 minus 1 equals 2 minus 1, which is 1. Which means whenever you see root 2 plus 1 or root 2 minus 1, you can write it as the reciprocal of the other. So here, I can actually replace this with 1 over root 2 plus 1, which is nice. And then add the 2 to it. And I started off with this, remember. Okay? Don't forget that. Now I got root 2 plus 1. And again, I'm going to do the same thing that I did here. Split it up into 2 plus 1 over 2 plus root 2 minus 1, just like before. And then this part can be written as a reciprocal. And let me just kind of tell you that this is the same thing I'm going to use. 2 plus 1 over 2 plus 1 over root 2 plus 1. Remember, root 2 plus 1 and root 2 minus 1 are reciprocals. So you can write root 2 minus 1 as 1 over root 2 plus 1. And guess what? You can continue to do this, like you can do this forever. And you're going to get our original infinite fraction. So we kind of worked backwards. We started with the value. By manipulating the root 2 and the numbers, we arrive at the original expression. All right? So that's going to be the value of our expression, which is root 2 plus 1. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
高品牌，5天去除最高达99%牙渍 ，Crest 放闪笑，放刺美，
全新 Crest 香氛锁白牙膏，温和锁白，果断放闪。
Hello everyone. In this video, we're going to be solving a log equation or a logarithmic equation. We have log x with base 3 and log 2x with base 2. So one of the things that makes this problem interesting is different bases. When you have the same base, these kind of problems are fairly easy to solve. Suppose you had something like log x with base 3 equals log 2x minus 5 with base 3. Then you can easily say that since the bases are equal, we can safely say that x is equal to 2x minus 5. And from here, we get x equals 5. And obviously, x equals 5 satisfies this equation. You can check the domain. But the bases are different. So what are we going to do? I'll be presenting two methods. And the first method is kind of nice because it uses a very nice property. And then, actually not necessarily a property, but it uses the definition of logarithm. So if you're new to logarithms, this is going to be helpful. And it also uses exponentials. The second method is a little different. And now we're going to compare our answers at the end. Okay? So let's get to work. First method. For my first method, I'm going to go ahead and set both of these equal to the same thing, like something. Log x with base 3 and log 2x with base 2. Suppose they're both equal to t. Since they're equal to the same thing, right? Now, from here, we get two equations, which is what is nice about substitution. This is t. So I get log x with base 3 equals t. And by using definition, what do I mean by definition? This is the base, that is the exponent, and this is the result. Make sense? That's how logs work. Pretty easy. Okay, so that means 3 to the power t equals x. Awesome. Let's go ahead and do the same thing with the other expression or equation. Log 2x equals t. And then from here, we get the same thing or something similar. This is the base, that's the exponent, and I have to come back for the answer. So it's kind of like this. Start at the base, go across, and then come back for the answer. So kind of like 2 to the power 2 equals to x. How do I reconcile these equations? Wow, big words. So, I mean, in other words, how do I solve it as a system? One of them is x, the other one is 2x. So double the first equation, 2 times 3t is equal to 2x. which is equal to 2 to the power t. Awesome. We got rid of x because we need to solve for t, and it's easier, trust me. Now, to solve for t, this is an exponential equation. Remember, I told you we were going to go with substitution, and then from there we're going to get an exponential. Let's go ahead and divide both sides by 3 to the power t. That gives us 2 to the t divided by 3 to the t equals 2, since 2 is on the left and 2 to the t is on the right. I guess I switched places, okay? And then these two have a common exponent, so I can kind of take it out like this. And then at this point, since you have an exponential and the exponent is a variable, you can log both sides. Logs are going to be very helpful. Again, one more time. And I like to use the natural log, which is ln. Doesn't matter, no big deal. You can pretty much use anything. But if we use ln for every single method we do, then it's easier to compare. That's why I'm going to stick to ln. So ln is the natural log, which is base e. So I'm going to ln this, and I'm going to ln that. Okay? If you want, you can use parentheses, no big deal. Bring the t to the front, and then you get the following. Okay? What am I going to do with this? Divide both sides by ln 2/3 because you want to get t. And ln 2/3 from quotient property can be written as ln 2 minus ln 3. So whenever you have the quotient or the ln of a quotient, that can be written as the difference of the ln's. Did that make sense? Hopefully it did. Now, this is my t value. Be careful because you're not solving for t, you're solving for coffee. I mean, not coffee, you're solving for x. What is the relationship though, right? Well, 3 to the power t is equal to x. Great, let's go ahead and write down. 3 to the t equals x. And I have t, so I can just plug it in. From here, x equals 3 to the power ln 2 divided by ln 2 minus ln 3. Uh-oh. ln 2 minus ln 3, by the way, is a negative quantity. Therefore, ln 2 divided by that is going to be negative. But 3 to the power negative something is not negative. It just means it's a small number. Kind of like a fraction, sort of, like 1/10, right? Is 10 to the power negative 1. Awesome. So this is the x value, and we found it. Let's go ahead and take a look at the second method, because after the second method, we need to look at the graph. All right. Now, the second method uses a property called COB, or COB. What does that mean? It means change of base. Change of base is a very helpful formula if you have something like log, let's say.
我以前不吃止痛药，因为担心它残留在我体内会伤身体。但接种疫苗
I don't know, b with base a, and I want to write it in a different log like base x. I can kind of like put the b here because it's on top, and put the a here. You see, a goes here, b goes here, and we're all good. That's called change of base. And by the way, if you don't want to use any base x, you can use base 10, which is just log, or you can use ln, which is base e. You see, it's very easy to transition from one to the other, and so this is kind of like another identity, which is pretty interesting, right? Anyways, so let's see if we can find the same answer using the second method. How do we apply the second method to our problem, right? Here's how. You have different bases, right? So change of base would actually be perfect for this problem. And let's go ahead and change the base to Euler's number, right? And that will be ln. So how do we write it? ln x over ln 3 equals ln 2x. Let's put 2x in parentheses to avoid confusion. Divided by ln 2. You get the idea? You put this on top, and you put this at the bottom. Cool. But how do we solve for x from here? That's going to be a little intricate, right? Well, here's the idea. Cross multiply. ln x times ln 2 equals ln 3 times ln 2x. So at this point, you might be tempted to put the ln 2x and ln x together, even come up with something like this. I know some people like to do that. Use the change of base backwards, and this is going to be log 2x with base x. You don't really need to get into any of that. There's an easy way to do it, which uses the product property. Yay! Quotient property and product property are actually awesome. So if you have the log of a product, then you can kind of write it as the sum of the two logs. Make sense? And then we can use the awesome distributive property because we do need to use it. And then we're going to put the ln x's together. So this one and this one. Subtract ln x and then take it out. You're going to get ln 2 minus ln 3. Do you see what I see? ln 3 times ln 2. Uh-oh, this is not good because we didn't have that before. Don't worry about it. We'll take care of it. Now we're going to divide, obviously. And that's going to give us something similar. But this is an ln x, remember. To get x, you're going to do e to the power ln x. So x is going to be e to the power ln 3 times ln 2 divided by ln 2 minus ln 3. Such an interesting number with lots of ln's, right? But here's the thing. Our first answer was 3 to the power something, right? Let's go ahead and copy that here. 3 to the power ln 2 over ln 2 minus ln 3. How are they equal? Well, they are. If you take a look at it carefully, you can actually put this e to the power ln 3 inside. And then, guess what that gives you? E to the power ln 3, e to the ln x is x. So e to the ln 3 is 3. And you get the exact same answer. Or, of course, you're supposed to get the same answer. But sometimes manipulations are complicated. All right? So that's the x value. Let's go ahead and take a look at the graph real quick and we'll finish up. So these two functions are both logarithmic functions, but one of them grows faster. But before they do, they just intersect at a single point, which is the x value. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
Ma chi sei?
Il treno Eurosib 50 di Trenitalia e le 220 per Basilea e in partenza da binario 4.
Gentili passeggeri, il treno viaggia ora sulla linea del Bernina della Ferrovia Retica, che insieme alla linea dell'Albula è stata inserita nell'elenco 96 Brücken und durch 55 Tunnel. Ladies and gentlemen, the Albula and Bernina stretches.
Stack halt, but I think we're not stacking today.
Upgrade complete.
Oh. Oh.
For my brothers.
Right.
Enlighten me.
What's better? I do ogres? Nah. Go for the safe LOD, I think.
I am prepared. No one shall be the wiser. That's a given. Job's done.
I go mid. I go mid. I go mid. That triggers me almost as much. Oh, the professional level 1 send. I love how the LOD Snipes it.
Research complete.
Oh, and we get a scout. Easy. Ping ping like an idiot. That's how you know I mean business. And I'm really sad I'm not playing, Wait, really? Sun vs. EA is good.
I stand ready.
Okay. Apparently it is.
Thy bidding. No one shall be the wiser. Job's done. I am prepared. That's a given. Out with it. Job's done.
Guosaurus.
I stand ready. I stand ready.
So we don't know what Red has, right? It's unfortunate. Do we even get leaks, though? I thought EA was just too good on level 2.
Research complete.
Well, I don't know if we sent enough.
Out with it.
Yeah. A lot of small archers there.
Prepared. No one shall be the wiser. That's a given. It has begun. For my brothers. Done. Job's done. Research complete.
Master.
My bidding. I am prepared. Enlighten me.
He's doing an excellent job. He's pushing a lot. I mean, I can get away with it. Look at the role I have. The problem is I have to full sell the LOD already. Because I won't get the ghost otherwise. Okay, Red's having a tough game. I think we lose if we don't stack.
No one shall be wiser. Job's done. The restless dead await. Out with it. Upgrade complete.
Well, this guy's got EA.
I am prepared.
Yeah, they're like this. And this didn't happen on level 6. They went on the side. But I may not have enough value to hold this. Yeah. I leaked quite a bit on level 5, didn't I? I shouldn't have went 9-6.
Enlighten me. For my brothers. No one shall be the wiser. Job's done. I am prepared. Upgrade complete. Job's done. I bid you. Upgrade complete. For my brothers. It has begun. No one shall be the wiser. Job's done. Job's done. Job's done.
Yeah, the level 6 really hurt me as well. 5 and 6. The ogres going on the side didn't really help my case there. But they didn't do that on level 7. Except it was the opposite. So on level 7, it was the opposite. The champion went on the right. That made it worse. We're not killing shit here. I got punished hard for going 9-6. After that, I should have realized I leaked too much on level 5. But yeah, I don't know why they're not blocking right now, but on level 6 they did. It could have been big if they went here, because the champion was there, and he killed one of my necros. Oh wow, the ghost even suicided there. Not sure what that was all about. I think I reroll and see if I can get better for level 12, because that's when it looks like they're gonna send. Oh. Right, I used my full cell. Right. I forgot about that.
Research complete. Get on with it. I bid you. That's a given. No one shall be the wiser. That's a given. Job's done. Job's done. My brothers. Job's done. How can I help? Job's done. Job's done. Upgrade complete. Job's done. That's a given.
Yeah, well, that's not gonna matter when we leak 300 creeps. And we have ammo.
Research complete. I am prepared. No one shall get on with it. Enlighten me. It has begun. No one shall be the wiser.
I mean, I'll show it. I don't really care. They're gonna send anyways. So I'm still gonna show it. Oh, I guess he's gonna EA revive. Or... maybe not, I don't know. No, he's not gonna EA revive. Nothing stack halts. Well, I guess it's better than, I guess it's better than, Stomp. What are these lag spikes? Yikes. Again, they're going to the left. There goes my tank. Because the champion's in the worst spot possible. At least I got focused by my necros because it was over here. But the problem is, once this stuff is gone here... yeah, I don't know if I hold... So yeah, I needed to stay, no, he's definitely cleave. I needed to stay 9-5 after level 5. This is where I went wrong. Because I leaked way too much on 5. I misplayed there. For sure misplayed. This is really smart, by the way, that he went Seraphim. I think he would have leaked a lot with the build that he had. Really smart. He would have leaked a lot there if he didn't make it.
Job's done. Job's done.
Oh, I didn't even see I had Harpy. What the fuck? I didn't even make this. I could have made that for...
Job's done.
I could have made that for level 10.
Upgrade complete.
Oh, dude. This is very smart, yeah. If he has the value, go for it. Wow, they didn't sun? I wonder if you built it here, would that be better over mid build? Don't know. Also, I didn't even see you at Thunderbirds. Are they holding? Lords. Is that only one champ? Yeah. Well, they didn't stack, so I'm happy that they are cool.
Research complete. Upgrade.
So it's gonna be one heal. Because they should get time in time, I think. Oh, I don't think it's enough anyways. Yeah, plus they get time in time.
Get on with it. What you looking at? Yes, me lord. The dead shall serve.
Oh fuck. Not enough food, yeah.
The restless dead await.
Sack a few of those.
I am prepared. Yes. This better be good. I bid you. Out with it. I bid you.
Enough. I was already at 1,500 by the time the round ended, so yeah, I don't know. Yeah, it's two champions. I don't know what happened to them, but yeah, obviously I want to say, oh my god, no stacking worked, but we did not go against the best team. They kept leaking after that 15. my allies are good on 5. Doppelganger? Well, could work on him. Well, this would have been a good video, and now it's not. Misplay after misplay here. This would have been a good video, but look at what I did. I didn't even send. I completely forgot we were even sending. Holy shit, man. Where, like, straight up, where's my mind today? Like... Holy shit, dude. Talk about brain dead. Wow, so brain dead today. Holy crap. I didn't even send. Oh yeah, that was my plan all along, guys. I knew we were gonna King League. That was my plan. And I had terrible king control too. Oh god. Yeah, he's just full stacking. That's what he's doing. Look at all the tanks here. Yeah. I guess now you guys see why people stack. Stack is so stupid, man. I don't care. I find this a win.
目前有1位选手听牌就是 Broccoli， 其他7位都要阻止他拿成冠军。那 Broccoli 这一把如果没有吃下鸡来的话，下一场至多会有5位也是跟他一样听牌的，他就会错过这个关键的机会哦。
没错，有点像在看 Title 的那一场比赛，就全部7个人卡他，就是盯着他一个人。
对，那场 Title 的比赛，我记忆真的非常深刻。他为了防止别人卡他，他是前面直接空城，然后之后再决定方向哦。果然是没有办法拿主秀，要看2之1有没有爆好一点的东西给 Broccoli。其他人的话，则是有看到一个思绪杂乱的吗？我没有拿下来。 拿皇冠。这里的话6-1，他也是已经来到18分哦。对他而言，其实这场就是卡着，然后反正不要老八就行。
对，那个一刀千金，我对他印象很深刻，因为基本上都不会掉钱。
对，好，
超级无敌难掉钱。可是，就是有时候你就要换一个思绪，你就要调整一下你的心态啊！没给我，他送我一件装备了，很强了，我在前面打了连胜，这些都是钱。对，心里就会舒坦一点。没错，我之前真的有2阶段，打了5连胜，然后1块钱都没掉。那个时候聊天室就想说 ，OK， 以后不会再选了。然后我下次还是再选了。就是有一些阵容特别契合，就是什么萨利啦，或者是你刚好就是有酷奇的时候，你还是会想要说，你今天多一件装备就是一个战力。
哦，这里看一下 Broccoli 的话是打连败，然后薪资刚已经放上去喽。这个剧本其实跟 Title 的有一点点像哦，前面先蹲经济，然后后面再选阵。
是这样比较不容易被卡，就是先去看一下其他的玩家，他们已经确定玩什么样的阵容。像这个看起来真的很乡村，
我直接拉6等，不跟你开玩笑，2之5就拉6等。他前面可能掉的钱不少哦。
我感觉可能真的是打了非常多的钱。
他这个跟你不一样，他2阶段应该是有掉钱的，要直接上6等。
没有掉钱啊，怎么可能？这个东西真的会掉钱？没有0。
我们在看的时候就没掉，我发现波提的凝视，
我就看着你要掉多少钱，
1块都没掉，
我没掉，你也别想掉，
真的1块都没掉。哎呦，这里 Double 也是抽了一口气，3个铲子，这个 Broccoli 要故技重施了吗
？True damage 来，
已经开始在比战了，跟观众。
OK，
而且这里还是掉乌尔加特，他这样乌尔加特是直接上2的哦，
又要来秀一把了。
啊，直接来2星乌尔加特，很舒服，铲子直接合。
直接合，真的哎，这个阿卡丽自己会来，
没有跟你开玩笑。
我之前有真的玩过阿卡丽一张不来的，就是哇这边直接 play ball， 这边的话全身金光。
花同学，我觉得好像没有看到什么可以救他了，蓝照之盾选了。
阿卡丽，
哇还是有办法上8，还是抽到了。他经济量比我想象中的高，不好意思。而且凯特琳也来了，为什么每一波都有凯特琳？
天哪，
这就是命吗？
真的是命哎！又要谷底反打了，
而且他抽的这个辅助道具也是很合适的，奇克的号角。每一波都是上8抽到底，然后刚好就凯特琳。我刚才还在问说凯特琳没有来怎么办，原来是我多余了。凯特琳一定会来，
一定会来，这就是王者的实力。强者都是相信自己一定抽得到，上8滴个2、3下就行了。阿卡丽什么抽不到会被别人卡，我直接用漂的。我觉得现在这个质量真的有点。可以，等一下我们想一下要吃什么早餐，大家都可以先去叫一下了。
OK。
因为这场有2家雅宁，我觉得这2家凑在一起根本就是找回家的路。
了解。
对，就是这一把都已经有人要，就是降职赛事都已经有人要登顶了，结果没有想到还有2个同行可以撞在一起的。
目前看起来好像只有 Double 有机会去挽救这个局面，因为我看其他人牌面有2个明显是为了故意卡这个 Broccoli， 结果没卡成，然后另外2家雅宁互撞，剩下的看起来就是看一下 Double 这个乡村有没有办法救助，让大家再看一局，还是要让大家去吃早餐呢？
是这样，没错。他这边还在新纲要开张，就看他们能不能有一家就是可能完全大成的雅宁，但是要有夜色的，避免被直接砍破头。
对面
那下就只有机器人一个人在扛，其他全部都是一星。
对，
扛不住的，全部都跟纸一样。
星等真的太差，没有拉起来。
对，而且其实外面都已经把那些超粉体系的牌，就例如说这种凯特琳啊，都已经抽光了，然后阿卡丽抽，他竟然还有办法逆命只找到一只。其实这种状况真的已经很崩，真的天崩局了。
来看一下这个最后一张萨米拉有没有办法抽出来？
萨米拉来，差一张而已。
哦，有了，3星萨米拉，各位有救了，有希望了。这个萨米拉只要不要一枪被爆头，
是没错，只要不要太快倒，都有机会。他这里可能得回春一下。哇，这里还有出 damage 转，这个一定
不会吧？又出 damage？
没有，下面的人一定会拿走的。
你拉啦，帮助大家一把。
你拉啦，
大家要跟他致敬一下。
对，
做得好。他自己也需要了，他也是玩出 damage。
对，我们完全没有卡什么为了要防止也没有，就自己刚好需要，就刷不到基亚娜，我需要这个好东西。他其实这个萨米拉真的有点可惜，因为他萨米拉3星了，但是他只有1件装备，他没有像他说什么俄语啊，然后也没有巨杀这样子的装备。是这边终于可以开个3KDA 出来。
这2家看起来面部表情都是哥尽力啦，还是没有抽到亚宁。
是，就差那么一张。这个场景我还真有遇过，我不知道你有没有遇过真的就是拿了这2个复制器，然后
从头到尾没有用。
对，然后
一个金
色就是差这一张，很经典的差一张。
确实可以感受到。那这里 Ashmu 的话是遇到了61的话2件装，感觉是可以把对面给切过去。Ashmu 是扛不太住了 ，Ashmu 倒地。另外一边米拉拉的话，
年轻是什么颜色？
话他的应该是已经开到，我不知道有没有开到6了。看一下1、2、3、4、5。
那他这边倒下的话，另外一家亚宁就这边倒这么多家，
哇！到底谁可以拯救全村？还是我们都要去吃早餐，去正常时间上班了？2家 True Damage 的对打都是 True Damage 凯特琳，看一下这个狙的角度有没有办法直接狙到后排？这里凯特琳，不对，他去击另外一边了。有打到一下，把 Broccoli 的狙死了。这个对位对得很成功，但是还有一只阿卡丽在场上。
阿卡丽跟凯特琳互电，
哇，把对面射走了。Broccoli 手在空中挥，成功了。
太精彩了，这把
只剩3家了。61有办法防住吗？
他这边就是坦度撑起来就行了。
61，乌尔加特走到脸上，一枪就不见了。哇，而且这个对点的上面，萨米拉对点强很多。Broccoli， 这乌尔加特差1张，然后萨米拉
真的挡不住。
好，那看一下这个3星乌尔加特有没有办法顶住前面的3星亚宁3星亚宁很早就直接被晕到了，而且被萨米拉锁头。Kevin Parker 的吸回来了。他砍前面的小马，把这些血量全部吸完，而且这3个人都在角落，一倒下去，血又全满了。原本剩200滴，但把 Double 给送走了。版本答案，亚宁有办法单挑凯特琳吗？
哇，这个好像是2个花主播在场上打一样
真的，一个是花主播最喜欢的角色，一个是花主播的姓氏。
没错。哪一个才是最强的？而且这边基亚娜是有2星的，如果他有办法去偷到装备的话，或者是去踢一下那个阿卡丽，或是能够成功走进去狙击那个凯特琳。
他1、2费卡是有那个，他是有小伙伴看不好意思，我想说他刚为什么要挂这个？
还有那个小伙伴，没错。
亚宁看他的走位了，有没有办法走到后排？去砍一下那个凯特琳，被狙了1枪之后，但还是可以吸回来。前排已经倒下了，2倒下去，凯特琳没了。Kevin Parker 要拯救这个拉比了吗？要让他再看一场吗？Parker 已经来到10等了，但现在血量亏输大概20。这里有1张伊洛伊， 这个伊洛伊有办法把它卡下来吗？应该 Kevin Parker 卡 True Damage。
对，但是这个伊洛伊拿了。这个雅尼真的非常难处理。哦，对到了吗？
有对到吗？要看一下这个基亚纳队的位置。有，雅尼要直接走进来了，但是也有可能是直接被狙死。好像被爆头了，哇，已经开启跳水模式了，一枪下去受不了，放铜边好像效果不太好，
不太理想。从侧边切入，再试试看。可是这个基亚纳队的位置其实蛮不错的。
那一下下去还是挺痛的。这边最后 Broccoli 选择再把这个处刑者开起来，给阿卡丽一点伤害。这一波是把位置成功的换到另外一边哦，先让雅尼去把层数给叠起来。跳水的话只是跳到左边，哎，雅尼这一次叠得很好哦，要从左边切起来，没有他往前跑了。哎，哥哥，不是，不要往那边跑。哇，这一次被狙到他头上。Kevin Parker 有可能剩最后一次机会来拦住 Broccoli 了，要不然其他人全部要回家了。这个凯特琳应该会去狙击伊洛伊吧的触手，
感觉是有机会，可是有可能会被前排挡下来。对，
也是，
没错。
如果可以挡2下的话，对战场效果是差非常大的。最后1秒，雅尼要不要换一下位置？哦，他摆的是跟凯特琳同边吗？
哦，没有，侧边
这边有换，有看到。
对，
全场 Broccoli 的呼声已经来了。
这边可以先处理掉阿卡丽吗？
这个跳水有晕到，第2下也有再晕到，已经跌到40层了。雅宁的伤害已经跌得到全满了，但是他飞错边了，又被晕了一下。这2道下去有办法吸回来吗？吸回来了！哇 ，Broccoli 剩4滴血，这个基亚纳这个触手真的太关键了，
打得有来有往。
而且这双跳水跳得好漂亮，连续的晕眩。加油，雅宁，往后砍。这次的对位一样，雅尼是在远处，看一下凯特琳的第一次狙击会狙到哪一些的目标。
有狙到了这个触手，
但是这次的跳水晕眩没有晕到后排，已经被打到了，再逼了一下，再一下普攻能吸回来吗？40层吸到1200，吸回来了。Kevin Parker 守住整场，我们还有下一场可以看，赌神公开赛还会继续。
无限喋血的雅宁啊！全场的英雄
！Oh my god！ 接下来的话就听牌了，不止这一家了，4、5家听牌了。旁边的每个人都在感谢他 ，Kevin Parker 做得好，做得好。
他笑得好开心，好激动。
因为这第1名跟第2名的奖金足足差了4倍哦。第1名是拿10万，第2名只有2万5
啊，
所以他帮大家保住至少多拿这一笔钱哦的机会。
是不可置信。
雅宁这一刀下去是直接200万台币，差的很多。
这一刀好有价值。
那我也想问一下这个波提，你觉得 Broccoli 现在的心态打击有多大？最后那个雅宁1砍5，可能把他这辈子赚过的钱砍掉，一刀下去就少了200万。
真正的一刀千金就在这里，那个巨兽决议的价值200万哎。
哇，80层的雅宁直接砍爆。
我觉得这个会有 PTSD。
Hey all, Nego here. First off, I want to showcase the abilities and talents you'll have to pick. Then we shortly go over the stats you want to focus on increasing. Next up is the return stealth, regrowth. Gotta pick up some camouflage. Let's just hit. Then we gotta stack our hemorrhage to 5 common points. And then we gotta use our rupture ability. If our enemies run away, we make sure to slow them down by using our Frost Shock ability. This way we can kite even more if we need to, or catch up to our opponents. This is actually the core rotation, guys, And it's simply as that. Now that we know what to do with our spec, which abilities and talents to choose, and what stats to go for, I think it's time for us to move on to the footage of how this build is used in the wilds. Alright guys, what I prefer to do is go into stealth mode, sneak up behind the target, use your Garrett, Hemorrhage, Rend, Hemorrhage, and Rupture if you don't kill them before. That is really it. It's not really that hard. I'm gonna try to find some players, but this is Laughing Skull at the moment. As you see, it's very empty, but I'll try to go on and find some players. Alright guys, unfortunately it did not succeed for me to find any players. However, I would like to thank you all for watching. Please subscribe to the channel in order to stay updated with all of my newest content.
单身吗？还是你正处于一段无期限试驾型恋爱呢？什么是无期限试驾型恋爱？你们该发生的明明都发生了，牵手、抱抱、发生性行为全都发生了，但是对方迟迟不愿意跟你确认关系。没错，我们今天来到了充满圣诞气息的信义区。我不相信每个人都这么幸福，一定有人正处于水深火热的关系当中。让我们一起去揭开大家的疮疤。我今天要看到新一支血流成河 ，Go！
来访问一下这位小姐，所以你有遇过无期限试驾型恋爱吗？
就是
对对，还没问完呢。
不是要让别人血流成河，不是让我血流成河啦。该做的都做了，但是对方却迟迟不愿意跟你确认关系，完全没有。你们这没有谈过恋爱吗？
或是你们身边有没有朋友有遇过，可以跟我们分享？
朋友有，那他维持了多久？快2年。哦，真的。他后来习惯的原因是因为那个男生他喜欢上了别的女生，所以他对那女生是立马公开。所以我朋友就。超伤心的，所以才这样2年。然后那时候他还跟他说，因为他被伤害过那个感情，所以就不敢，就是太高调让别人知道，就很渣，超渣，真的很渣。然后跟别人在一起马上公开，对，祝他下地狱。
In this figure we have a rectangle and we are given the areas of 3 right triangles. One of these right triangles has the area of 27 square units, the second one 15 square units, and the third one 12 square units. We need to find the area of this blue triangle. There are multiple methods for solving this problem, and here we will explore one of them. If we could find the area of the entire rectangle, then we would subtract the areas of these 3 triangles and we would get the area of the blue triangle. So then let this rectangle have one side A and another side B. Now let's take a look at the triangle whose area is 27 square units. One of the formulas for finding the area of a triangle is 1/2 times base and times height. I will write this formula to the right. So to get the area of a triangle, we multiply 1/2 by the base and by the height. In this triangle, we can say that the base is B and let this height be x. Then we can write that 1/2 times B and times x equals 27. Now let's take a look at the triangle whose area is 15 square units. In this triangle, we can say that the height is A and let's call the base y. Then we can write that 1/2 times y and times A equals 15. Now, what about the base and the height of this triangle? If this side of the rectangle is b and this part is y, then this part will be b minus y. And if this side of the rectangle is a and this part is x, then this part will be a minus x. Then we can write that 1/2 multiplied by b minus y and multiplied by a minus x equals 12. So far we have these equations that represent the areas of these triangles, but as you see, they have a lot of variables, so we will try to use substitution to eliminate some of these variables. First, we will solve this equation for x, and in the first step, we will multiply both sides by 2. Then we will have bx equals 54. And now, if we divide both sides by b, we will get that x equals 54 over b. Now, the next equation will be solved for y, and we will start by multiplying both sides by 2. Then we will get that y times a equals 30. Then, if we divide both sides by a, y equals 30 over a. Now, in the third equation, we will replace y with 30 over a and x with 54 over b. Then we will have 1/2 times b minus 30 over a times a minus 54 over b equals 12. Now, as you see, this equation has only two variables, and these are a and b. Now, let's simplify this equation and let's see if we can solve it. First, we will multiply both sides by 2. Then, on the left side, 2 and 2 will cancel. Then, we will remove the parentheses by using FOIL, so b times a is ab. Then b times negative 54 over b will be negative 54 because b and b will cancel.
Minerva is a global university for curious, bold, and purpose-driven students. Apply today.
도와주시겠어? 지금 몽성병원 안에서는 끔찍한 일들이 벌어지고 있어요.
Then negative 30 over a times a is negative 30 because a and a will cancel. So we will write minus 30. Then negative 30 over a times negative 54 over b will be positive 1620 over ab. So we will write plus 1620 over ab. Then on the right side, we will have 24. Now we will subtract 24 on both sides, and we will have AB minus 54 minus 30, and then minus 24 plus 1620 over AB equals 0. Then if we combine these three numbers together, we will get negative 108. Then we will have AB minus 108 plus 1620 over AB equals 0. Now, to get rid of this denominator, we will multiply both sides of this equation by AB. On the left side, we will use the distributive property. Then AB times AB is AB squared. AB times negative 108 is minus 108 AB, and AB times 1620 over AB will be 1620 because AB and AB will cancel. So we will have plus 1620, and on the right side we will have 0. Now let's recall that a quadratic equation has the form a x squared plus bx plus c equals 0. In this equation, the variable is x, and a, b, and c represent numbers. Now, do you see that the equation we got here is also a quadratic equation where the unknown is the product ab? If we can solve this equation, we can find the product ab. And the good part is that this product AB represents the area of the rectangle. To solve a quadratic equation, we can use factoring if it's possible, or we can use the quadratic formula. For the equation to the left, the quadratic formula is x equals fraction negative b plus or minus square root of b squared minus 4ac all over 2 times a. If we use this formula for our equation, then we will get the following. The unknown ab equals fraction bar, and now in place of negative b, we need the opposite of this number, which is positive 108. So we will have 108 plus or minus square root of negative 108 squared minus 4 times 1 and times 1620. Then all this will be divided by 2 times 1. So again here, a represents the number that is in front of the variable squared, and that is 1, and c is 1620. If we simplify the radical, then we will get that AB equals 108 plus or minus 72 divided by 2. If we add 108 and 72 and we divide the result by 2, we will get 90. But if we subtract 72 and divide by 2, we will get that AB equals 18. Now recall that the product AB represents the area of the rectangle, and it cannot be smaller than the areas of these 3 triangles. Therefore, we will disregard the second answer and we will keep only the first one. And now, once we know the area of the rectangle, we will subtract the areas of these 3 triangles and we will get the area of the blue triangle. So then, the area of the blue triangle is 90 minus 27 minus 15 minus 12, and the result is 36 square units. So we found the area of the blue triangle, and now the problem is completed. I hope you liked this problem and the solution. Please subscribe, leave a comment, and thank you for watching.
放心，超快，缓解酸痛，快用。
Hello everyone, in this video we're going to be looking at a quick and easy exponential equation. We've done a lot of exponential equations, and some are complicated, some are non-standard, as you've seen I think about an hour and a half ago, the premiere. But this one is fairly simple, but for those of you who are new to exponential equations, this would be a good exercise. I'm hoping that it'll be helpful. Please let me know in the comment section down below. Now we have 2 to the power x plus 2 to the power x equals 4 to the power x. Now this could be called a freshman's dream, or maybe high schooler's dream, I don't know, because when you add the 2 exponentials, you just add the bases, right? But that's not always the case. For example, if you add 3 to the x and 3 to the x, do you always get 6 to the x? Or is this true all the time? The answer is no, not in general. We're going to be looking for an x value that satisfies this particular situation. So for which x values is this true? That's going to be the question, okay? And how do you add exponentials? Good question. Like whenever you have something like a to the b and a to the c, if b and c are different, can you add them? Or if you have 2 to the power 3 and 2 to the 5, can you add them? Yes, you can find the numerical values, but when the bases or the exponents are different, it's kind of difficult to add. But when they're both equal, it's kind of like having the same thing twice. Make sense? Okay, there's a couple ways to approach this problem. One way to do it is Fairly simple. If you add a plus a, you get 2a. Awesome. What is a in this case? 2 to the power x. So if you add 2 to the x and 2 to the x, you get 2 times 2 to the x, because 2a means 2 times a, right? What's that supposed to mean, though? How can I solve this problem? And again, you can solve this problem in so many ways. I guess we can talk about multiple solutions. You can just go ahead and divide both sides by 2 to the x, and that's going to give you 2 equals 2 to the x, because when you divide these, you just divide the bases. And then from here, you can conclude, hey, x is equal to 1, right? But that's not the only way to do it. You could also do the following. When you multiply two exponents, you add when you multiply two powers, you add the exponents. So from here, this is supposed to equal 2 to the power 1 plus x. And 4 can be written as 2 to the power 2 to the power x, which is 2 to the power 2x. And then from here, you can say that, hey, 1 plus x is 2x, which again gives us the same solution. So no matter how you do it, you're going to get the same answer. Obviously, we could also look at it from a different angle. I guess the purpose here is not just give you a super easy problem that you can do mentally, but more like going over the properties of exponents in a single problem, because notice that we're using a lot of different properties. Hopefully, this will be good practice. Okay. Now, another way to look at it is, since 2 to the power x is a common factor, we can take it out. What do you get inside? 1 plus 1. That's what's really cool about factoring. Don't you love that? It becomes 2. And now, again, we can divide both sides. And 2 is going to equal 2 to the x. And you can proceed as before to get x equals 1. Make sense? Okay, great. So that pretty much sums up the solution. I don't think there's any other way. Maybe there is. Who knows, right? I mean, there might be another way to do it. Obviously, you could do the following as well. I just thought about it. You can call this a, and then that will give you a plus a equals a squared, and then this gives you a squared equals 2a, and then you can kind of bring these on the same side, and then factor out an a minus 2, and from here you get two solutions. Great. A equals 0, a equals 2. Wait a minute. Isn't there only one solution? Yes, because the problem is if 2 to the power x is equal to a, notice that 2 to the power x can never be 0. Even with the complex values, that's not going to happen. Therefore, a equals 2 is the only value, and from here we get x equals 1. But what makes this problem, I think, more interesting is the complex solutions. Let's go ahead and explore if you can find any complex solutions from here. So here's how it goes. We can go ahead and add these up together just like before, and that's going to give us 2 times 2 to the x, 4 to the x, and then 2 to the x equals 2, and x equals 1. But that's the real solution. Let's go ahead and complexify the right-hand side. We can go ahead and write the 1, which is invisible in this case, right? You see the 1 now? We made it visible. That was in invisible ink. Now we're going to replace 1 with e.
我推荐牙周氏漱口水，3倍除菌量，增加保护力，有效对抗牙龈问题。
To the power 2 pi n I. Because if you think about the Euler's formula and the polar form of the complex number, remember it was e to the power I theta, which could also be written as cosine theta plus I sine theta. You notice that theta represents the angle that the number makes with the real axis. So if you have a complex number, graphed or plotted like this is theta, this is the r. By the way, r is the modulus, so if our number is z, then you can also set this equal to the absolute value of z. What are we talking about now, though? We're talking about 1. So 1 is actually going to be a real number with no imaginary part. This is the real axis, this is the imaginary axis, remember? So our number is actually going to be on the real axis, on the positive real axis, 1 unit away from 0. So its angle is going to be 0 degrees or 0 radians or whatever, or 2 pi or 4 pi or multiples of 2 pi. That's where I get this 2 pi ni from. Make sense? Great. So here's what we're going to do. There's a couple ways again to proceed with the solution, but if you go ahead and just follow one of them, I think that's going to be good enough. I don't know. We might talk about both. So one way to do this is divide both sides by 2. That's going to give you x minus 1. Solve for x minus 1, and then you'll get x by adding 1 to both sides. I talk too much. Let's get to work. Now I'd like to natural log both sides, but wait a minute, I don't have an e on the left. I want to change the base. To change the base, are we going to use change of base formula? Well, kind of. We're going to use the identity 2 equals e to the power ln 2. Replace the 2 with that, you're going to get e to the power ln 2 multiplied by x minus 1 equals e to the power 2 pi ni. Wait a minute, we don't even need to ln both sides because it's kind of obvious, isn't it? The exponents are equal. Great. So now let's go ahead and set them equal to each other. X minus 1, I want to write that first, times ln 2 equals 2 pi ni. And then the next thing you can do is, there's again so many ways to go about this problem. You can go ahead and distribute and then isolate the x, or just divide by ln 2, which is what I'm going to do, and then add 1 to both sides, which is fine, right? And this is really cool because when you add 1 to both sides, this is going to show you the components, which is really nice here. Let me talk about what I mean here. Notice that n is an integer. Wow, did I say that? I'm sorry if I forgot. Apologize. N is an integer, and you can replace n with any integer value, including n equals 0. What happens if n is equal to 0? You get x equals 1. Wait a minute, didn't we find that before? Of course, that's the only real solution to this equation because we complexified it. We totally forget about it, right? And now, notice that this is a general solution. So if n is equal to not 0, then of course you're going to get all the imaginary, or I should say complex solutions. But there's a real part which is 1, and there's an imaginary part which is 2 pi n over ln 2. N is an integer, and you get infinitely many complex solutions. And this brings us to the end of this video. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
有感冒症状就用普拿疼福茂加强定，30分钟快速有效缓解症状。
Hello everyone. In this video, we're going to be solving an interesting non-standard equation. We have 4 to the power x equals 8x, and we're going to be solving for x. Now, I call this non-standard because we have an exponential function on the left and a linear function on the right. We're also going to be taking a look at the graph and some results from Wolfram Alpha. But let's go ahead and see how we can solve this using a very special type of function called Lambert's W function. All right, so here's what we're going to do first. We want to bring the x and the 4 to the x on the same side, and we should do it on the x side. Because 4 to the x can move easily, but just by changing the exponent. So I'm going to go ahead and do the following. Divide both sides by 4 to the x. That's going to give me 1 equals 8x divided by 4 to the x. The next thing I'm going to do is get rid of the 8 by division. So let's divide both sides by 8. And that's going to give me 1 over 8 equals x divided by 4 to the x. Let's go ahead and write the variables on the left. And then manipulate. Do manipulate expressions, do not manipulate people. All right, so now, first of all, we want to use the negative exponent here. Write this as x times 4 to the power negative x equals 1 over 8. I'm pretty sure at this point or before, you found a solution. But let's go ahead and wait for the complete solution. All right, so we're going to be using Lambert's W function, but first we have to make it appropriate. So Lambert's W function is basically something that can act upon t e to the t to bring out t. In other words, it's the inverse function for t e to the t. The reason I use t here instead of an x is because we're going to use a little bit of substitution, and it's not going to be x e to the x at the end. Okay? I mean, if you have it, that's great. You can definitely use it directly. So now we need to work with this expression. And I want to have an e at the base, not 4. So let's go ahead and use the famous identity. 4 equals e to the power ln 4. If you go ahead and replace 4 with that, we get x times e to the power ln 4 to the power negative x from here equals 1 over 8. And then ln 4 and negative x are both exponents, so they will be multiplied. So this is going to give us x times e to the power negative x ln 4 equals 1 over 8. Our expression is almost Lambertable. That's a word that I just totally made up. But anyways, in order to be able to apply Lambert's W function, we do need t e to the t. So we kind of got our t here. This is the t, or our thingy. but we don't have that here. But it's you can easily make it just by multiplying both sides by negative ln 4. Notice that x needs to be multiplied by negative ln 4 to get negative x ln 4. You get the idea? Okay, so that's what we should multiply both sides by, not just one side. So multiply by ln 4, you're going to get negative x ln 4, negative ln 4 times e to the power negative x ln 4. Notice that you multiply both sides by negative ln 4, not negative x ln 4, because we didn't multiply by x, just negative ln 4. Notice that the right hand side is constant and it needs to stay as a constant. Now, here's our t. So we're going to go ahead and replace that with t, and we're going to get t e to the t. I want to use Lambert's W function, but on the right hand side, I don't have anything that is appropriate, right? So we need to work on that a little bit. Let's go ahead and do that now, and then we can just set them equal to each other and just W both sides, and we're done. Hopefully, right? So how do you work out negative ln 4 over 8? How do you make it, or how do you prepare it, or how do you prep it? So here's what you can do. First of all, multiply the top and the bottom by 2 to get a 16. And the purpose, hopefully, is clear, because if you bring this 2 as an exponent, you're going to get 4 squared, which is equal to 16. Wait a minute. 16 is at the bottom, so it's kind of 1 over 16. Yes, you're going to bring the negative 2, not the positive 2. Okay? So we kind of need to back up and...
牙龈常常出状况，马上用牙周式漱口水。
Not that much. And we need to go ahead and move this here so that it becomes 4 to the power negative 2, which is 1 over 16. You get the idea? So yes, very intricate manipulations. ln 1 over 16, or 4 to the negative 2 divided by 16. I can kind of write this as ln 1 over 16 divided by 16, or just write ln 1 over 16 times 1 over 16. Makes sense? It's more appropriate because we would like to get t e to the t. Well, wait a minute. This is not t e to the t. More like it's ln t times t. Don't worry about it. If you have that, you're super close. So here's what we're going to do next. We're going to use our ln identity again and turn this into e to the power ln 1 over 16. Look at that. We got what we needed. So this is now ln 1 over 16 times e to the power ln 1 over 16. This is your new t, or if you want to call it c, you can. But let's get back to the equation and make the substitution. t e to the t equals ln 1 over 16 times e to the power ln 1 over 16. Obviously, you don't really need Lambert's W function at this point, do you? Just to understand that t is going to equal this number right here, correct? Yes, but let's just do that W on both sides for fun. It's not going to hurt, right? And from here we get t equals ln 1 over 16, because that's what W gives on the right hand side, right? Makes sense? So whenever you see something like x ln x, or y ln y, or t ln t, just use the identity e to the power ln x equals x, and then you'll get the t e to the t form. Make sense? Okay, great. Now we got this, but what does t mean, right? What is t? T is a drink. No, in this sense it's different. T is actually negative x ln 4. Great. So let's go ahead and set that equal to negative x ln 4. ln 1 over 16 is ln negative ln 16, because 16 to the power negative 1 is 1 over 16. So this negative 1 power can be moved. It's invisible right now. And then we can go ahead and divide both sides by negative ln 4. Negative ln 16 divided by negative ln 4. Negatives will negate each other. Aha. And now we have ln 4 squared, which is 2 ln 4. Hopefully you don't mind me skipping that step. Come on, you guys can handle this. And we get x equals 2. Awesome. Wait a minute. Didn't you already know that? Like at the beginning when I gave you this equation, you probably went like, aha, I got the solution. X equals 2. Because why? 4 squared equals 8 times 2, which is 16 equals 16, right? Great. But the million-dollar question is that the only solution? Is that it? And the answer is no. Because Lambert's W function will produce two answers, and you can look at the graph of it. I believe I shared it in a recent video. But it'll produce two solutions if the value that we have as an input is between negative 1 over e and 0. Correct me if I'm wrong, but I believe that's the case. And this, our value, just happens to be that. ln 1 over 16 is actually a negative value, which is between negative 1 over e and 0. Okay, so it'll produce two solutions. But how do you find the other solutions? Can you just manipulate? Is it 1/2 or is it 4? No, it's not that easy. But let's go and take a look at some results from Wolfram Alpha, which we can abbreviate as WA. And now take a look. There are two real solutions. So we're basically using two branches of the Lambert's W function, the main branch and the other branch, which kind of gives us the second solution. Now, if you look at the numerical values, this is what you get again from Wolfram Alpha. One of them is 2. It says approximately, but don't worry about it. It's exactly 2. And the first one is kind of 0.15-ish. But what we're going to do is we're going to look at the graph of these two functions, and guess what? They intersect. Wait a minute. You said there are two solutions. Yes, you're only seeing one of the intersection points. This guy is going to curve. This is going to go straight, and they're going to meet again at x equals 2. But that's way out of sight because of the zoom in. And this brings us to the end of the video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time.
Okay, Soju is actually the only person in the world who can bot 4 with a true damage spat. No flame. But I shouldn't say that because the same thing might happen to me. I know his TF items are very normal, it seems like. But from this match history, what I'm learning is I think you just don't play TF. Wait, isn't TF really bad, guys? Does anyone know? Happy holidays, Portal, Golden Prelude. And this is like the safest one. Like, I hate multi-talented. Albert likes TF. Oh, the last time I watched him, he said he broke up with TF. Oh, yeah. Okay, Jinx reroll. He's still. Oh, I've actually seen quite a few TF3s. Because no one buys that shit unit. Never told us about your experience playing Lethal Company. That game is too hard. I don't know. This actually Stars Are Born Jinx reroll. That does not seem right. But these, I hate these augments. They're all so bad. Okay, guys, there is no way you play Jinx reroll here. Because I have Rod, Cloak, Belt. Like, what are you gonna do? Morello, your Jinx? Probably just open, right? Maybe I'll get the true damage spout on Carousel. Man, I've never been comfortable open forwarding though, guys. Like, isn't open forwarding actually so scary? Like, what if you just die? You're strict. Okay, isn't that the horrible thing about this set though? It's literally just like, if you're in any way not rich, you already know you're probably going 7 or 8. Like, you literally, there's no option for you if you're not rich. Like, in the past, I feel like if you were not that rich, like, it's fine, you can still somehow come back. But now it's literally like, if you're not rich, you're just giga-fucked. I'm not even first pick, even though I'm basically open forwarding. Huh? Oh! Like, sorry, I'll open more next time. Okay, can we just like... I am actually down. Is anyone else down for just like no spats this set? Just like fuck it, since they already like ruined spats anyway. How does it feel to be 200 LP up of Soju? Bro, the man is like GM. I don't feel anything. Like, it's actually sad that you guys are comparing me to him. Okay, I mean, against this guy, do I even... Like here he has a true damage spat on bench. He started the game, by the way, full econ opener, 1 item. I mean, okay, this isn't even bad. Honestly, it's not bad. I 3 loss into 2 win. Like, it's not even bad. We kind of streaked. It's fine. Wait, we just need to hit 1 Yone and it's actually over. 0 heart still stack, yeah, because he has zero units in. Like, is it even my fault that I just fought 2 open porters in a row? Like, no. I mean, don't we just win out if we hit like 1 Yone or Ezreal? Oh, GG's. Alright guys, I'm gonna apologize ahead of time for what I'm about to slam here. But yeah. I'm not really that sorry. LP's LP, man. No, I don't care how many people are bedging me right now. Like, I don't care. You know, do you think I care? I don't care. I'm going rank 1. I told Cutie, you said Cutie could be rank 1 if he really cared. He said he's going for rank 1 now. Okay. Guys, I said Cutie can be rank 1 if he really cares. I can guarantee you he will never really care. Oh, it's probably not unified. I think it's probably always crash test dummies here. But do the dummies count towards epitaph? Oh, it's a unit. It was like perfect, right? We just cash out and then we move on with life. He hit League of Legends without really caring in rank 1. I mean, that's very different. No. Like, he was actually always good at League. He has not always been good at TFT. No flame. Okay, the thing about like different about TFT and those other games is TFT, like, you unfortunately always have to do something called study, right? And if you don't study, like, you just can't be good. Like, it's not like League or like Valorant where you don't have to constantly like study shit up and like, I don't know, like always like try to keep up with the meta. Like, you don't really have to, right? If like, even if you don't know anything about like League or Valorant meta, if you were good, you'd just be good. But with TFT, it's like, you can be the best player in the world. Like, you don't know which comp is good, you're not gonna do well. All you have to do is go to tactics.tools and read the first 3 comps. But like, you know, Cutie, he doesn't open up that website. He hates it. He says he doesn't want to be a nerd. So he doesn't open up any statistics websites. Yeah. you guys study the game. I just go with the flow. Like, obviously, if you're a casual player, you can just go with the flow. And things are probably still okay for you. I think. RTS Angel, thanks for the 17 months. Thank you. I'm gonna 4-1 this again. I should be able to, right? With how much money I have. If you're a casual player playing max 100 games, you know how far you can climb. Probably masters at best. I mean, you have to have like, because everyone starts what in iron. So it's like it still takes even probably the best players like 50 games to get to master. Okay, I'm actually gonna be like dead. Oh no. I just come to Diamond. I found Emerald so frustrating. I was stuck there for ages. Oh yeah, I think this set it's the hardest for people between like I would say Emerald and Master. It's like that area where life gets really hard for this set. What is this? What is a 5-star steel board? So yeah, don't worry. Like your hard stuck Emerald, it's like that's just the area that's the game gets kind of hard. Alright, you know what? 28. That's a lot of lives. We good. Oh dear God. I mean, I can put them on a Kali and just dual carry a Kali. And basically put on any 80 carry. I am not buying that. I'd rather die. Holy shit, that was actually kind of close. Why does he have a Z2 at 7? Guys, is combat caster good? Is it good for Ari? Okay, it's probably fine, right? It could also be probably just combat caster. I have 2 Lilias on my board. Wait, it's fine, it's fine, it's fine. Barg? No, because I don't know if I'm hitting Ari. Okay, but isn't that kind of weird? I saw 0 Aries. Oh, I don't think there's one person. Well, I actually think I front row this Anna. Oh, he hit. What is going on with all these items? Both of our Kiana's farmed. Up, GG's. Guys, it's a Christmas miracle. We're also going 1K LP today. It's a 1.x kind of day. Yeah, it is. Honestly, save mental and end stream here. Huh?
那个还要抄的人，我瞧不起他。
A 凯特琳 ，B 葛雷夫 ，C 林董，D 图奇，E 好运气。
真的复选吗？
啊，没有一个，
只有一个啊，
这个很难哎。
哇靠，林董
是哪一位啊？林董，
黑金有存者讲的，哇靠，林董有枪啊！
如果是我认识的那个林董的话，他应该有枪哦。
这边选手会得
大家不要讲
应该不会
好不好
吧？倒数3秒，3、2、1，好，来，请亮答案。
我给林董机会。
第一题
超难。
第一题竟然就有分歧 D C C D C。
林董感觉就是
我选林董，哇靠，林董有枪啊！
公布答案，答案是
我在想，他拿的是公啊，对，
我在想啊，
哇靠，林董有枪，
哇，这12年都没有这个角色，
我就没玩过林董。
两位职业选手安静点，我听不到好好讲话。
啊，总之啊，就是图奇，哈，图奇没有枪，他是拿十字弓，
对，
让一下。在第2题选择题1分，下列哪个联盟战旗的英雄只出现在联盟战情中，尚未出现在召唤峡谷 ？A. 布雷尔，
我不知道。
B. 卡桑蒂 ，C. 希尔科 ，D. 赛特。
我知道。
你知道是哪一个吗？其中一个。
有上
花人开嘲讽，
应该是他。
好，看他写完了，来公布，亮答案。
叮咚
A C C C，
我增加游戏难度啊！
答案是 C。
上爽了！据说你是联盟战旗主播啊！
我看错题目了，我以为是出现在那个召唤峡谷里。
哦，上位，
你跟我一样啊！对哦，你跟我一样。
哇，那我还是打战旗。
现在的分数反而是最有冠军相的花轮是0分哦。
水吗？
哦，今天可能是放水。第3题选择题3分，所以3分钟，请你把握。集才华与美貌于一身的创作歌手阿福邓普鲁，拥有千金散以及令人惊艳的创作能力是。请问英雄联盟联盟战旗中，阿福是一只 A 海牛 ，B 海象 ，C 海豹 ，D 海狗 ，E 海狮。D 海公牛，
它是白色那一只嘛，对不对？
海公牛，
怎么感觉有那个陷阱啊？
对啊，海公牛，感觉是这个。
我也感觉。
但我在出题目的时候，我才发现这海字辈的，就是这些动物好多。来，请公布自己的答案。就这个。
海公牛。
C A C F B 海公。小熊竟然陷入了我们的这么烂的陷阱。
海公牛，
这不是来闹的选项吗？
他看起来超像正确答案的。
答案是海。
所以伏笔来了，有看到这里？来看到这里有没一个箭头？这里在一个 A， 镜头帮我拉近一下。其实在这里。
其实是 A 呀。
好了，没关系，你们算我错了。
没有 OK， 小熊算对，小熊算对。
有啊，学到。
真的吗？好强！
哦，小熊现在
如果
分了，
小熊很猛
猜对冠军项有没有什么奖品？
运彩是不是？
嘉奖1支。3题结束呢，现在小熊最高分，然后花轮急起直追哦，2分。伊泽瑞尔的大招精准弹幕可以对陆地上的敌人单位造成大量伤害。如果伊泽瑞尔发生精准弹幕，0.4秒后可以击中12公尺外的阿狸，那伊泽瑞尔的精准弹幕时速为A 96，时速96，B 时速108，C 时速116公里，D 时速124公里。
这个怎么算？
游戏啊，
这是国小数学啊。
国小。
哦，完蛋，我死定了。有没有那些锦囊可以用啊？什么排除法那些？
没有。
盲猜，
这个应该是盲猜。我想
这可以算多久？
我觉得10秒钟，20秒给各位算。
我用出题者的心态来，他目前还没有把答案放在 B 过。直接选 B。
我觉得下一题是 A， 这题应该不太会是 A。
所以大家都没有在算数学。
没有人在下面空白处很多。好，剩下5秒，4、3、2、1，好来，请各位。
我做了一个看起来很厉害。
有没有 D 的？有没有 D 的 ？OK， 我们好啦。
D、A、C、A、B、C、D 都有人选，答案是100。
我说过了，
说过，好强，
好有想法。
好，其实这一题呢，只要把0.4秒把它变成1小时的秒数，就是12乘以那个数字就是答案。
要跟所有的小孩子们讲说，如果以后不知道这题怎么解，学铁牛哥哥。
选 B， 不会选
B， 没有输过的，
第5题填充题1分。
你会写字吗？
爱讲笑话的易大师的护目镜上有几个镜片？
我要把它画出来。
你想一下，
镜片哦。
对，他的护目镜不是有很多的那个圈圈吗
？Jack 好像也差不多。
好，
来，请公布
7片。
7个、8个、7个、
8个。
你是不是偷看我答案
？7个。
只有丁特没有画，丁特写
了
7
吗？这有需要画吗？
幻想一下，
答案是7个。
可以耶！
顶级。
为什么你们都知道啊？完蛋了，
按照的。
我多画1排啦。
昨天才玩过。
第6题选择题1分。杰哥面对阿伟脱下眼镜后，大喊了一句：“听话，让我看看。”请问下列哪个英雄不太可能演出
杰哥的角色
？A. 乌迪尔 ，B. 李欣 ，C. 杰西 ，D. 塔里特。
这是什么？那应该是这个吧？
这个很难耶。
我知道了，有点微微的 hell，
很优
微微的，微微的。
啊，我知道。有。
是有点派，一定是他。
好，只有丁特写乌迪尔。答案
我想太多了吗？
答案是李欣，是
题目已经
他是盲僧，
对，让我看看，盲僧看不到。
我很好奇，你想到哪里去？
我以为你在影射同性恋。我想说
没有。
这出题很用心，因为我被讲过说什么我头发放下来长相乌迪
尔。但主要是让我看看。
但
因为李欣呢，他是盲僧，所以呢他看不到。第7题来了。这一题呢答对呢，不只可以得到3分，也可以得到我们的特殊道具儿骑士的手卡。
OK。
联盟战旗的棋盘中可摆放英雄的格子数，加上联盟战旗的棋手开始的生命值，加完之后呢，除以联盟战旗1场的玩家数等于多少？虽然是简单的数学，
格子数有多少？这个我真不知道。对啊，它有4排，每一排有几个人？有印象吗
？8个吗
？8个吗？
我记得可以放3只，各3只2星吧，2星棋手。
好难哦，这题我想想。
这题要不要大家一起帮忙？
因为第一个格子数就是会决定答案是对还是错。如果我们
8还是7啊？
它是一定能除得进来的，对不对？
对，答案是一个整数。
7
吗？
你像7乘4的话就28。
对，好，7、8。
好，28。
你们是不是忘记你们是竞争对手？
没有，这个就是
开始小组会议了。
前面弄完，后面算出来都不一样。
对，所以刚刚有人讲说，7哦，
对。
后面有人这个样子。
起手开始的生命值。
一场是10个吗？好，没人要帮
还是我算错？还是我算错？我开始怀疑自己。
5，就这样。
4、3、2、1
，Number 4。
4，
有意思，兄弟，
英雄惜英雄。
你们为什么写9在第一个？你们刚不是说7？
7啊，
有4排啊。
对，4排。
第一排有9，那9乘以4啊。他是16，唐老大。
你算16，
对，
但是你28不知道加多少，所以8算16。
对。
那我们公布答案16。为什么你可以算对？
因为我在想是50还是100，然后50我除不进，我就想说100吧。
哦，就是100。
哦。
哇，7格7、4。
哦，它是7格哦，我以为是9格哎。
9格是下面的那个英雄。
它这个有分的，哇，那么久我都不知道。
你有道具了哎！
你很专业哎。
道具啊！
我们恭喜唐老大得到我们的鹅骑士手牌。
哎呀！
那我说一下这一题哈，联盟战旗的棋盘中，一开始可以摆放英雄的格子数是28格，一开始起手的生命值是100，相加就是128，然后联盟战旗一场的玩家数呢是8位，所以呢除下来呢就是16。那我们恭喜唐老大得到机会题，
这个能答对很猛。
那我们7题结束的分数呢，铁牛跟唐老大紧追在后，小熊第1名，丁特。加油啊！
老哥，你还好吗？
没事，
还要被你拉仇恨。
没事。
第8题选择题1分。统神因为擅长使用古拉格斯，俗称9筒，而有亚洲统神之称。在游戏中，古拉格斯是用哪一只手拿9筒？A 右手，B 左手。
1/2题，
然
后要演一下。
对啊，
应该是这个吧？
是这样喝吗？
锁定答案，不换。
A 或 B，A 或 B， 写个右。
这是你 man 的，如果你这题你错的话，你
对，自信答，
自信答。然后来，请大家公布手上答案。A B， 只有刚刚答对的唐老大选择 B， 答案是 A 右
手抱着，没错。
不要拿起来喝嘛。
第9题也是选择题1分，唐老大也要使用你的特殊道具吗？不要。好，为什么不帮我放大绝吉林？请问吉林大绝的效果是？这里有点算送分啊，因为我相信各位一定都会。A 复活时光结界的目标 ，B 蓄集能量向前发射一束光波 ，C 立即恢复附近友方的生命值 ，D 暂时传送至附近新的位置。
这题是送分，这才是送分。
这是 B 吧？
不是 B， 我觉得是 C。
我觉得你们都先想一下，
应该就不用再有作答的时间了。
我记得是回旋，对啊。
传送。
请各位公布自己早就写完的答案，
再演就没意思了。
答案是 A， 没有错。
不是光速吗？
吉林大绝是可以复活时光结界的目标，然后他放了大绝之后呢，他被打死就可以复活。第10题选择题2分。那唐老大，如果你要选择道具，就是在这个时候就可以使出来了。就是我在讲的，还没有，就 hold 住哈。努努和灰狼虎的大招是绝对0度。
对，是嘛？
请问绝对0度是摄氏几度？A 0度 ，B -4度 ，C -273.15度 ，D -327.67度 ，C。
这个答案会很白痴吧？
小龙直接来一个嘲讽。
他是担心我是白痴，这个答案会很白痴。
先讲出来就不白痴。
绝对，感觉数字要选大一点点，对不对？绝对。
我觉得它0度哦，
他都
逻辑是这样子吗？
真的假的？绝对0度哎，不可能。
不就0度吗？
真的吗？
绝对。
绝对
0度。
答案出来，你们不要不是。
你们是在演戏还是真的没有读书？
都抓不到，对不对？
没读书。
相信自己。
我该不会真的是白痴？
这个答错会被笑吧？
可能会被 观众前面的莘莘学子们说，这个角色不是有教吗？
假的。你在用你的学历，
可恶！
太高中了吧？
可是我觉得实力不够，那个运气来凑。来，我准备
看起来最有可能的。
我给他一个最爱的，我觉得他一定最冷。
好 ，D C C A，
哎，大家都有 A B C D， 哎，这有人选 A，
小熊真的选 A，
极致冷，
绝对
，so cold。
正确答案是。
呀，那
小熊中招了吧？
中招！
我也就选数字大一点点的。
我被智商攻击。
可恶！
绝对耶！
努，威老姆，你们也没那么冷嘛。
至于负4度 C 呢？对，没有，4度 C 是那个密度最高啊，不重要，不重要。第11题填充题，要写答案哦。谁的技能每一招结尾都是惊叹号？请写出这位英雄的名称。
惊叹号。
你看他的技能，每一招都是一个惊叹号。
中文吗？
中文，他中文结尾都是一个惊叹号。
都是一个惊叹号。
要不然给个提示，女生。
我觉得应该是我写的这个。
好，小熊早就写好了就对了。公布各自的答案哦，每个人都不一样哎。瑟拉芬、萨米拉、安妮、吉因科斯跟露露，有一个人答对。
我觉得是我，我觉得是我，我觉得是我。
答案是吉因科斯。
全部都是，
真的哎，空照，第一招快力尽快。
哎，怎么你唱歌没有惊叹号啊？
这个能猜就很猛哎。
小熊为什么你知道？
因为他都有什么碰碰、抱抱、什么撒尿尿，我记得。
再问一次，我刚刚是选小熊的冠军。
第12题选择题，这里3分哦。
要用吗？要用吗？
要用了。好，大家使用我们的特殊道具。
我要故意写一个错，然后很明显让他看到。
把人家无情单杀、无情双杀的蛮王泰达米尔，他的被动技能是战斗狂怒。每次攻击、暴击或击杀单位都可以获得怒气。那我们一般人有怒气的时候呢，可能会口出恶言。
对，
请问下列哪一个公然用词会判下最高的赔偿金额？
我记得有点，我记得有点。
见人就是绞刑。B 人渣公务员。D 塔卡杯赛。
最高赔偿金额。
这4个来讲。哪一个曾经被判下最高的赔偿金额？
对我来讲很难，因为我是香港人，我不太懂。
我直接拉扯。
这个有很日常的选项。对呀，我觉得我好像有看过这个新闻，有一个网友做出一个表。
哎呦，他是有表格的，骂人的价目表。
我记得有香蕉。
法官有自己的一套评判的标准。
我被骂到哪一个会最不爽？谁敢骂我贱人？
谁敢说我头壳装屎？
所以现在就填了，已经亮出答案，你在带这个风向。
对，我在带风向。
所以我可能不会抄。
我选好了，
好，来，请各位公布答案。
好。
A D。
好，头壳到底有没有？
关键人就是小晴，要不然就是塔卡杯赛。答案是 B。
想猜 B 的。不用钱嘞，
不用钱嘞，
是语助词，有的时候情绪来，什么？
人渣
干嘛
？A 是见人就绞刑，曾经被罚到5万；人渣公务员曾经被罚到30万，是我们这些答案。
这个是仔细想想，那个其实超过分的。有人
那新闻上写说那个字，其实也是0元的，因为法官那时候判定说它就是一个台语的发语词。那这一题呢，汤老大很可惜，
还好，
可惜呀。
再来第13题，填充题1分，请分别写出拉姆斯在 Ban and Pick 中被选择以及被 ban 的语音。
这个是送分给丁特，他很常用这一支。
可是他的那个英文是什么啊？他的英文是什么啊？
编的语音，
编的语音，
真的我不知道哎。
这个1分，
中文
是不是有点太少了？
我以为这是很简单的题目。
答案很简单，
答案很简单。好，来，请公布各自的答案。
有点可梦的概念在里面，对不对？
就看我大写拉姆，
出自己的名字，拉姆，
绝对不可能是拉姆。
他以为他被选是乌龟，
你知道他其实不是乌龟吗？他是狗鼠。
它不是刺猬吗？
所以这里答案是就是
OK。
那小熊我觉得算对，因为你知道，你今天才知道是 OK。
对，我一直以为是乌龟。
乌龟。
但是我刚刚已经用那个奥博 A 拿了3分，我不好意思再多拿这1分。
但应该 OK 啦，我觉得算对。
那小熊倒扣1分。
我同意。
你们算我对，然后我把频道删掉，这样就没有违反规矩。
玩这么大，那我们现在小熊拿出手机，我们。Death is like a wing, always by my side。亚速开滑，物体要能够滑起来，必须克服最大静摩擦力。如果水平推格禁止物体力为 F 跟摩擦力的关系为下列哪张图 ？X 轴为 F，Y 轴为摩擦力。
好，反正绝对不会是那个嘛。
哪个？
就看起来比较聪明，你知道吗？反正绝对不会是那个。
A 是一个对 A B C D 有点难叙述，
好难哦，
是不是？观众朋友们、小朋友们先念书，不然长大呢就会跟叔叔阿姨一样。选手们请公布自己的答案。
随便选选咯。
A B A A C
这个概念是
有人选
C 有点看不太懂
吗？像我没读书啊。
C 跟 D 都有点抽象。
答案是就是 C。哇，这一题呢，来你知道吗？你知道哦，竟然知道。其实对，因为 F 跟摩擦力呢，在不动的情况之下呢 ，F 跟摩擦力是一起上升。当突破最大静摩擦力之后呢，它就变动摩擦力，它就会一直持续的就是动摩擦力。
我们是那种键盘酸民，你知道吗？就在那边说白痴，这谁不会烂死？
然后选错。
这题恭喜唐老大一个人得到2分，
很棒，好。
那现在14题过去了呢，现在分数都蛮平均的，其他小熊
还有机会，
遥遥领先，对，还有机会。True Damage 真上乐团的团员基亚娜，造型是哪个品牌的设计师所操刀的 ？A. Prada B. Louis Vuitton
正确，厉
害。LV C. Gucci D. Chanel
厉害。OK， 我们用那个去想，他的武器是不是圈？
所以不会是 Prada 跟
LV。
所以现在是班上的那个
武器长得比较像 Gucci。
因为它不是
那个形状，
我
对耶，
我真的不行，因为我的角色都是怪物跟男角。
可是
我听你们的，
是它的外套很 fashion，
很爬哩，很 fashion。
哦，你是说其他3个不是你选的不 fashion？
不是，就是它的那个，我懂，老花。
唐老大，你现在是人家只是第3名，确定你要把你自己的知识传授给别人？
我有可能是误导哦。
因为我们在都只懂得打打杀杀，这现在真的不懂。
这个随便，
这个随便。
谁设计过？
但我忘记是。
好，请公布自己的答案。来，品头选 Prada， 花轮选 Gucci， 丁特也是 Gucci， 这2个人都是 LV。
我先信唐老大。
正确答案是 LV。
你超棒的，这就是信任，可以得到的最好回报。
太厉害了！
为什么他们都懂啊？
因为我们平常没在买包。
我还顺便把2个人拉下水，再给答案。发现了，
带着大家上狮子练，
被他洗脑了，真的蛮像的。
第16题，最后5题哦，选择题3
分，
哇，3分，干爹的题目要会啊。联盟战旗 S10的版本名称叫做 A 变种大乱斗 ，B 音乐大乱斗 ，C 明星大乱斗 ，D 一起大乱斗。
绝对是一起，大家都一起，大家都一起。
是这次的版本吗？
对，
没有错，
跟朋友一样一起玩战旗，
一起大乱斗。
啊，请公布自己的答案。
等。
小熊最后改了 C，
我没有改 C， 是因为我本来写成这样，我怕你看不懂。
为什么你只有小熊选 C？
因为一起大乱斗看起来像是我刚刚在乱讲的，然后音乐大乱斗我记得出过了，就有那个会听音乐 DJ。
那这题的答案是音乐大乱斗。
没事，小熊没事，没事啦，没事。
你分析了，
谢谢小熊，
分析的挺好的。
我们家小熊就是善良，会做效果。
小熊这波让啊，
太让了，
让完的那个分数现在目前蛮平均的。
谢谢。
第17题，选择题2分。This is an apple. This is a pen. Apple Pen，Apple 跟 Pen 合在一起叫做 Apple Pen。在联盟战情中，2个锅铲合起来的道具叫什么 ？A. 白金皇冠 ，B. 起手皇冠 ，C. 2只锅铲 ，D. 超巨大锅铲。
这个真不可能再错了。
2只锅铲
可以支援吗？
对，超巨大。
铁牛是认真的在讲，
这真的可以支援吗？
铁牛他的题目已经有那个告诉你答案了 ，Apple 跟 Pen 合在一起就是 Apple Pen， 锅铲跟锅铲合起来就是2只锅铲。
锅铲。
我选 D 耶，超巨大，要换吗？
我 我觉得差距大也有你的道理在。
是2只锅铲吗？如果真的是我蛮挫的，要换吗？现在不帮哦。
你刚刚意见真的多。
请公布答案。哦 ，D B B B B。
铁牛不错，
铁牛不错，
你真的选超巨大。
我刚刚前面有讲，我只玩了3个月。
我不是叫你选2只锅铲吗？怎么还是选 D？
好了，我换一下。
答案是 B 骑手。
不错，应该好尝试。
辛苦你。
第18题，填充题2分。丁特本名薛宏伟，前英雄联盟电竞选手，曾效力于 TPA 台北暗杀星，请选出暗杀者（刺客）的英文。丁特 OK 吧？
写很快耶，丁特。
这样不要丢脸了。
大家应该都看过这个单字，
有点难度，
请参赛者亮出自己的英文。
希腊文吗？
要吧？练得出来吗？
我觉得我是差不多的，但是我应该是错。
Assassin， 哦，都是 assassin， 你干嘛？手拿掉，你手拿掉。
我多一个啦。
很可惜，没有人答对。
丁特写很快的，
丁特写很快，
也写，
但丁特的那个字母顺序有点反。
反了。
不可能，丁特不可能说，他就写超快的，而且他看过这个队伍，他
听我直接写的，不可能错。
曾经是在里面的一员，他不会错。
说起台湾英雄联盟，想起谁？
有可能是我错。
怎么可能？他代表暗杀星的刺客。
辅助起家，你敢信？
答案是 ASS。
少一点我这样算1分吗？
没有。那这个词要怎么背呢？就是 SS。屁眼进去，可能会被删掉这段。最后2题，第19题。等一下，
怎么了？怎么了？
图片忘记拿掉。
我看不到。
我们相信凭实力。
没错。
联盟精灵尔骑士的披风是蓝色，请问下列哪一项东西不是蓝色 ？A. 艾希的弓 ，B. 瑟拉芬的翅膀 ，C. 提摩帽子上的毛 ，D. 西格斯护目镜的镜片。
不是蓝色。
不是蓝色。
瑟拉芬有翅膀的吗？
对啊，我也在想瑟拉芬。
提摩的毛。
提摩的毛。
瑟拉芬有翅膀。不是人吗？
这些东西全部都是他们一般造型。
用猜的好了。
瑟拉芬的翅膀，
应该是他的翅膀吧？看起来像翅膀啊，长。瑟拉芬有翅膀吗？
我印象中瑟拉芬好像没有。
那应该叫背饰好了，它的背饰，它应该不是翅膀，它的背饰。那没关系，因为今天呢裁判说了算。好，请各位公布。
透明或粉色。
应该是它粉色。
铁牛选瑟拉芬的翅膀。
瑟拉芬的翅膀。
你觉得它不是蓝色？
我觉得不是蓝色，应该是粉红色。
应该是粉红色。
可爱的女生都是粉红色。
花轮选择西格斯护目镜的镜片，
因为镜片蓝色都看不到东西。
哦，就看不到东西，
我觉得比较合理一点点。
逻辑大师。
对，因为我也戴眼镜啊，如果是蓝色镜片，我是看不到。
所以你觉得是透明？
可是他是约德尔，他不一样。
我也是约德尔。
丁特选择艾希的弓，你觉得艾希
的
蓝色？
弓是绿色的。
绿色的弓。
他妹艾希的，我记得他以前是玩。
里面艾希，
其他角色我都不太确定。
小熊也选择瑟拉芬的背饰，加拿大选择提摩帽子上的毛。答案是西格斯护目镜。这是艾希的弓，蓝色。瑟拉芬，我以为是翅膀的东西，它的那个背饰。
它太粉了。
提摩帽子上的毛，
这有毛啊！
它有毛是蓝色。
西格斯护目镜的镜面是
绿色。它有毛。
是蓝色。
西格斯护目镜的镜面是
绿色。
好，19题结束呢。现在铁牛11分，花轮16分。哎呦，花轮追上哎，
专打后期，专打后期。
丁特12分，小熊16分，唐老大15分。好，在这一题填充题3分。
哇，关键局。
英雄联盟中可以自己设定技能的热键，曾经3度获得世界冠军，并且是 LoL 史上第1位获得大满贯的选手 Faker， 他把闪现技能放在键盘上的 F。请问 F 跟键盘上同一格的注音符号是什么？
对啦，
我的键盘没注音啊。
啊，这个对，可能对花人比较不公平一点。
注音是那个什么 /p/p。
对 /p/p。
因为我昨天有看那个动漫，然后我用那个注音去搜寻那个名字。
你跟我讲你想要什么，我跟你讲。
我觉得是这个。选手公布自己的答案。7颗7啊，诗还是7？等一下，那是什么？哦，想要学小学招啊！
原来这是女性特权，那我查查。
哇，这个
太特别，我都不想说，刚刚有一题是为了你设计的，你看。
火药味很重，火药味很重。
但唐老大，你还记得 C8 是什么吗？
对耶，
哈哈，
我错了。
有人是对的，
有人是对的，蒙对了。
好紧张，好紧张，
什么？
答案是7。
很厉害！
哎，我真的对哦，连香港人都对了，
很厉害。
我昨天动漫有搜寻过这个字，
你是唯一一个认识的注意。
对，
乱写，我是凭实力写出来的。
我是靠蒙的，我是靠蒙的。
那我们20题结束呢，分数是铁牛11分，花轮19分，丁特15分，小熊16分，唐老大15分。那我们恭喜最后下半场追上的花轮，大乱斗的冠军，
实力不够，运气来凑。
恭喜！恭喜我们今天的冠军花轮，颁发奖状。
哎，我我觉得今天能拿这个冠军真的是很靠塞，像是什么提摩的头发是蓝色的，我都不知道。对，这种东西我觉得要回去再科普一下。没错，
直接带到其他，我们一位一位来访问。好，铁牛，
公审环节，
是参赛心得。
我觉得你出题非常棒，前面都会带一些不一样的风向，然后后面都用英雄联盟来结尾，这就是一款非常棒的游戏。
很正面，很正面。
熊姐，
其实我刚刚输的时候，其实觉得蛮冤的，想要怎么会这样说？后来仔细想想，我的乌龟跟我的 A 应该都不能算对，所以就觉得心情好像稍微平复一点的。然后希望大家可以跟我们一起大乱斗，耶！一起大乱斗，是音乐大乱斗，
记得大乱斗，
好在意，
丁特，
我觉得有点愧疚，对不起我的英文老师。
没关系，
大家一定要好好学习，然后一起玩英雄联盟，联盟正局有手机版哦，
耶！谢谢丁特。最后一位唐老大，今天你原本已经有做赛前练习，
有，我还找我表弟，然后搂友们，我们还在群组互相丢题，
结果有猜中题目吗？
没有。
同步也颁发我们这次冠军的礼物，骑士的玩偶，还有
好棒！
英雄联盟滑鼠垫，
好想要。
这个都给你，因为这些都是大家一起的，对不对？然后记得要支持英雄联盟，还有联盟战旗，加油！
谢谢各位观众朋友看到最后，那联盟战旗手机版已经上线了。那就这样，那我们下次大乱斗
换新角度录影，希望大家习惯。2023算是电影产业疫情之后的复苏元年，很多期待已久的好莱坞大片呢，都是在今年上映的。那其中 Barbie 就创下了14亿美金的惊人票房，是本年度票房最佳电影，也是华纳兄弟发行电影中的最高纪录，非常的惊人。同档期对抗的这个奥本海默呢，也是有个9亿美，表现也很好，戏院中又活络起来的感觉。虽然本频道最近好像一直都有点厌世，好像一直在给电影负评，大家可能会想说，那其实我还是有看到很多我很喜欢的电影啦，只是就是这种我比较不会做成长片，可能会放在 IG 之类的。今年呢，我是真的看到了很多我觉得很不错的电影，那今天就趁着年度10大来把这些好片分享给大家。第10名，宝可噩梦 Beau is Afraid。大家知道我一直都很吃那种猎奇电波的那种怪怪电影，那这个 Ari Aster 他的前面2部电影就是《仲夏夜》跟《夙愿》，我都超爱。果不其然，宝可噩梦看完之后我也超爱。这部片呢，完全就是给疯子看的，一点逻辑都没有，很像身临其境到这个男主角的噩梦之中这种感觉，一步一步让你伴随男主角一起崩溃。我特别喜欢整部电影第一幕的那个噩梦情境，他描绘的是那种被害妄想症、内心无比脆弱的人，他眼中可能看到的世界，然后用一切很超现实猎奇的方式去呈现。总之就是超级酷，推荐给看腻这个商业大片想要换换口味的人，是一个很有趣的体验。第9名，黑的教育 黑的教育呢，我自己当初看完就觉得蛮喜欢的。那原来我不觉得它有到年度前10名的程度，但是我这一次列这个清单呢，我就认真回想自己今年度看的电影。这部片确实是我今年看完印象最深刻，也获得最多观影乐趣的电影之一。它剧情很简单，就是3个幼稚的高中生大冒险失败衍生的一系列荒腔走板，然后最后差点引来杀身之祸，最后要付出惨痛代价的故事。那整部电影呢，甚至不到90分钟，很短很精简。黑的教育别的不说啦，就是节奏抓得非常好，是一部你会看到紧张到手心冒汗的一个黑色小品。现在在 Netflix 看得到，很值得一看。第8名，《龙与地下城：盗贼荣耀》（Dungeons and Dragons: Honor Among Thieves）。Oh no！ 跟我一样，平常理解英文没问题，却口说有障碍，除了沟通害羞之外，也无法发音标准吗？推荐想要努力提升英语发音到母语程度的你。Elsa Speak。那我们想要练习口说的话，可能就还是要找那一种实体的老师，或者这种小班制的线上课程。但是我们这种社恐人呢，平常话都已经说不好了，还要在其他人面前说英文，然后面对活人，难免还是会紧张一点。那这个 Elsa Speak 呢，就提供了 AI 英语学习功能，上面有超过1600堂课和40种不同的主题，用英文母语的标准去审视你的英文发音还有流畅度。What new flavors do you guys have? 这样就有83%咯。除了英文发音呢，内建的 AI 口说导师是真的可以跟你进行像是真人一样的对话，并且给予你专业的反馈，让你知道你的口说可以如何改进。我来选一个 conversation 的情境。
I'm so excited for our beach trip today.
Me too. It's gonna be blast. What time does the train leave? 好好玩哦。好，再试一次。Me too. It's gonna be a blast. What time does the train leave? 这样只有76%哎，好严格哦。我就是 TH 的音，我就是始终发不准，每次只要发字的那个音都会被他纠正。里面超级多对话情境，从办公室到购物，到平常朋友闲聊，甚至到恋爱都有。实测这个看起来很酷的这个恋爱情境，好不好 ？Online dating 好了。
Hey, you look familiar. Do you know Luke Johnson?
I do. How do you know him?
I do. How do you know him?
哦，他是 How do you know him? How do you know him? Okay. Small world. I work with him now. Wow. So how's your night going? 讲得不流畅也会被他讲，不行。除此之外 ，Elsa Speak 还会根据你的个人上课情况制定最适合你的专属课程，真的超级聪明，推荐给每天都想要练口说的人。今天有专属优惠要来分享给大家，就是只要用这个 QR code 下载，或者是用资讯栏下面的第一个链接下载的话呢，就会有7天的免费试用。如果你试用之后觉得还蛮喜欢的话呢，就可以用下面的第2个链接下载，就会有第1年的6折优惠，或者是终身的1.5折优惠，非常的划算。那这几年讲到商业娱乐片，好像都是一些番外或是续集，在你觉得到底有完没完的时候呢，《龙与地下城》就是起了一个头，开启一个新的世界观。在去年的商业大片中呢，算是比较耳目一新的存在，同时呢，也完美示范了什么是一部好看的商业片。可惜的是呢，它的全球票房表现好像不是很好，还不确定会不会有续集。奇幻题材呢，在台湾就是都蛮不受欢迎的，但是这一部呢，我觉得大家一定要给他一次机会，真的很好看又不流俗，然后他的每个角色的塑造都很讨喜。Chris Pine 就真的很北蓝，很好笑，然后 Sophia Lillis 她演的那个德鲁伊小女生也很可爱，就是那种看完心情会好的娱乐爽片。现在看完能够让我 feel good 的电影真的很少了，这部是真的很好看。第7名 Barbie。老实说，芭比在我心中并不是一部传递什么重要讯息对我意义的大作。论这个女性主义的探讨的话，我觉得这一部的说教感还是有点太重，探讨男女困境的方式呢，也比较生硬尴尬一点。但它的确是一部让我看得很开心的电影。 我喜欢粉红色的芭比世界，我也喜欢马格罗比饰演的典型芭比，我也很喜欢 Ryan Gosling 他演的阳光肯尼，娱乐性很足，视听效果呢就是很令人舒服，很享受。那我得承认呢，我自己看完这部电影之后，我是觉得蛮可爱蛮喜欢的，但我真的没有料到它可以卖这么好，14亿美金耶，天哪！14亿美金是什么概念？是影史票房的第14名耶，比黑豹还有冰雪奇缘都还要高，完全是现象级的一部电影。第6名，奥本海默 Oppenheimer。自从天能让我完全看不懂之后呢，我一直有在对诺兰生闷气。看完奥本海默之后呢，我花了一段时间才比较愿意承认还蛮喜欢的。那诺兰说故事的功力依然在线，人物塑造饱满扎实，推进剧情的方式呢平稳又不失趣味。整个核弹研究的过程在诺兰的镜头语言下呢，显得格外有温度，用各种角度去侧写这个成为死神的男人。那我不是一个爱看传记的人啦，但是你如果需要一部电影示范什么叫做把一部传记电影拍到登峰造极，那奥本海默就是一个过100年之后你都还是可以拿出来端详一番的一个模范生作品，真的是很优秀的一部电影啦。第5名，亨利·休格的神奇故事 The Wonderful Story of Henry Sugar。亨利·休格的神奇故事呢，是今年魏斯安德森在 Netflix 推出的4篇短片作品的其中一部。那片长就短短的只有40分钟，描述透过瑜伽冥想训练而得到透视超能力的这个男主角 Henry Sugar， 靠他的能力诈赌赚进上亿的神奇故事。这个故事呢，改编自这个罗尔德·达尔的同名著作，整个微电影都是用类似舞台剧的方式去呈现的，连角色念台词呢都很像是在读本一样，就很有趣，有一种讽刺的逗趣。画面就是典型的 Wes Anderson， 缤纷可爱，赏心悦目，就很适合配饭看，很推。苍鹭与少年 Kimi ta ja do kiruga。 如果你是看完苍鹭与少年一头雾水的那种人，没有关系，我也是。其实我觉得《苍鹭与少年》呢，真的也是一部感受大于逻辑的电影，就是整个故事太超现实了，你试图用理解的，只会觉得它到处都不合理、不好看。那这部电影的魅力呢，在于去感受宫崎骏设计出来的这个奇幻世界，台词中的温暖，角色的成长。那宫崎骏的电影呢，常常就是创造出一个看似让你逃离现实的世界，但其实最终的意义是要你去勇敢面对现实的残酷。发现没发现爱这样，回到家就是一个人静下来，然后播个米津玄师的地球仪，然后连续播个这样10分钟，你就会想通了。鬼手鬼手请开口 Talk to me。 鬼手鬼手请开口，我看完真的睡不着，认真睡不着。这部电影诠释邪恶的方式太真实、太恶心、太恐怖了。很多中邪的人的呈现方式呢，不是我们在恐怖片里面常常看到的什么吐虫啊、吐黑色的血啊，是一种很痛、很诡异的方式。那怕被黄标，所以我就没有详述了。总之就是会看到很不舒服就对了。你会相信这就是现实生活中人中邪会有的样子就对了。那整体来说呢，这部电影也是蛮有创意的，是一部让你眼睛一亮的恐怖片。喜欢惊悚的人一定要看，它就是可以满足你的猎奇欲的同时呢，它的故事也是有一定的水准。我找到第几名了？第2名。第2名是蜘蛛人穿越新宇宙 Spider-Man Across the Spider-Verse。 蜘蛛人穿越新宇宙有多好看，应该就不用我多说了。这部片就是集所有超级英雄片讨喜元素之大成，它描绘的是一个很复杂在多重宇宙中跳跃的故事。前一集被大力赞赏的作画风格呢，在第2集也升华了，让不同的角色的宇宙都有不一样的美术风格，而视觉上呢，完完全全的炫技之作。那故事面也带出了 Miles 在终于认同自己蜘蛛人身份之后，再一次面临更加棘手的存在危机。可以想象第3集的走向呢，会更有层次、更有趣。是就算拿到超级英雄影剧泛滥的这个现代大荧幕上呢，依然非常出彩的一部动画片，非常厉害，值得第2名。第1名，噔噔噔噔噔噔噔噔噔噔噔噔，从前的我们 Past Lives 我自己也非常意外，这部我在飞机上面看的电影会是我今年度看完最喜欢的一部。他故事描述一对男女数十年来经历的分分合合，他明明感觉命中注定，却始终无法走在一起。非常凄美之外呢，说故事的方式也很有灵魂，安插了不少琐碎的生活片段细节，大大增加了观影时候的代入感。那这部电影很棒的地方是呢，它会在对话中保有呼吸的节奏。有时候两人聊天聊一聊会静下来，突然安静个2-3秒，就很像是现实生活也会有的对话一样，所以观众就有点像是在偷窥一对真实存在的男女一样。那他对缘分还有前世今生的描绘呢，也很浪漫，看到最后很无奈，但也会感慨人生就是如此。那爱情也不像小时候我们在偶像剧中理解的那样，有时候共度一生的人不见得是最多化学效应的，而是在你选择的道路上能够陪伴你的。这部描绘的不是那种干柴烈火式的爱情，却有一种荡气回肠的凄美。我看到在飞机上哭出来，下飞机了都还在哭，真的不是一般的好看，很好看。好的，以上就是本年度的年度10大了。其实有一些遗珠是我想看还没有去看，像是可怜的东西还有梦行者保罗，可能就会到明年的年度10大吧。好的，那今天影片就到这边啦，我们就下次见啦。或者是你自己有看到什么觉得很好看的电影，我没有选的，也可以在下面留言跟大家分享。那我们就下次见了，拜。
的人都杀害老人、妇女。
Hello， 大家好，我是塔塔。冬天就是要吃一点厚重疗愈的食物，最近特别想吃牛肉，今天就来跟大家分享这道超级好吃，但是做法有一点点麻烦的匈牙利炖牛肉。你可以搭配饭或者面包、意大利面都非常好吃哦。先来处理蔬菜的部分，洋葱先切对半，然后再切成细丁。洋葱可以为汤底带来自然鲜甜的滋味。今天我们大概需要2颗的洋葱，大概是300克左右。这些洋葱丁熬煮到最后都会溶在汤里。红萝卜就1条的分量，先分切成2等份，然后再切成喜欢的大小。这里准备1颗红椒，我这个比较大颗一点，所以我用半颗的量。红椒也是非常甜的蔬菜，非常适合拿来熬煮。如果你真的不喜欢红椒，那就把分量替换成番茄就可以了。把红椒先切成条状，再切成丁。番茄的部分我会先去皮，这样到时候煮完番茄皮就不会浮在汤上面。粗略的切成小块状就可以了。准备4到5瓣的蒜头，剁成蒜末。蒜苗、蒜白的部分切成薄片。等一下跟洋葱一起炒香。我觉得这道菜来一点辣会更好吃哦。这次我准备了一部分的牛肋条跟牛腱来炖煮。把牛肋比较肥的部分先切除下来，不然汤真的会很油哦。但是呢，不要去得太干净，因为我们还是需要油脂带出香味。粗略的切成大块状，这样煮起来比较好吃。这边我准备了1条牛腱心，这样搭配起来会比较丰富。你也可以全部都用牛肋条来做，但是不要全部都用牛腱，因为牛腱没有油，香味会比较少。大致上呢，就切成大块状，像这么大块厚厚的样子，然后再切开1刀，接着在每一块肉上划上1刀，这样炖煮出来的牛腱会比较柔软一点。准备1锅水，水里放入一些姜片、1点酒去腥。冷锅的时候把牛腱放进来汆烫，去除血水。大概看到汤上面布满浮沫就可以捞起来了。捞起来之后用温水稍微冲洗一下，用一个盖子盖起来，预防水分蒸发。牛肋的部分我们就不用汆烫的方式，来一点盐跟黑胡椒调味，再来一点综合香料增加香气。香 让手搓揉均匀，将味道吃进去。现在撒上一些面粉，包裹住肉块，用手轻轻地拨动一下，抖一抖，让肉块均匀地裹上一层薄薄的面粉。处理好后呢，就先放在盘子来准备煎肉了。刚刚切下来的牛油不要浪费，用它来煸出香味。煸油的时候可以加一点橄榄油进来，这样会比较快出油。这些牛油会慢慢的释放油脂，然后就会变成像这样一块一块干干的样子。把牛油都取出来，锅里的油也取出一半，先放到碗里备用。火力调整一下，用中小火来煎这些牛肋。其实不裹面粉也是可以的，但是牛肋条沾上一点面粉来煎，除了比较不会喷油之外，牛肉的鲜味也会锁在里面。大致上一面煎出焦香，再翻面煎，最后翻炒一下就可以取出来了。锅子先放一旁，换上一个铸铁锅，开中火加热，把刚刚预先保留的牛油放进来。接着把洋葱跟蒜白放进来炒。如果你觉得油不够多，可以再补一点橄榄油，没有关系，因为我们蔬菜很多，还是需要足够的油脂。来一点盐跟黑胡椒调味。大致上炒到洋葱呈现半透明的样子，把蒜末跟辣椒放进来。继续炒到洋葱颜色有点偏黄的样子，现在就可以把红萝卜跟红椒放进来了。先把这些蔬菜跟锅里的洋葱炒出香味。如果你有新鲜的香草，这时候加一点会更棒哦。把刚刚的牛肋放进来，先充分的拌炒均匀。再来一点烟熏红椒粉放进来，炒出香味。烟熏红椒粉我是用辣的，不能吃辣的呢就买甜的。都炒匀了之后，再把刚刚的牛腱放进来，稍微的拌匀就可以了，让所有的肉块都均匀的裹上锅里的蔬菜。这里呢，记得我们锅底必须是干的，因为我们要在这时候呛入红酒，把锅底的香味呛出来。火转大一点点，把所有的料拨回来，让料都沾到红酒的香。一定要把酒煮沸，这样酒味才会蒸发掉，不会发苦。如果你担心你的红酒太酸，可以补一点糖进来。现在呢，把番茄丁放进来，拌匀一下，让番茄软化。加入适量的热水或者高汤也可以。如果你手边有月桂叶的话，放2片进来一起煮，味道会更香。等汤都煮滚了之后，锅转到最小火，盖上锅盖，慢慢的炖煮1个小时。因为汤里有淀粉，所以火不要太大，不然很容易烧焦锅底哦。等待的时候来处理马铃薯的部分。将马铃薯先切对半，然后滚刀切成大块状。马铃薯大块一点，煮起来会比较好吃。哦，这边汤已经煮好了，哇，好香哦！整个颜色跟香味都出来了。目前牛肉还不够软，但是蔬菜都融得差不多了。现在呢，把马铃薯放进来，轻轻的翻动一下，让马铃薯浸泡到汤汁，再补一点盐调味。这时候把火转到最小火，盖上锅盖，继续炖煮30分钟。时间到后，关火再焖个2个小时，味道会更融合。好了，我已经等不及要吃了，开盖，哇，好香哦！看到咕噜咕噜的一锅，肚子就饿了起来。现在马铃薯已经炖煮得相当松软又入味，来试喝一下味道，做咸味的调整。像这样超好吃又非常疗愈的匈牙利炖牛肉就完成啦！搭配一下绿花椰，看起来会更加的美味。这道匈牙利炖牛肉虽然准备起来有点繁琐，但是非常值得一试哦。 好啦，看得我口水都要流满地了，那我就开炖喽。这个牛腱已经炖到非常软的口感，一点都不柴。虽然2种不同部位的牛肉处理起来有点麻烦，但是最后汤不会太油，牛肋、牛腱的味道融合在一起，非常好吃。马铃薯的熟度煮得刚刚好，裹上牛肉的酱汁，好吃极了。好啦，今天的影片就到这里。喜欢我的分享，记得帮我点赞，让更多人可以看见优质的影片。那我们下次再见，拜拜。
My name is Ella. I'm used to just learning math, head down, and watch a lot of YouTube. Brilliant is
历史焕颜霜。
Hello everyone. In this video, we're going to be looking at an exponential equation. We have 10 to the power log x squared plus x to the power log x equals 20. This kind of looks like a very non-standard problem because the bases are different, the exponents are different, and how are these two functions related, right? We should be able to kind of combine them. So let's go ahead and take a look at the graph of these two functions, and then we'll talk about it. So here's the graph of these two functions. What is that supposed to mean? So let me go ahead and explain what this all means. Now we have two functions here, 10 to the power log x squared and x to the power log x, and their sum is 20. Normally you wouldn't be able to solve this problem because these two expressions are very different, maybe, right? The bases are different, so on and so forth. But here's what we're going to do. We're going to try to relate them using either substitution or something else. So I'm going to go ahead and show you the substitution method first, and then I'll show you a property that's very helpful. So let's go ahead and call log x something. How about setting log x equal to y? Now this gives us 10 to the power y squared plus, now what's going to happen to x? If log x is equal to y, by definition, remember, this means base 10. Did I say that at the beginning? Maybe I did forget. But log x is basically in base 10. And then you can use the rule 10 to the power y equals x, or x equals 10 to the power y. So this x needs to be replaced with 10 to the power y. And then, of course, I need to raise it to the power log x, but log x is just y. So, and you're like, why is this happening? 10 to the power y squared plus, now you multiply these exponents, don't you? Y times y is y squared. That's going to give you another 10 to the y squared. And this is kind of interesting, don't you think? Okay, I'll explain a little bit what that means, but hopefully you already got it. Now notice that these two things are equal. So I can just write this as 2 times 10 to the power y squared equals 20. And then dividing both sides by 2 yields 10 to the power y squared equals 10. And from here, we get two solutions. What are they? Y squared is equal to 1, and that means y is equal to 1 or y is equal to -1. In other words, there are two numbers whose square equals 1, 1 and -1. Of course, we're kind of talking about the real world, but even in the complex world, that's the case. Except for, adding multiples of 2 pi and so on and so forth. Now, we got these two solutions, but what is y? What is the relationship, right? Well, x is equal to 10 to the power y. So from here, we can find the x values. X is going to be 10 to the power 1, or x equals 10 to the power -1, which can be written as 1 over 10. So it looks like there are two solutions. One of them is 10. The other one is 1 over 10. and that's it, right? So let's go ahead and go back a little bit and kind of explain what is going on with the graph. These two expressions actually are identical. That's why when I graphed them, I kind of had to use a dotted line or dashed line for one of them so that you can see both colors. Otherwise, they're just going to overlap. Depending on which one you do first, the other one is going to be overridden. Anyways, so these two expressions are equal, which is not very easy to see right away. But if you do a little bit of manipulation, you realize they're the same. Now, let's go ahead and approach this expression from a different angle. So we have 10 to the power log x squared and x to the power log x. Now, I want to show that these two expressions are actually equal. How could I do that differently? So here's what I can do, a property that is very helpful. If you have a to the power log b with base a, then this is equal to b. Make sense? In other words, these two bases cancel out. They're both bases, right? Why does this happen? Because what you can do is you can go ahead and set this equal to x, and then log both sides base a, and then this is going to become that, and this is going to be log x with base a. Now, obviously, you could move this to the front. That would give you log b with base a times log a with base a, which is 1, so you can cancel it out, equals log a with base, log x with base a, right? So what does that tell you? Oh, by the way, I made a mistake here. This is supposed to be log b with base a. And now notice that these two expressions are equal, right? So from here, we can safely say that x is the same thing as b, but we called it x, now you can call it b. Make sense? So that's a really nice property, and we're going to use that here. But how do you use it? That's the million-dollar question. So let me rewrite my expression.
你如果在吃东西的时候忽然觉得它有一个短暂尖锐的疼痛，那可能就是
Don't hesitate to write things down over and over because that's going to help you see things. And it'll be a good practice. It'll help you remember some formulas and identities and properties and so on and so forth. Anyways, so to be able to use that property, and obviously in the special case, a to the power log b with base a, notice that these a's are the same. What happens if the base is 10? Then you're going to get something like this. But we don't always write base 10, so we might as well just write it as 10 to the power log b, which is b. So log and 10 will cancel out. Make sense? So now we're ready to apply this property. We can write this as 10 to the power log x to the power log x, because log x squared is just log x times log x, right? Isn't it? And then we're going to use our super duper magical formula. What is 10 to the power log x? It's equal to x. So this becomes x to the power log x plus x to the power log x is equal to 20. Since you have the same thing twice, that's going to give you x to the power log x equals half of 20, which is 10. Now at this point, again, you have a couple different options. How do you solve this problem? You can use substitution if you want. You can set log x equal to t, and then from here x becomes 10 to the t, and 10 to the t becomes 10, and 10 to the t squared equals 10 to the first, and t squared equals 1, and t equals 1 plus minus 1, and then you can go to this to find x. Or you can just, I think the second method for this one is easier. You just log both sides and you're pretty much done, because then you can bring this to the front, right? That would give you log x times log x equals log 10, which is 1, by the way, because 10 to the power what number equals 10? The answer is 1. And from here we get log x squared equals 1, and this means log x is 1, or log x is negative 1, which means again x equals 10, or 1 over 10, 10 to the power negative 1. As you see, there are so many ways to get the answer. Whichever one you like the best, you can go ahead and choose. All right, so that's pretty much what this video is all about. And you know, just make sure you know these properties again are famous. The property of the day is if you have a to the power log b with base a, then the a's cancel out and you end up with b, to be or not to be. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
胶原大红瓶5胜肽胶原力3倍 up， 弹润紧致。Olay 专研科学护肤，一直努力，你的年轻不必费力。
Hello everyone. In this video, we're going to be solving a Diophantine equation. We have x squared plus x equals y squared, and x and y are integers. So this is called the Diophantine equation. We're not looking for real solutions because obviously there would be infinitely many real solutions to this equation. We only have a single equation but 2 variables. So let's go ahead and take a look. I'll be presenting 3 different approaches, and let's start with the first one. Before we kind of start talking about the first method, I want you to notice something. If you go ahead and set the y equal to 0, then you basically get x squared plus x equals 0. This is just a particular solution. And then from here we get x times x plus 1 equals 0. And this gives us x equals 0 or x equals -1. This means that there are 2 x values for single y value. And this basically gives us 2 ordered pair as solutions. So we have 0, 0 and -1, 0. All right, let's go ahead and take a look at it from another perspective. Now, I'm going to go ahead and try to parameterize this thing. I can go ahead and actually factor x times x plus 1 as I did here before I substitute anything. So let's go ahead and start with this again, x squared plus x equals y squared. And then I'm going to factor out the x. Now, in order for this product to be a perfect square, because y squared is a perfect square, right? X plus 1 needs to be a perfect square times x. Why does it have to have x? Because we only have a single x, and we need to multiply it by another x to make it x squared, and then anything else that's a perfect square will work. But we do need at least one x. So x plus 1 can basically be written as x times t squared, where t is an integer. Okay? So that gives us something real cool. By setting x plus 1 equal to xt squared, we're able to solve for x. Let's go ahead and do it. X plus 1 equals xt squared. Let's subtract x from both sides. Xt squared minus x equals 1. Factor out x, you get t squared minus 1 equals 1. Don't forget, t is an integer. We can divide both sides by t squared minus 1 as long as t does not equal 1 or -1. Obviously, that's not going to work because, as you can see here, if t is 1 or -1, we get x times 0 equals 1, which is impossible, right? That equation has no solutions. So, under those conditions, t does not equal plus minus 1. We can go ahead and divide, and we get the x value as a parameter, or in terms of another variable, which we call a parameter. And then y is just what? How do you find y from here, right? Well, y squared is equal to x times xt squared. So let's go ahead and work that out here. Y squared is equal to x times xt squared. But x times xt squared is just x squared t squared. Great. From here, we get 2 solutions. Y is either tx or y is -tx. Awesome. We're going to check both. But we do have a value for x in terms of t. So if x is equal to this, then if y is equal to tx, then it's just going to be t over t squared minus 1. And in the other case scenario, y is just going to be -t over t squared minus 1. Again, these give us the solutions. But which t value is going to work? Remember, we had minus 1. But x times xt squared is just x squared t squared. Great. From here, we get 2 solutions. Y is either tx or y is -tx. Awesome. We're going to check both, but we do have a value for x in terms of t. So if x is equal to this, then if y is equal to tx, then it's just going to be t over t squared minus 1. And in the other case scenario, y is just going to be -t over t squared minus 1. Again, these give us the solutions. But which t value is going to work? Remember, we had set y equal to 0. Now, if you look at this equation very carefully, 1 over t squared minus 1 can only be an integer because x is an integer, remember? X is an integer. In order for this to be an integer, t squared minus 1 needs to be an integer. But t also needs to be an integer because y is equal to t times x, right? Well, actually, y equals not t times x, but let me see what we found. Y equals tx or negative tx, exactly. So if t, I was thinking about can t be square root of 2 because t squared minus 1 is going to be an integer, but that's not going to work because then y will not be an integer. So we do need t to be an integer as well. And the only integer for which 1 over t squared minus 1 is an integer is t equals 0. So for t equals 0, we get the same values as before. Okay? So that's pretty much the first method. And now let's go ahead and take a look at the second method. And then you're going to let me know which method you like the best. Now for my second method, I have x squared plus x equals y squared. I'm going to use a really cool manipulation. And that is multiplying both sides by 4. So here's a general strategy. If you do see x squared plus x and you're solving a diaphanted equation, definitely 99.9% of the time, multiply both sides by 4 because that's going to help you only. So if you multiply both sides by 4, we get the following. 4x squared plus 4x is equal to 4y squared. And then how do you proceed? We want to turn the left-hand side to a perfect square. So I'm going to go ahead and add 1 to both sides. And that's going to give me 4x squared plus 4x plus 1 equals 4y squared plus 1. And now the left-hand side can be written as a perfect square, 2x plus 1 squared. And 4y squared can also be written as a perfect square because it is 2y quantity squared plus 1 completes the process. Now, if you look at this very carefully, if you've done a little bit of algebra before, hopefully you're going to be able to notice how much algebra is used for number theory because this problem actually belongs to the number theory domain. Anyways, hopefully you see difference of two squares. Let's subtract the 2y squared from both sides, and then we'll be able to factor this, which is nice. A squared minus b squared can be factored as a plus b times a minus b. This is one of the most important, I think, famous formulas in math. I would say Pythagorean theorem, this one. A couple other ones are super duper important. And this is just one of them. Now, this expression can be factored into 2x plus 1 plus 2y and 2x plus 1 minus 2y from difference of two squares, and that's equal to 1. Let's go ahead and arrange these terms a little bit. Write it as 2x plus 2y plus 1, kind of like in standard form. And then 2x minus 2y plus 1, and the product is equal to 1. Now, it's very good to get 1 actually here because 1 can only be factored in two ways. 1 times 1 and negative 1 times negative 1. So let's go ahead and look at each case. Case by case, we're going to solve this, right? So the first case is going to be 2x plus 2y plus 1 is equal to 1, and 2x minus 2y plus 1 is equal to 1. Now, what does that give me? Actually, if you add these equations up, 2y is going to cancel out. You're going to get 4x equals 0, which means x equals 0. And then if you plug in 0, you're going to get y equals 0. So you're going to get 0, 0. We call this 0 0 elde var 0. Okay, hopefully you can find out what that means. And then the other scenario is 2x plus 2y plus 1 is equal to negative 1. And the other equation also equals negative 1. And then from here we get pretty much something similar, but this time y is going to be 0, but x is not going to be 0. We're going to get negative 1, 0 as before. So far we found two solutions to this diaphanted equation in the integer world, and those are 0, 0 and negative 1, 0. Now, we're going to go ahead and take a look at the third method, which I think is very interesting, and this is probably one of the most common methods for these kinds of problems, but you never know. It kind of depends on the problem. And here's the third one. So we're going to go ahead and write this our equation and subtract y squared from both sides, and we're going to turn this into a quadratic in x. It is quadratic in x, right? Because we have x squared and x. So we can use the quadratic formula, and it's just awesome. Negative b plus minus the square root of b squared, which is 1, minus 4ac, which is going to be plus 4y squared. And in order for x to be an integer, we first have to get an integer outside the radical. So the expression inside the radical needs to be a perfect square, and that's just perfect. So let's go ahead and set the discriminant equal to z squared, because if that's the case, then we might get an integer. It's not guaranteed, but we still need to check. And from here, guess what? We find difference of two squares again. But this is a lot simpler than the other method, because this is very easy to factor. Z plus 2y, z minus 2y equals 1 again. We get the same scenarios. If z plus 2y is equal to 1 and z minus 2y is equal to 1, from here you get 2z equals 2, which is z equals 1, and y equals 0. All right? Z is just a dummy variable. We don't care about it, so it's not important. But y equals 0 will obviously give you the x value if you just plug it in, right? If you plug in y equals 0, you're going to get negative 1 plus minus 1 divided by 2. And again, that's going to give you the negative 1 and 0. So there's going to be two x values, negative 1 or 0. And if with the other scenario, which is z plus 2y equals negative 1 and z minus 2y equals negative 1, this one is kind of interesting. 2y is going to cancel out. 2z equals negative 2 is going to give you z equals negative 1. And if you plug in z equals negative 1, you can basically find the y value from one of these equations. Like if in the first equation, you're going to get y equals 0 again. So it's just going to repeat the same thing. In other words, there are only two solutions, and those are going to be negative 1 comma 0 and 0 comma 0 to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and
24시간 쇼핑할 수 있는 대형마트 까르푸와 대만의 스타벅스 그리고 공항까지 지인이나 가족들에게 선물하기 위한 대만에서 추천드리는 기념품 18가지를 빠르게 소개해드립니다. 시럽은 하는 편이 감고 화장가 타이베이 시내의 소품샵이나 용캉제의 유명한 상점들도 방문해봤는데 크기나 모양에 따라 진미 홍샤오 맛이 있고 마라 맛이 가장 3개가 들어있고 전부 다 한 번에 넣어 드시거나 레토르트 파우치만 마지막에 넣어 드셔도 됩니다. 파우치에는 실제로 소고기가 들어있어 퀄리티도 꽤 좋은 편이고 맛있어서 구매해서 드셔보시면 좋을 것 같아요. 다음은 구미 초코볼입니다. 까르푸에서 많이들 구매하시는 등 많이 사 박스는 2012년 과일 맥주로 처음 선보이며 현재까지 많은 사람들이 통과지 나는 구매해봤는데요. 또 망고 가능하니 꼭 참고하셔서 알뜰하게 쇼핑하시면 좋을 것 같아요.
오빠가 잘 가고 있지?
네? 여기 아니야. 문이 열려서 그냥 내린 거 아니야? 공주의 취향. 남자를 만나서
요즘 다 줬어.
엄마 이것도 크림치즈. 오빠.
엄마들하고 되게 비슷해.
Hello， 大家好，我是沃提，将介绍百万牙宁和 13.24B 5大上分神阵后呢，今天要来介绍的是杀五 3C， 帮助你脱离没有阿里、没有伊泽也没有凯特琳的绝望时刻。我之前有跟大家分享过我的 Flex 只是拿到了 S 级，这个位置大家通常是 C 到 A 居多，甚至还有看过 D 的，我有时候呢也会掉到 A 啦。这个东西虽然不影响积分排名，但我觉得它是一个很好检视自己哪里不足的小工具。有兴趣呢，大家也可以自己到 TFT Tools 搜寻自己的 ID 就能够找到了。杀五社啊，是我最近打泰夫美服得到的一个体悟，就是不管哪个伺服器呢，都是疯狂卷。TFT Tools 搜寻自己的 ID 就能够找到了。杀五社啊，是我最近打泰夫美服得到的一个体悟，就是都是疯狂卷超粉阿里拼多，还有新冈一泽啦，还有凯特琳这样子的一些后排 C 位，但我大多时候都是挺飞的。有常关注我实况或是看我影片的人，应该或多或少都是有看到这件事情。就是我很常就是玩阿里，然后奇怪怎么阿里一张都刷不到，或者是迟迟都没有办法2星。甚至我在玩新冈一泽的时候，也很常是刷不到凯特琳，也刷不到一泽，我就非常吐血。反正撞阵啊，我一定是被撞烂的那一个。虽然有时候可能不是阵容问题，但玩冷门阵呢，总是会提高2星的几率。我也一直在想说，怎样才能更好去对付当前的热门阵容，像是阿里啊、一泽啊这一些的。于是我换位思考了一下，如果说我今天是在玩超粉阿里的那个人，那我会比较讨厌遇到哪一些阵容、哪一些打法，于是就得出了这个结论，分享给大家。如果看完影片还是不会，就真心推荐一定要去找人教学，这是最快的上分捷径。我们有非常多的学员呢，已经上了钻石大师，这些我们教上大师的已经超过10位了，就更别说翡翠钻石的绝对是超过40位。教学后学员平均水平大约都是落在翡翠到大师之间，其实我们比较多都是教上钻石大师了，因为蛮多翡翠跟钻石的人来找我们教学。而如果你是刚接触战棋的新手玩家，我就更推荐你一定要找人教学，你会省下非常多的时间成本。可以趁有优惠赶紧下单，剩下最后2天就要结束了。现在2场可以现折400，5场可以现折1050，非常划算。之前就有人先去找过8391教学，然后才来找我们教学，就发现我们的品质更好，而且也更便宜，福利也是更多的。因为现在下单的话，你不只可以免费进入我们的战棋 VIP 群，还可以收到烫金的实体卡片，也能提前看到战棋的上分攻略，更可以认识到非常多的大师精英玩家，还有很多战棋的知名实况主也都在我们的群组里。预算有限没关系，加入一推会员也可以解锁战棋的图文攻略，或是简单帮一个赞，影片看到完都是非常大鼓励，感谢你们。好，这套阵容的组成就是会有约瑞科、维尔格纳尔、魔豆、阿卡丽、尼可、莉莉亚以及死哥，基本是5杀5射3 KDA 3超粉2处刑。目前版本较流行阿里新冈的体系，新冈就是包含那个刚刚有介绍到凯特琳啊、静啊，然后伊泽啊、露西恩啊这种，所以杀五色算是比较偏冷门的4费阵，适合呢常常抽不到阿里2星或者说伊泽的玩家。当其他人在内卷阿里啊、伊泽、凯特琳这些角色的时候，我们就可以从中找到一点出路，挤进前4名。尤其是红 B 啊卡莉，我真的觉得是非常高的一个上限所在，完全有机会暴打现在最热门的 T0真商转阵容。因为现在守望阿里的出现，阿里有的时候呢，他会去拿科枪这件装备，一则也会有人去和正义，或者说他们都会去拿一些吸血类型的增幅，像说吸血迷信嘛，几乎都会有回复，非常难处理哦，所以就会需要红比阿卡丽去为敌方后排挂上减疗的效果，再配合死哥一发技能，很好轻松带走他们的后排。也因为这套呢是一个3C 阵哦，所以它能够抽的主秀选择也是非常多元的。你可以去拿的是阿卡丽、死哥还有维尔哥。如果你是拿维尔哥的话呢，就推荐你最好是去拿疾风的一个羁绊，会是比较好的。这段部分阿卡丽可以去拿红 buff 无尽加上正义。我其实一直以来呢都还蛮喜欢给阿卡丽带上无尽这件装备，就是我觉得他正义拿1个就够了，然后另外2个呢可以是输出装备。而红 buff 的话呢，它是最优先级的，因为它可以确保给敌方后排去挂上减疗的一个效果，这样呢死哥才不会一波炸下去的时候没有把他炸死。因为你会发现死哥有时候他的伤害就是差一点点，然后他就可以把他带走了。这 个时候呢，红 buff 它会继续燃烧，依靠着这个燃烧的效果呢，增加减员的速度。这个的话就是可以去拿精进红 buff 那使噬性神盔、电刀法宝、破防者这类的一些魔攻装备。比较推荐的就是双启动装，然后再加上一件输出装备。例如说，今天你可以先去出精进加上红 buff， 或者是精进加上纳什，这样也是可以的。对，如果说今天你阿卡丽也一直刷不到，就是有的时候也没办法，那个阿卡丽就一直不来，那这个时候我的红 buff 就会先给到我们的死哥身上，然后阿卡丽呢可能再去拿剩下的一些斗士装备。所以我有时候也会遇到一个状况，是我的这个死哥呢跟威尔哥都已经2星，结果我的阿卡丽还在1星，我觉得这样还是蛮强的。有时候阿卡丽1星啊，但是他带着一些比较暴力的装备，其实对后排的威胁也是蛮巨大的。如果今天真的是没有双启动装备的话，那你也可以带的是精进加上电刀，电刀就是算半个启动装备。好，再来就是魔斗，它会是我们的一个主要坦克，你可以给它皇冠啊、后战以及龙爪等等的坦型装备。那副 C 的话呢，就会是维尔哥，可以给它嗜血加上夜色。夜色渐渐装呢还蛮适合维尔哥，就是防止它暴毙。大家可以把维尔哥就是想成劫这样子的一个存在。征服装置的选择上呢，最推荐的就是直接拿3战力，所以最好就是3个都直接拿战力型的征服装置。金属头啊、治愈灵球、珠光莲花、碰撞测试、酷热打击、魔控、吸血迷信、理想主义以及王者馈赠。那玩这阵的先决条件呢，就是建议前期要优势开局，就是要尽量去用保险浪的一个打法。
你的银行贷款通过了，恭喜你！
太专业了，这么快！
因为我们是得去上8等抽牌的。这个过渡部分呢，这套是一个以4费为核心的营运阵容。前期优势开局保险打法，可以多多善用超粉的体系下去过渡。第一个你可以去做的事情呢，就是选用超粉加上 KDA， 还有加上任意的后排，库奇拉、安妮、珊娜、凯撒、瑟拉芬巴的这些角色都是蛮不错的选择。再没有的话就是吉因克斯，可是因为吉因克斯他没有办法去带精进这样子的装备，所以前面这几只角色会是更好的选择。这边也给大家一个参考建议哦，就是你可以先用莉莉亚、凯能、塔里克加上珊娜再去过渡。那第二种状况呢，就是你可以运用卡桑蒂这张主秀牌来去搭配后排的 C 位。卡桑蒂真的是非常强势的一张主秀，我们在之前呢就有跟大家分享过这个主秀排行榜，当时就有把卡桑蒂归类在 S 级的主秀，所以这就是如果你有真的常常来关注我们的影片的话，真的会得到非常多别人可能得花1-2个星期才能够体悟出来的理解。过渡这种东西呢，其实是蛮看当下的一个竞派，比较需要注意的就是前后排均衡的分布。而6等的话呢，通常你可以去搭的就是3星钢3超粉，通常3之3前有3星钢的话，我都会视情况去吃一下这个3星钢的奖励，除非说今天你可能是正在连胜的一个状况，那我就会舍弃星钢，我就会想说，那我就直接上最强战力就好了，反正我是有连胜奖励的，我何必再去看那个3星钢，甚至还要冒着损失可能10滴、20滴血的一个风险。再来就是你今天的血线可能就已经非常低，这个时候呢，你是不太适合再去吞星钢的，因为你会越蹲脚越麻。所以这边也给大家一个参考点，就是通常我3之2血线可能已经低于60的话，我就不会硬要去吃这个星钢，会变成在3之2或者说3之5的时候找任意一个我可能可以去玩的赌狗阵容去止血，拼个前4名。如果说你今天是正常顺风或者说保险的一个对局，这个时候我们就可以在3之5的时候去升上7等。升上7等的话，需要观察的一个条件只有一个，就是你升等之后有剩余30块的经济。这个东西应该很好算出来吧，因为你只要把箭头移到购买经验上面，它就会告诉你说升等需要花费多少的经济。这个升等啊，我觉得是非常关键的一件事，因为很多人不会在这边升等。我真的有用心观察这件事情，就是大师以下的玩家几乎不会在这边升等，通常只有在打连胜的人呢会在这边升等。但我现在的理解是，就算我不打连胜，我也会在这边升等。这个升等啊，其实会蛮影响到游戏的节奏，甚至是你的血量。虽然说我们亏了2到4块钱的一个利息，但是可以多10到15滴左右的血量，你可能就多了1-2波的容错。我觉得这个是非常值得的一件事情。但是我觉得有些人就是少做了这一手，然后就少了一个大师的排位。那这里7等的话呢，就基本上我们不会去刷牌，就是补上一些相关的羁绊，然后或者说强力的单卡划水即可。什么样的角色算是强力单卡呢？我觉得乌尔加特还有魔斗都是非常强的卡，而且呢这2张卡都非常好去凑到羁绊。 你看沃尔加特呢，它可以跟赛特去搭上冲撞者，然后如果你是用超粉过渡的话，它也可以跟纳尔去搭上冲撞者的羁绊。而魔斗的话就更不用说，守望者就是随便凑都凑得出来的。接着等到4之1或者说4之2的时候，我们会去升上8等。如果你真的很想要在4之1升上8等的话，我自己是不太推荐在4之1去升上8等，因为你升上8等最好要有40块的一个经济量是会比较好的。而你4之1升的话，通常你都只剩下20-30块的一个经济，很容易抽崩，真的非常容易。所以如果你不是超级天胡局，或者是说升上8等之后，你知道自己不会有40块的一个经济，那就不要在4之1去升上8等，还是推荐你就在4之2去升上8。因为呢，萨五色的体系老实说也不会有人跟你抢。升上8等之后呢，就是要大刷牌转正，更换我们的主秀，组出完整阵型即可大功告成。接着我们来讲一下辩证的思路，因为会有3个主秀可以抽，又有蛮多种羁绊组合的搭配，所以就是给大家更多参考的一个方向。我其实最推的呢，就是抽到这个阿卡丽的主秀，不管你是抽到这个 KDA 或者说雏形都可以，因为呢它能够直接忽略掉敌方的前排，然后直接杀到后排，快速减员输出位的一个血量。接着呢就能配合死哥的技能一波带走，这件事情真的是百试不厌，你会得到非常愉悦的快感，就会心里想说哈哈你在玩凯特琳啊。因为凯特琳呢通常都要站在底角，他毕竟是打最远的一个敌方英雄，所以蛮多人凯特琳会站在底角，而他们在没有161的时候呢是完全防不住你的。甚至我觉得现在大家已经没有那种很高的防阿卡丽意识了，就很常我随便摆个位置就能够轻松带走敌方的一个 C 位。再来就是抽到维尔哥的一个疾风主秀的话，那你就可以去凑到3疾风的羁绊。维尔哥主秀呢会比较需要夜色来去保命，不然呢很容易直接被伊泽啊还有阿里这些角色直接做头打死。而且维尔哥呢也会比较需要军能法医跟俄语这类的一个降物防装备。这个是杀五色的死哥或者说维尔哥，最推的呢还是死哥哦。最后阵容的上限呢就是在于后期你可以去补上维尔哥跟约瑞科的装备，那你就可以达到完美的3C 位伤害直接灌满。有机会升上9等的话呢，就可以依照你的主秀羁绊去补出7杀5射，或者说4雏形以及5 KDA， 或者说你可以直接去补上一些强烈的单卡，例如说161啊、凯因啊、基亚纳这一些5费的单卡都是 OK 的。而如果说你今天是有杀5射转的话呢，是完全可以给到阿卡丽的身上，就可以去开出7杀5射，对阵容来说是非常巨大的提升，因为杀5射转的阿卡丽呢真的很强。反之，如果是没有转职又抽到杀5射主秀的一个状况下呢，我们就是通常要等到上到9等的时候才能开到7杀。不过我觉得大家是真的不用病态的去追求7杀这件事情，其实你只要搭出5杀5射加上3战力的增幅，就有非常非常高的强度了。这一点可以完全印证在我这一场的实战当中。OK， 这一把呢就真的是救急天崩局啊！我在4之2刷牌的时候是完全刷不到一张的死哥，甚至是维尔哥的，就是完全一支后排的这种主 C 呢都刷不到，我就只有刷到这一张阿卡丽的主秀而已，除此之外没有任何的4费后排主 C， 所以呢我就先用伊泽当做我的一个后排 C 位，反正就是有什么牌就用什么牌。而且大家可以看到这一场崩到什么一个局面，就是我到5之5的时候，我的死哥竟然都还没有办法2星，差不多呢这一场就是要老8的值了。你看这个波比这么会敲哦，还好真的是吓死。这边如果没打赢后，第8的就是我我真的是刷到头壳快破掉了。OK， 然后你看这边5之6刷完，死哥依然没有2星，救急离谱局。OK， 这边对上的呢，就是他已经9等了。你看这种人是怎么样？他们9等已经要来把我们给杀爆了。就没有想到我们维尔哥还有阿卡丽一个天秀操作，维尔哥打了一个7000多的伤害。所以其实我觉得维尔哥在有军能法医或者说俄语这样的破防装备的状况下，其实他的伤害是非常足够的。这里遇到的话呢，也是伊泽。其实就现在新钢的人玩的非常多啊，刚刚那一家也是算就是新钢的体系，只是他是养镜的，大家应该看得出来吧？就是现在有些人他升上9等，他就是会去找镜这样 样子的一个 C 位。那我们为什么不上9呢？没办法，我们锁不住血。然后到了6阶段，我们的死哥才去升上2星，所以我觉得我的打法是真的非常适合非洲人的。我相信大多数的玩家应该是不大可能5阶段完全刷完，然后你的主要后排 C 位还不2星的，非常难发生的一件事情。我就是那种阿里不2星，死哥也不2星的一个玩家。那对面的话，这个就比较难处理了。为什么呢？因为他唢呐2星了，然后这一场也是假人局。在面对假人的状况下，死哥阿卡丽或者说这种维尔哥的 C 位其实会比较难发挥一点。对面的话，它就是很明显的是一个新纲95的体系，它就是呢前面先去养伊泽啊这些的角色，然后后期再去转玩是什么露西恩啊、镜啊，但其实它都是同一个体系，就是新纲95。这边在打他还没有9等，他8等就5费2星了。好，但合理的是他有一个复制器，还行，他就是85，他就是那种8等就能刷到5费2的。OK， 他比较神，再更神、更进阶一点点，那也没办法，好不好？就人家会刷牌。对面的话呢，就是这个乡村处刑的体系。那现在有一些人他可能也会去玩什么守护处刑啊、高处刑的一个体系，反正大同小异，就是处刑的体系。那这边看过来呢，就又更95了。这个人是真的9等的95，好不好？这个人是唢呐2星，然后161 2星，西格斯2星。这边的话，我觉得其实会比较难处理的。我自己的话，我会把维尔哥先放中间，先把他们第一波的血量先打低，接着死哥再炸大，还有就是靠着我们的阿卡丽疯狂的去收割，我觉得这样是一个比较好的搭配。这个转盘里面呢，有这个杀无赦转，算是还蛮不错，但其实老实说，不需要这个杀无赦转。我们刚刚的这手打5杀5赦，大家有看出来吧？5杀5赦哦，不刚需7的就能这么强。那这边的话，其实也不用卖这个阿卡丽，因为其实用阿卡丽就能够完全打爆它了。但我是觉得啦，换一下也好，反正就测试一下每个东西的强度，所以我这边就换成了约瑞科。OK， 可以看到我们维尔哥他先去帮后排的 C 位先挂了一波的减疗，有没有减疗先挂到了之后，这个死哥再配合收大，就是形成一个非常完美的 combo。他这里为了去躲他的基亚娜，所以我稍微换了一下摆位，就不要让对面的基亚娜去偷到你的 C 位装备。所以这件事情呢，就是会有一些小技巧，大家还是得去提防一下的哦。结果最后他被那个小鬼杀死哦，这边真的是可以再细看一下这个操作。就是我觉得约瑞科也是非常强大，大家也可以看到哇，如果真要讲的话，这好像是一个4C 的阵容。就是你中期的话呢，你可以去给到维尔格，像是说嗜血者啊、夜色这样子的装备。然后如果你的红 buff 真的没人带的话，那红 buff 也可以给到维尔格，因为它毕竟是一个群体伤害。维尔哥呢，他是一只角色，我觉得他更像是一个功能角，他的技能呢是会让对方的角色附带一个增伤10%，这个增伤的效果呢会持续5秒钟。而杀无赦的效果就是即使一名英雄，他就可以释放这个摇滚魂嘛，然后会有一个额外的增伤效果，可以增伤25%。而5杀无赦的话呢，它也有一个额外的增伤是30%的额外伤害。所以杀无赦呢，真的可以说是一个为伤害而生的羁绊，大家可以尽量去拿一些战力类的增幅。那今天video到这里喽，感谢老板的收看，拜拜。
I am back competing in chess. It was literally only like a month ago since my last tournament, but I love playing over-the-board chess tournaments, and I've set up a New Year's resolution for me to play more over the board and compete more in 2024. So I'm just starting early. I am right now in Stockholm, my hometown, competing in probably the biggest Swedish international chess tournament that there is. I am at World Cup, which is a huge chess tournament with a bunch of grandmasters and people from all over the world coming to Stockholm in winter when it's literally like -10 degrees outside to compete at chess. Can you imagine? Like, there's people from so many warm countries. They're right now in Sweden in December. I am sorry for them, but I am very happy because I'm from Stockholm. So it's really fun to see such a big tournament, you know, at home, pretty much. So I am participating in Rilton ELO, which is the like second division of the tournament for people that are rated under 2200. And my starting rank is number 8. So my goal for this tournament is actually to win it. Sounds pretty crazy, but if I do a really good tournament, I do think that I can play above like a rating of 2200 if I'm like playing my best chess. So I do think that there's a possible chance for me to win the tournament. But obviously, today I played round number 1 and I was facing a 1700 who was lower rated than me, but I had not really had time to prepare before my game because I had to set up my stream. I am live streaming all of my games and you can catch that on my Twitch channel. But I had a lot of tech issues and I was running around for 4 hours before the game and it was complete chaos, and I managed to fix everything 5 minutes before the game started. But what happened was that when I went up to the tournament hall, I was like, okay, stream is good. A game of chess, Anna? We're playing chess today? So I had no idea who I was facing. I had not prepared at all. And I was terrified of going to a game unprepared. It is always very, very, very scary. But I was playing against 1700 Alexis Duault. I'm sorry. He's French. It's a French name. I don't know how to pronounce it in French. Please let me know how to pronounce it in French. But I was facing him and I had the black pieces. So he started by going 1d4, I went d5, and he played the Queen's Gambit. Now, I went e6 to defend the pawn, and here I actually thought for a little while, which wasn't really that necessary, but I absolutely hate it when my opponents do what I typically do. And so here, I was really scared that if I went like knight up, that he would capture my pawn and that we would enter a Queen's Gambit, like decline, but like the exchange variation. I play this with white and I think it's awesome and I don't like facing it. So yeah, I didn't want to face that. So instead I went c6. And I used to play this when I was a little kid and call it the triangle opening, but it's not called the triangle opening. But anyway, so he brought out his knight and I developed my knight too, and then he went bishop g5. And here in this position, I just stopped the pin. He went e3, and all of this is like really standard stuff, and I just developed my other knight. Now, my idea here was that I was actually waiting for him to basically develop his bishop because I wanted to be able to take this pawn with a tempo, because now he's forced to move his bishop again. So now it's like this turn that he did was for nothing, pretty much. That's the idea. So he captured back, I went b5. The idea here is that I get a lot of like queenside space, but he gets a little bit of center. So I'm trading my center for getting like some space on this side of the board. And here I was feeling pretty comfortable, but I went for this move b4. And spoiler alert, my mom would end up roasting this move. She thought this move was not good. The idea of this move is that I wanted basically to... my idea is that I want to go c5. I want to defend this pawn and I want to go c5. But obviously I cannot go c5 right now because then this pawn is hanging. So I thought either what I do is that I go like bishop b7, a6, c5, or I go like b4, bishop b7, c5. And I didn't want him to be able to go a3 and ever stop my move b4. So yeah, that was the reason for me going for it now. But I think this is a mistake. But he ended up moving his knight. And now I did a little bit of another creative move. I did an Anna move, okay? I love chess when I feel like there's like no boundaries to it. When I feel like I can do exactly whatever I want, that's when I love chess the most. And I was feeling very creative today. So I was like, okay, Anna, you don't really know this theory. You probably should, but you don't really know this theory. Let's be creative. And so I play this move, queen a5. Now, what is the idea of this move? Well, the idea of this move is that I'm immediately threatening b3 check. So let's say he does something random, then I have right now b3 check. And then, well, if he ends up going check, going back, then I'll be able to bring up my bishop. So that is the idea with that. But I'm also stopping him from going knight c5. I was kind of scared of him trading and then going knight c5. I thought that this was the most important key square of the whole board. And I was also just kind of wanting to stop him from going knight e5. So these were my different ideas here. I thought that my queen was pretty good placed, and I also thought that I'm stopping the knight from moving because then the bishop is hanging, and I'm stopping this queen because then this knight is hanging. So he ended up just castling, which was a good move, and I was thinking here for a while, but I ended up developing my bishop because I wanted to threaten going c5 and then taking this because then this bishop would end up being weak. So he went bishop f4, and I was like really relieved when he did this move. Like, I genuinely think I looked at him and just like breathed out because it was a very passive move. It was once again the same thing as before, that he basically wasted now a tempo in the opening by going here and then going back. And this may seem like little, but this extra turn actually matters a lot. And at this point, we had both thought for a very long time. I had 44 minutes left on the clock, and so did he. So I was feeling kind of good because at certain parts of the game, it felt like he thought it was boring that I was thinking for so long. Like, I would like think for like 20 minutes and he would like look at me and then he'd like look around, and I was like, okay, you know what? I know that I'm taking a long time. But then he thought for a long time too, and then I felt a bit better because I was like, okay, now we're on the same boat. So I was feeling pretty good about that. But I castled here, and he did once again a pretty slow move, which was h3. And now all of a sudden I felt like I had gotten, like, because he hadn't done anything crazy, like he hadn't like immediately tried to stop my plans, I realized that I now had time to do everything that I wanted to do. So my plan the whole time was just to push the c5 pawn. I knew that if I'm able to push c5, I am not going to be worse. I may not be better, but it will be an equal position at least. So I really wanted to push this and open up my bishop, because this bishop right now sucks. It's like really bad, right? So I thought, do I go c5 now? The reason I didn't do it was because I saw that if c5, he has takes, and after takes, I wanted to take with the bishop, takes, and knight takes, I realized that he had bishop d6. And I'm not really sure exactly how this is, because there's like a lot of like different things, but I really wanted to keep my knight, and so I didn't want to allow him to trade the knights, even though these pawns end up being very weak. I should be better here, but this is the reason I didn't do that. So instead of going c5 immediately, I started by moving my rook to d8. Now, here I really thought that he was going to go something like a3, or something like knight d2 to try to move the knight around, or even knight e5 I was looking at, but he ended up just going queen c2, and I once again felt like I was gaining some time. So I now went c5, finally. I was able to do the move that I had like been waiting for so long, and here I felt like it was definitely equal, and it felt like a position that I was very comfortable in. So he took, and I decided, because I wanted to keep a little bit of the play, I wanted to be able to have my knight being very annoying, I decided to take with the bishop, because I thought that this would be harder for him to play, kind of. And especially when I was facing someone that was lower rated, I was also trying to do moves that I thought might be difficult for him to handle. So here, after I took back with the knight, I'm threatening to take his bishop. I'm also kind of threatening to take this knight, although I'm not sure if I wanted to take it because I also want to keep my bishop. This bishop is not very strong. So he ended up going bishop e2. And now I was looking for a long time, and I really wanted to bring up this bishop and like threaten the queen. But then I realized that he can move up his queen and try to trade it, and I did not want that. So I brought in my rook, and I was really happy because now both of my rooks were in the game.
你如果在吃东西的时候，忽然觉得它有一个短暂尖锐的疼痛，那可能就是敏感性牙齿，这就是一个警讯，你要去处理它。我会推荐舒酸定，帮助舒缓敏感性牙痛，它确实的有效。
And he went queen b1. And when he did this move, I was like jumping out of happiness. I was like, okay, Anna, we got this. I was like giving myself a pep talk. I was like, okay, Anna, we got this now. Like, these light squares were so weak in my opinion. They were so weak. I really thought he would do something like rook d1. I think this is what he needs to do. But when he moved this queen, it was like his third move that was kind of slow. I just immediately realized that I could threaten his queen. And when I did this move, it almost seemed like he hadn't expected it. It almost seemed like he was, you know, kind of confused. Maybe he missed it. So he moved his queen, and now I brought up my knight. The idea here is that I am actually just completely winning because he's gonna lose his rook. He cannot now, I'm threatening his queen. He cannot move his queen to either here, 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 or here, or like anywhere, because then I'll be able to take this bishop and take the queen. He must capture my knight, but then when I capture his bishop back, his rook is trapped. So here I thought that he was gonna go a3 to at least try to win a pawn. The idea here is that after I take the rook, well, he's gonna be able to win this pawn because I cannot capture back because my queen is hanging. But he did a move that kind of made me jump out of my seat too. He went knight d4. And obviously, my initial thought is fork. But it's not a fork because he has this move threatening my queen in the meantime. So I'm not gonna win a piece. But here, actually, I ended up capturing the rook. The best move is for me actually to just go e5 immediately. And the idea of this is very nice, is that after queen b5, after he moves his bishop, I am forcing a queen trade. And being an exchange up when the queens are off the board is just almost an instant endgame win. Especially in this position because I'll be able to bring up my rook. So this is almost just an instant win in this position. But instead, here, I started by capturing his rook. And then after queen takes e5, now we had the same thing as before, but we didn't have a queen trade. So this is still very much winning for me, but I only had 12 minutes on the clock, and I still had to do 17 moves before I got extra time. So we both had little time. I was still feeling pretty confident, but yeah, I was a little bit worried about my clock. So he went bishop here, pinning my knight, and I knew that I was completely winning, and everything that I wanted to do was that I wanted to dominate the board. I wanted to make sure that his rook could not come in and take space. So I thought as long as my, rooks and queen are in the center of the board, I'll be doing fine. I wanted to go a5, but I was scared of his queen coming in, which was a stupid thing to be scared of, but sometimes we're scared of ghosts that don't exist. And that was me during the game, especially when you're low on time. So I went rook d6, I just brought up my rook, and then he brought up his queen. I didn't really see what the idea of this was. I was actually kind of scared of him going like f4. But he just went queen here, and then I went a5. And now he took, I cannot take with the pawn because then I have a check and I lose the rook. I ended up seeing that. So I took with the rook, and now he brought his rook in. And now I started to get a little bit worried because it was like everything that I wanted was to have a lot of space, and I didn't have space anymore. But I just had to make sure that I didn't get back rank checkmated. So I gave a little bit of air for my king, which is called in chess terms Luft, because it's the German word. And it's also the Swedish word, Luft. Yeah, if you want to sound like a pro chess player, you can say Luft, and then people will know that you're really good at chess. Add that to your vocabulary. Okay, so I gave a little bit of air for my king, right? And he brought up his queen, and now I only had 4 minutes left, and I saw a lot of pawns hanging, so I started shaking here. I started feeling like, okay, Anna, like, let's not mess this up, like, come on, Anna. I was just trying to be ultra sharp focused on the game, no distractions, nothing else, just focus. So I ended up here going rook c2, threatening this f2 pawn. I knew that I needed to give him some counterattacks. He offered a trade of rooks, I took it, and now I didn't really know exactly how to defend everything, but I thought, okay, let me threaten checkmate in one, because I'm low on time, and I wanted to gain some extra time. And he went e4, which I thought was a mistake, because now I had this move, rook d6, threatening the knight, threatening the piece, defending the pawn. My queen is attacking the pawn. If he moves back his queen, well, then this is very passive, and then I will have no problem at all, because then I'll finally take activity and the d-file. So he has to move the knight, but then I'm very important that I do not take this pawn immediately because then I lose the rook. I have check. After the king moves, I take the pawn, and now I knew that I was winning because I didn't see how he was going to stop the threat of queen f4 check. I didn't know he was going to stop it. The only way he could stop it was with the trade of queens. But I calculated, and I knew that the trade of queens was winning for me because my rook would be able to pick up these pawns. So he went check. I forced the trade of queens. And here, it looked like he was going to resign. But he did not resign. So he played a few more moves, took my pawn, I took this one, and now the key move, he went here so that if I take this pawn, I take this. The key move here was f3. And in this moment, my opponent resigned. And I was so happy after the game. It's like always whenever a game finishes, you just feel like you're like on a cloud, like you feel like you are like in another planet and you're finally landing back on Earth. And that's what I felt like. I had been so focused for the past like 10 moves of my game because I had been so like, you know, stressed with my time that I was so happy. I could like finally breathe out. And I was so happy to get the win. And maybe you've heard on my voice that I won the game. I don't know if it was possible to hear on my voice. I didn't sound so sad, but I did not want to hide it. I am very happy that I won the first game of the tournament. I was facing a lower rated opponent, but these games, like, you need to win them. It's not just, oh, I'm facing a lower rated insta win. No, you have to win the games. And I'm actually really happy with the game because I ended up having an accuracy of 95%, which I think is really good. So my opening was pretty bad, but after that, the game was really good. So I'm really happy with the game. And after the game, I told him, good luck with the rest of your tournament games. And he said, what? And I was like, oh no, please do not think that I'm saying something bad. I'm trying to be nice. I was like, good luck with the rest of your tournament games. And he was like, no English, no English. And I was like, I'm sorry, bye. So that was a bit awkward. But yeah, super fun to be back playing over the board chess. I will be playing every single day for the next 9 days. Apart from the 1st of January because, you know, New Year's the 31st. But apart from that, I'm playing every day. So we are back with daily YouTube videos, daily recaps of every single one of my rounds. But not only that, if you want to see the game live and see my mom's commentary, and you don't want to watch that on Twitch, I will link my second YouTube channel, Anna Kremling Extra, where I'll be publishing all of my VODs so that you can see when all of this happened live. So I'll be putting that in the description box down below as well. But thank you so much for watching this. I am so excited once again to be back competing. This is my favorite thing in the world to do. And my goal for this tournament is actually to win it. Yes, I know it sounds crazy, but I am ranked 8th, I think, in the starting rank. So I have a chance of winning this tournament if I do a good job. I also obviously want to get over 2100. So rating is a goal, but apart from that, I want to win this tournament. So wish me luck for tomorrow's round, and let's see if we can do it. Okay, thank you so much for watching. Bye!
Suppose we are given a circle with radius r, so that its area is a equals pi r squared. Let's paint half the circumference blue, and then roll the circle 1/2 turn, so that we are left with a line of length pi times r. Extend the line by the length of the radius r, and we get a semicircle of diameter pi r plus r. Then create the half chord from the bottom of the original circle to the larger semicircle and call its length x. Connecting the ends of the diameter to the end of this half chord results in a right triangle according to Thales' triangle theorem. Consequently, the two subtriangles with side length x are similar. This implies that pi r over x equals x over r. Therefore, x squared equals pi r squared. We can also use the half chord to create a square with side length x so that its area is a equals x squared, but x squared equals pi r squared, and thus we have constructed a square with the same area as the given circle. That is to say, we have squared the circle.
一个离不开钱的频道。瑞士拥有全球顶级风景以及升级社会福利制度，是许多人置产的梦幻选项。这里月薪中位数高达6600瑞郎，却是持有住房比例最低的国家之一。整个瑞士只有约40%家庭有房，对比之下，欧美都有70%左右的有房率。本期就要来聊聊坐拥高薪的瑞士人为何买房比例这么低，是不想买还是买不起？位于中欧的瑞士境内有举世闻名的阿尔卑斯山，罕见的自然美景让这里被誉为世界公园。然而打开瑞士地图，山脉地形占了70%国土，导致多数人民必须挤到剩下30%土地居住，也因此种下了高房价的种子。跟其他全球地区相比，瑞士城区的房价相当惊人，按单位价格排名全球房价前5高的城市，第2跟第5名就是瑞士第1大城苏黎世以及第2大城日内瓦。如果从成交总价来看，瑞士独栋房屋的中位数将近120万瑞士法郎，换算成台币高达4285万元。公寓虽然相对便宜，但中位数也要台币2750万元。虽然房价这么高，但瑞士人赚得更多。该国月薪中位数高达6600瑞郎，就算跟单位房价最高的香港相比，瑞士人的薪水仍是香港的2倍以上。这让人不免好奇，瑞士人纯论收入，应该不至于买不起房，为何该国有房率如此低落？这背后的其中一个关键就在于该国非常严格的贷款门槛。瑞士本地人想买房必须先通过2道关卡，首先是总价2成的头期款，其中至少1成要是现金，以100万瑞郎的房子为例，买方至少要先准备10万瑞郎现金。虽然对比当地薪资，这笔金额并不算高，但在瑞士生活，即使是本地受薪阶层，存钱也不算容易。一份针对外派员工的调查显示，全球生活成本前10昂贵的城市，有多达4个都在瑞士。进一步细看当地家庭的开支，根据官方统计，一个每月收入1万瑞郎的家庭，扣除税负、养老金、保险、居住水电成本以及日常开销，理论上只能存下1700瑞郎，这还没算上奢侈开销或小孩的教育钱。更糟的是，并非每个人的月薪都能跨过存钱门槛。假如在零售业工作，月薪就只有中位数的1半，也就是3000多瑞郎，这就很难存得下钱。因此，瑞士年轻人的处境也跟其他地方的青年类似，若收入不够高，家庭资产不够，身上还背有学贷，就很难走上买房之路。刚刚说到了头期款只是瑞士买房的第1关，真正困难的是第2关，收入的负担能力。当地银行要核发一份贷款，月收入至少要达到利息的3倍以上。除此之外，银行为了规避风险，采用的不是现行利率，而是用大约 5% 的利率，再加上预期维修费用的摊提，这会让标准拉高到 6% 左右。我们简单试算一下，如果想要在瑞士买到中位数77万瑞郎的公寓，首先要支付2成的头期款，剩下的61万瑞郎换算 6% 利息就是37000元。按照第2关条件说的，收入至少要超过利息的3倍以上。也因此，若想购入房价中位数的公寓，年收入至少要超过12万瑞郎，才有机会通过贷款。更糟的是，在许多实际案例中，银行的门槛还高过3倍。反观当地年薪中位数就只有8万瑞郎。换句话说，要想靠一己之力买房，多半连贷款的资格都没有。也因此，对瑞士年轻人来说，大家好，这里是穷奢极欲，一个离不开钱的频道。先前介绍过台湾大缺工的现象，有人可能会好奇企业为何不加薪抢人。事实上，数据显示，制造业和服务业这4年来都有调高薪资，但问题在于台湾经济常年成长，实质薪资却有长达15年的冻涨期。虽然近年开始调薪，但吸纳较多就业人口的休闲服务和餐饮业薪水仍比不上总体均值。高房价和高物价更让钞票变薄，工薪族开始出现体感贫穷的现象。摊开台湾的经济数据，这里和贫穷似乎沾不上边。光以贫穷率来看，台湾不到美日韩等先进国家的1成，人均 GDP 在2022年超越南韩，拉近与日本之间的距离。 但对台湾的上班族来说，这些光鲜亮丽的数据无法代表真实的心情。有民间机构和媒体在2023下半年提出体感贫穷的说法，用来描述台湾总体经济成长与人民所得脱钩的情况。这个说法是真的吗？打开官方记录，政府多次调涨基本薪资，多年来名目经常性薪资也不断增加，过去15年间的涨幅约30%。但从2003到2018年，台湾扣除通膨影响的实质经常性薪资却几乎没有成长，直到2019年才出现明显涨势，而且行业之间的薪资落差相当明显。有媒体统计，在2023年中旬，各行业的实质薪资对比，发现吸纳最多就业人口的服务业，薪资只有全体的80%。虽然住宿和餐饮业因为缺工而调薪，但休闲服务及教育业的薪资却出现下滑。与此同时，全台房价在20年间平均上涨3倍，物价也频频上调，生活开销和薪资水准之间的落差，便是台湾工薪族体感贫穷的根源。至于背后的原因有很多，包括产业外移和升级缓慢，以及学历通膨等因素，而且低薪带来的问题远比降低眼前的生活水准还要严重。我们都知道，理想的薪水曲线会随着年龄增加而上升。假如这件事情没有发生，收入将无法应对。
Brothers, that's a given. No one shall be the
Job's done, job's done. Job's done. Job's done.
It has begun. No one shall be the wiser. That's a given.
Job's done. Job's done. Job's done.
Out with it. I am prepared.
Et merci.
Upgrade complete. My bidding. Upgrade complete. Out with it. Enlighten me. I am prepared. My bidding. I am prepared. Begun. Job's done. My bidding. Upgrade complete. Job's done. I didn't. Upgrade complete. Out with it. Great, great. Job done. Great, great. Has begun. I do. Job done. I am
We've done similar problems before. I don't know if you remember. I hope I haven't made this problem before. I don't think I did. But anyways, we have x cubed equals x squared plus x plus 1/3. And I'll be presenting two methods. And remember, yesterday, I think it was yesterday, right? There was a Diophantine equation. Hopefully you've seen that video. X squared plus x equals y squared, right? And I told you, whenever you see this expression, especially when there's a perfect square on the right-hand side, it makes sense to multiply both sides by 4 because that's going to give you a perfect square and eventually difference of two squares. There's quite a few problems in number theory that uses this trick. But wait a minute, we see that again. So should we multiply both sides by 4? No, not here. Because you have an x cubed on the left. If you do multiply both sides by 4, it's going to mess up everything. So we should use something else. But guess what? That's going to be the second method. So let's proceed with the first one. All right, for my first method, I'm going to go ahead and try to use cubic formula. This will be incomplete, so bear with me because that's going to be a little painful. I just want to show you how to start it, and then you can hopefully continue from there. And by the way, I kind of set it up for you, and I'll show you what that looks like. So first of all, we're going to put everything on the same side except for the constant. And then we should replace x with something. And here's how you can do it. To find the number that you're replacing x with, look at the general case. Let me go ahead and write it down for you. In this case, our goal is to get rid of x squared because that will be a depressed cubic, a cubic in depression, but it's good because it's easier to solve. Now, to be able to get rid of the x squared, we need to replace x with some other variable plus, now here we do have a b as the coefficient. We kind of need to negate it, which is a negative b. And I could kind of write it as a minus sign, minus b over 3a. So the 3 comes from the power. If with fourth power, the cortex, you're going to use 4. But that's the general idea. And if you actually really do plug this in, you're going to notice that x squared disappears. or in your new equation, you're not going to have a y squared. I should probably state it that way. The quadratic term disappears, not x squared. Of course, x squared disappears because you're replacing x with something else, right? Okay, cool. So let's see how we can proceed with this. But notice that with for our particular case, we should be using x equals y minus -1/3, which is y plus 1/3. And that brings us to this equation, because when you replace x with y plus 1/3, you're basically writing it like this. Make sense? Replace x minus 1/3 with y, and you're going to understand why I said that. Make sense? Okay, so that's going to be my conversion after some work. This is going to turn into something that looks like this. I'm going to have y cubed minus 4/3y equals 20/27. Because you're going to have other constants, you're going to combine them. That's what you're going to get. Okay? And then I need to consider the infamous or famous identity that I've been using all the time. If you subtract 3ab times a plus b from a plus b cubed, you get sum of two cubes, which gives us the cubic formula. Because if you replace a plus b with y and 3ab with 4/3 and a cubed plus b cubed with 20/27, you get the same equation. There you go. You got yourself a system. So the system is ab is equal to 4/9, a cubed plus b cubed is equal to 20/27. And if you cube both sides, you get a cubed b cubed equals 64/729. And then by substitution or whatever, you'll get a cubic equation in a cubed or b cubed. And then you can solve it. But guess what? That's going to be really painful. So all you have to do is you kind of need to replace b cubed with this minus a cubed, and that's going to be a lot of work again. Okay? Anyway, so
全新雅诗兰黛白金级黑钻酥露逆时焕颜霜，长寿肌。
what do you do with this? You just continue and solve it. But I'm going to show you something much, much better than this, because this problem was designed for the second method. Don't be mad at me. I want to show you alternative solutions. I hope you don't mind, because everybody is different, everybody learns differently, and hopefully knowing multiple solutions will help you in the long run. Okay, so this is called, or this could be called, a sneaky equation. Remember I told you with the Diophantine equation, we multiply both sides by 4 because that helps. With the cubic case, you don't multiply by 4, you multiply by 3. Okay, let's do it, and then I'll tell you why we did that. When you multiply both sides by 3, you're going to get 3x cubed on the left, big deal. On the right-hand side, though, we're going to get 3x squared plus 3x plus 1. It's amazing. I should probably say not just when you see x squared plus x, but x squared plus x plus 1/3. So that combination is just amazing and rare, but it's very helpful. So what does this look like? Take a minute, think about it, and what does this remind you? If you said x plus 1 cubed, you got it. If not, that's perfectly fine. Don't worry about it, because you will get it in time. Now, let's go ahead and add x cubed to both sides, and on the right hand side we do get a perfect cube, and that's just perfect. Remember, in other problem we got a perfect square that was helpful. This time we got a perfect cube because the left hand side is also a cube, which is nice. So now we get the following from here. 3x cubed plus x cubed is equal to 4x cubed. And the right-hand side can be written as x plus 1 to the 3rd power. So both sides are perfect squares? Meh, not really, but we can manage. 4 is not a perfect cube, but we can make it. We can kind of write it as the cube root of 4x to the 3rd power, and there you go. It's kind of like a semi-perfect cube, right? It's good enough. Now, since we have cubes on both sides, we can actually cube root both sides, and when we do, we're going to get a real solution. What about the other solutions? They're complex, because there's no way you can get other real solutions from here. That kind of shows it. But I'll show you how we can get those complex solutions. Let's go ahead and write this as follows. Cube root both sides, cube root of 4x equals x plus 1. Since I want to solve for x, let's go ahead and bring the x terms on the same side and use factoring. We're going to take out x, cube root of 4. Oh, that's such a weird cube root of 4 minus 1. Now notice that the cube root of 4 is greater than 1, so this is going to be a positive answer. Great. And x becomes 1 over cube root of 4 minus 1. If you're really obsessed and you wanted to rationalize the denominator, you could just multiply by the conjugate. And to see what the conjugates are, you could basically call this a. And you're basically looking at a minus 1. You should multiply it by a squared plus a plus 1 to get a cubed minus 1, which is going to get rid of the radicals. So what is a squared? It's going to be the cube root of 16, and then plus cube root of 4, plus the cube root of, wait a minute, not cube root of, it's just 1, divided by that. But the product at the bottom is just going to be a cubed minus 1, which is 4 minus 1. So this whole thing is going to be a 3. There's a 1 here, so the answer is going to be then the cube root of 16 plus the cube root of 4 plus 1 all over 3 in the most rationalized denominator form. Make sense? Okay. Now, how do you get to the complex solutions? To get to the complex solutions, you kind of have to consider the way we factor this. So let's go ahead and get back to that. Cube root of 4x cubed minus x plus 1 cubed equals 0, right? Well, because we subtracted it, it should be 0. Awesome. Now, left-hand side is a difference of 2 cubes. So let's go ahead and factor it that way. Cube root of 4x minus x minus 1. And that kind of disappeared because with the first method, we just cube root both sides. So we didn't do this. But the second factor is just going to be, remember, from a cubed minus b cubed, you're going to get a minus b, and then a squared, which is cube root of 16x squared, plus ab, which is cube root of x, cube root of, not cube root of x, cube root of 4x multiplied by x plus 1, and finally x plus 1 squared, and the whole thing is equal to 0. Now, the first one we already know that's the only real solution. The second one is going to turn into a quadratic, and I believe you can do it. You're going to multiply, you're going to get an x squared, you're going to get another x squared from here, and you have an x squared, combine them, turn it into a quadratic, and guess what? The solutions are going to be complex, but they're going to be very complicated. All right, so let's go ahead and take a look at the graph first. The real solution, well, why did they write it that way? Isn't that weird? Well, you can kind of simplify this hopefully, and you'll get the answer. And these are the complex solutions. Oh man, this is just crazy. And let's go ahead and take a look at the graph of these two functions, a cubic graph and a parabola. By the way, I don't think this parabola touches the x-axis, but it's very close. And then they intersect at a single point, which gives us the real deal. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye. Exponential equation with different bases. We have 2 to the power x plus 2 to the power x equals 3 to the power x. Do you think we can find the solution by guess and check? This is probably going to be difficult. Now, we did a similar problem where the bases were different, but that time, if you remember a few days ago, the base on the right-hand side was a 4, and 4 is 2 squared, so that made the problem a great deal easier. But this one is a little different because 2 and 3 are not powers of each other. So here's what we're going to do instead. We're going to use the same strategy, combine the 2 to the power x's together, and then go for the solution. I'm also going to show you how we can get complex solutions. And at the end, I think we're going to be looking at a graph. All right, so I'll be sort of presenting two solutions. So let's go ahead and start with the first one. So for my first solution, I'm going to write the 2 to the x plus 2 to the x as 2 times 2 to the x equals 3 to the power x. And then since this is 2 to the first power, I can go ahead and add the exponents. Remember the rule, if you multiply two powers, you add the exponents. But of course, they have to have the same base. If the bases are different, you can't do it. And if the exponents are the same and the bases could be same or different, then you could basically multiply the bases and use the common exponent. So those are pretty much the standard rules for multiplying exponential expressions in the real world, okay? Now, what do we do then? We combine these into 2 to the power x plus 1 equals 3 to the power x. Again, at this point, you can try to guess and check, but I don't think you're going to find the answer by guess and check, unless you're very, very good at this. Now, here's what we're going to do. We're going to bring down the powers by using the natural log. So, if you natural log both sides, ln here and ln here, x plus 1 is going to be a coefficient and x is going to be a coefficient. So, this is going to look like x plus 1 multiplied by ln 2, or natural log of 2, equals x times natural log of 3. I'm not writing the multiplication symbol. You can, but I think it's understood that these two expressions are multiplied. Now, remember, our goal is to solve for x. So, you kind of have two options here. You can isolate the x term, but since we have it on both sides, I don't think that's going to be possible. So, it looks like we have one option, and that will be distributing the x plus 1. If you distribute x plus 1 over ln 2 or vice versa, you're going to get x times ln 2 plus 1 times ln 2 equals x times ln 3. Now we have x's on both sides, and you don't want that because we're going to solve for x. Let's go ahead and put the x's on the same side. By subtraction, we get ln 2 equals x ln 3 minus x ln 2. I could write this on the left-hand side, but that's okay. You should be able to solve either way. Now, at this point, what would you do? Since x is a common factor, you should definitely take the x out. And then divide both sides by ln 3 minus ln 2 to get the x by itself. So let's go ahead and divide both sides by ln 3 minus ln 2. ln 3 minus ln 2. That's too long. Let's go ahead and shorten it, and we should be good to go. And these should be equal, and I think this is an extra one. Okay, here we go. Now ln 3 minus ln 2 obviously is not 0 because 2 and 3 are not equal. Oh, come on, you knew that, right? And then we can basically go ahead and cancel that out, and x becomes this. But let's go ahead and write the x because it kind of keeps bugging me. We should have x on the left, unless you're kind of writing right to left. That's a different story, right? Anyways, this will be the x value. So, is that the only solution? Well, that seems to be the only real solution. Of course, at the end or towards the end, we're going to go ahead and complexify this expression so we can find complex solutions. Okay? So now we have an alternative. Let's go ahead and call that second method. Now we have 2 to the power x plus 2 to the power x equals 3 to the power x. By the way, I have a question for you which I'm going to pose, and later on I believe I'm going to make a video about this. And we've done some similar problems before. But my question is, at this point, if we had different bases, like all three different bases, like 2 to the x plus 3 to the x equals 4 to the x, could we still solve this problem, right? That would be a good question, don't you think? Or if we had something like 2 to the x plus 3 to the x equals the square root of 13 to the power x, or 2 to the x plus 3 to the x equals 5 to the x. Obviously, this would be pretty easy, right? Because 2 plus 3 is equal to 5. And I believe I made a short on this one. And the second one should also be easy if you really think about it. I made a similar problem a while ago, a long time ago. But the first one...
你可以的，你可以的，李书记，你可以的，可以的，你可以的，你可以的。
这是世界上最营养的洗发精，超级水果，超级营养，发质超级好。566营养对策，最营养的洗发精。
is going to be pretty interesting. Do you think we can solve this problem and find the x values without approximating, without any numerical approaches? I'm not talking about numerical analysis here, okay? Anyways, I just wanted to pause these questions and then continue with the second method. So we have 2 to the x plus 2 to the x equals 3 to the power x. So how do we proceed with that, right? again, just like before, we're going to write this as 2 times 2 to the x equals 3 to the x. But this time, instead of combining the exponents, or does that mean combining? No. Instead of using the properties of exponents to, combine these two things, I'm going to divide both sides by 2 to the power x, because that already separates the term that contains x, which is good. I don't care if x is an exponent. But this time, we're going to get something super nice. 3 to the x divided by 2 to the x. We already talked about the, what is that called? Multiplication property, but didn't talk about division. It's the same thing. If you divide a to the x by b to the x, you just write it as a over b to the x, or vice versa. And the same thing goes for multiplication, right? Okay, so those are the properties when the exponents are equal. Okay, so this means 3 over 2 to the power x equals 2. And now we can go ahead and just natural log both sides. You see, this is different from the first approach, because with the first one, we kind of wrote the 2 to the x times 2 as 2 to the power x plus 1. We combined the exponents, or added the exponents. This time, we didn't. So now, we're going to go ahead and ln both sides. Of course, you need ln to bring this x down, and that's going to give us x times ln 3/2 equals ln 2. And by way of division, of course, you're going to get x equals ln 2 divided by ln 3/2. But wait a minute, let's go ahead and compare this result to the first method. Did we get the same thing? Because this looks different. What did we get with the first method? We got ln 2 over ln 3 minus ln 2, right? Are they different? No, not really. If you use the quotient property, remember log of a over b can be written as log a minus log b. And this is true for any base, including base 10, including base e. So we can also write this as ln 2 over ln 3 minus ln 2, so our answers agree on the same thing. Make sense? Now let's go ahead and talk about how to complexify this. And then if I have a graph, I can't remember if I made one, I'll show you the graph. Okay? So how do we complexify things? What are the complex solutions? All right, let's take a look. Now we have 3 over 2 to the power x. I'm going to pick it up from here because I don't really want to do the old work again. So this is going to be equal to 2, right? That's where we left off. Now, at this point, if you're trying to find complex solutions, you can basically do two things. One, you're going to write the 2 as a complex number. What is 2 as a complex number? We can write 1 as a complex number. So let's go ahead and multiply both sides by 1, which can be written as, in the complex world, e to the power 2 pi n I. And of course, n is an integer. And what does that mean? It just means that we have a number whose argument is multiples of 2 pi, and that would basically represent 1 on the complex plane, because you're basically 1 unit away from 0, and you're on the real axis, so no imaginary parts. And this is a real number whose modulus is 1, which is itself, by the way, and the angle it makes is basically 0 or 2 pi or multiples of 2 pi in general. Make sense? Okay, we can go ahead and use natural log at this point. You could also write 3 over 2 as e to the power ln something and then go from there, but it will be the exact same thing. So let's go ahead and, because on the left hand side, we're basically talking about a real valued ln. So if you ln both sides, of course, we're going to have to deal with the complex logarithm on the right hand side. It's going to look like x ln 3/2 equals ln 2 plus, again, this is the product rule, ln e to the power something is something, so it's going to be 2 pi n I. And finally, by way of division, ln 2 divided by ln 3/2, and again, you can write it as ln 3 minus ln 2 if you want, if that's something that you like, plus 2 pi n, I'm also going to divide it by ln 3 minus ln 2, and then finally multiply by I. So that's going to be our complex solutions. There are infinitely many because n is an integer. Okay, so notice that this is nicely organized because we have the a plus bi format, which is the name of another channel that I have. Hopefully you're watching those videos on complex numbers. Anyways, In this case, let's talk about some specifics, like what happens if n is equal to 0, then you get x equals ln 2 over ln 3 minus ln 2, which is the only real solutions. But if n is equal to 1, you get a complex solution. If n is equal to -1, you get another complex solution, so on and so forth. Now, let's see if I made any graphs, and yay, I did. Okay, so the graph of 2 to the x plus 2 to the x is the pink one. Is that pink or purple? I think it's pink. And then notice that first, it's kind of above the blue line or the curve, but then after a while, it's actually going to grow a little slower. The other one is going to exceed it because it has a higher base. And the solution, the real solution, is right here as you've seen before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.